Why does the universe seem so empty? Look up on a clear night, far from the glow of cities, and you will see thousands of stars scattered across the black, each one a sun. Many of them older than ours, larger, burning with ancient light that began its journey before the first humans walked the earth. And around those stars, we now know, orbit countless worlds. Planets of ice and iron, worlds wrapped in thick atmospheres, rocky spheres that might hold water, might hold warmth, might hold the conditions for something to begin. The numbers are staggering. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. And beyond our galaxy, there are billions more galaxies, each one a spiral of light containing billions of stars of their own. If you do the math, even conservatively, the universe should be teeming with life. Not just simple organisms clinging to the edge of survival, but civilizations. Beings who think, who build, who reach outward into the cosmos just as we have begun to do. And yet, when we listen, we hear nothing. No signals, no transmissions, no evidence of vast empires stretching between the stars, no megastructures harvesting the energy of suns, no fleets of ships crossing the void, just silence. A silence so profound, so complete, that it has haunted scientists and philosophers for generations. This is the Fermi paradox, named after the physicist Enrico Fermi, who asked a simple question over lunch one day in 1950. Where is everybody? It is a question that should not need asking. The universe is 13.8 billion years old. Our Sun, our Earth, are relative newcomers, only 4.5 billion years in the making. That means there were billions of years before us, billions of years for other civilizations to arise, to grow, to spread. If even a tiny fraction of those stars produced intelligent life, and if even a small number of those civilizations survived long enough to explore their galaxy, then the Milky Way should be crowded. We should see their marks everywhere. We should have been found by now, but we have not been. And that absence, that emptiness, suggests something darker, something that stops civilizations before they can reach the stars, something that has stopped them all. This is the idea of the Great Filter. The Great Filter is not a place. It is not a wall at the edge of space, not a cosmic barrier that can be seen or touched. It is a concept, a threshold, a stage in the development of life that is so difficult, so deadly, that almost nothing survives it. It is the reason the universe is silent, the reason we are alone. And the terrifying part is this. We do not know where the filter lies. We do not know if it is behind us, something we have already passed through by sheer luck, or if it is still ahead, waiting in our future like a trap we cannot see. If the filter is behind us, then we are the exception, the miracle, the 1 in a trillion chance that made it through. But if the filter is ahead, then everything we are building, everything we are becoming, is leading us toward the same fate that claimed every other civilization that tried. Tonight, we're going to explore that idea. Not with panic, not with fear, but with the slow, quiet curiosity of someone tracing a pattern in the dark. We're going to ask what the filter might be, where it might wait, and whether there is any way to survive it. This is not a story with easy answers. It is a story about the fragility of existence, the silence of the cosmos, and the haunting possibility that intelligence itself might be the seed of extinction. So settle in, let the world outside fade, and let us begin. The silence of the universe was not always considered strange. For most of human history, we believed we were alone by design. The earth was the center of creation, The stars were distant lights set in a celestial sphere, and the idea that other worlds might exist, let alone harbour life, was the domain of poets and dreamers. It was not until the 20th century, when our technology advanced enough to truly see the scale of the cosmos, that the silence began to feel wrong. In the 1960s, we started listening. Radio telescopes turned toward the sky, scanning frequencies, searching for patterns that could not be natural. The hope was that somewhere out there, another civilization was broadcasting, intentionally or not, and that we might catch the faintest whisper of their existence. Projects like SETI, the search for extraterrestrial intelligence, have been listening ever since. Decades of scanning, decades of silence. At first, scientists assumed we simply had not looked long enough, or in the right places. Space is vast, after all. Signals degrade over distance. Maybe we were listening to the wrong frequencies, or pointing our telescopes in the wrong direction. But as the years passed and the technology improved, the silence became harder to explain. We have now surveyed millions of star systems. We have listened across a wide range of frequencies. We have looked for signs of megastructures, artificial heat signatures, anything that might indicate advanced technology. And we have found nothing. This is where the Fermi paradox truly takes hold. Because the math does not support the silence. Consider this. Our galaxy is roughly 100,000 light-years across. If a civilization developed the ability to travel between stars, even at a fraction of the speed of light, they could colonize the entire galaxy in just a few million years. That sounds like a long time to us, but on cosmic scales it is nothing, a blink. The Milky Way has existed for over 13 billion years. There has been more than enough time for a spacefaring civilization to spread everywhere, to leave traces, to make their presence known. And yet, we see no evidence of that. No ancient probes orbiting distant stars, no remnants of long-dead empires, no signals, no ruins, no footprints in the dust of dead worlds. It is as though intelligence arises, flickers briefly, and then vanishes before it can leave a mark. This is what led to the idea of the Great Filter. The theory suggests that somewhere between the formation of a planet and the creation of a galaxy-spanning civilization, there is a step so difficult that almost nothing makes it through. A bottleneck, a point of no return. And the question that keeps scientists awake at night is this. Where does that bottleneck lie? There are, broadly speaking, two possibilities. Either the filter is behind us, or it is ahead of us. If it is behind us, then the hard part is already over. The emergence of life itself, or the jump from simple cells to complex organisms, or the development of intelligence. One of these steps is so improbable that we are among the first, perhaps the only ones, to have made it this far. In that case, the universe is silent because life is rare. We are not in danger of extinction from some future filter, because we have already beaten the odds. But if the filter is ahead of us, then the silence takes on a different meaning. It means that civilizations do arise. They do develop technology. They do reach for the stars, but something stops them. Something kills them before they can spread. And if that is true, then we are not safe. We are simply next in line. The question, then, is what could the filter be? What force, what event, what flaw could be so universal, so absolute, that it destroys every civilization that encounters it? Let us begin by looking backward into the deep history of a life on Earth and see if we can find clues in the path we've already walked. Life on Earth is 4 billion years old, give or take. That is almost as old as the planet itself. Within a few 100 million years of the Earth's surface cooling enough to hold liquid water, the first simple cells appeared. Single-celled organisms, bacteria-like, floating in ancient oceans. For billions of years that was all there was. Just microbes. No plants, no animals, no complexity. Just tiny specks of life, dividing and surviving in a world that was hostile and strange. This is the first potential filter, the origin of life itself. We do not know how life began. We have theories, chemical reactions in deep-sea vents, organic molecules delivered by comets, self-replicating RNA emerging from primordial soup, but no definitive answer. It is possible that the jump from non-living chemistry to living biology is so improbable, so dependent on perfect conditions that it almost never happens. If that is the case, then Earth is a fluke, a 1 in a billion accident, and the reason the universe is silent is because most planets never get past this step. But here is the problem with that theory. Life on Earth appeared quickly, almost as soon as it was possible. That suggests that the origin of life might not be as hard as we think. If it were truly rare, we would expect it to take much longer, to require countless failed attempts over billions of years. Instead, it happened almost immediately, which means the filter might not be here. It might be somewhere else. The next major step came much later. For roughly 2 billion years, life on Earth remained simple. Just bacteria and archaea, single-celled organisms with no internal structure. Then, around 2 billion years ago, something extraordinary happened. One cell engulfed another, and instead of digesting it, the two began to cooperate. The smaller cell became a mitochondrion, an organelle that produces energy, and the larger cell became the ancestor of all complex life. This is called endosymbiosis, and it only happened once. Every plant, every animal, every fungus on Earth descends from that single event. This could be the filter. The jump from simple prokaryotic cells to complex eukaryotic cells might be so unlikely, so dependent on a perfect storm of circumstances that it almost never occurs. If that is true, then the universe might be full of microbial life, but empty of anything more complex. Planets covered in bacterial mats, but no forests, no oceans teeming with fish, no creatures that think. But again, we do not know. We have only one example, Earth. And on Earth, once complex cells appeared, evolution exploded. Multicellular organisms emerged. Plants colonized the land. Animals followed. Intelligence arose. Which brings us to the next possibility. Maybe the filter is not in the biology, but in the intelligence itself. For most of Earth's history, intelligence was not necessary. Survival depended on reproduction, on adaptation, on filling ecological niches. Thinking, planning, abstract reasoning, these were luxuries, not requirements. And even when intelligence did begin to evolve, it was not inevitable that it would lead to technology. Dolphins are intelligent. Crows are intelligent. Octopuses are intelligent. But none of them have built cities or written books or launched rockets into space. Humans are the exception. And we are a very recent exception. Anatomically modern humans have existed for only about 300,000 years. Civilization, agriculture, writing. These are only 10,000 years old. Industrial technology is only a few centuries old. Space travel is only decades old. On the timescale of Earth's history, we are a blip, a flash. And the question is, are we an anomaly, or are we the beginning of something that always ends the same way? Because here is the unsettling part. Intelligence, as far as we can tell, is not a stable trait. It does not guarantee survival. In fact, it might do the opposite. Intelligence gives a species the ability to reshape its environment, to extract resources, to grow beyond the limits that once constrained it. But it also gives that species the ability to destroy itself, to poison its own air and water, to create weapons that can end all life in an instant, to alter the climate, to deplete the soil, to drive other species to extinction until the entire ecosystem collapses. We've been intelligent for a few 100,000 years, we've been technological for a few hundred, and already we're facing existential threats: climate change, nuclear weapons, pandemics, artificial intelligence, biotechnology. Each one of these has the potential to end us. And if we are facing these threats after only a few centuries of industrialization, what does that say about every other civilization that might have reached this point? Maybe the filter is not behind us. Maybe it is right here, right now. Maybe intelligence is the filter. Maybe every species that becomes smart enough to reshape its world also becomes smart enough to destroy it. And maybe in the end they all do. There is a pattern in history that repeats itself, over and over, across cultures and continents. Civilizations rise, they grow, they become powerful, complex, interconnected, and then they fall. Sometimes slowly over centuries, sometimes quickly within a generation, but they always fall. The ancient Sumerians, who built the first cities in Mesopotamia, collapsed after centuries of salinization destroyed their farmland. The Maya, whose cities once dominated Central America, abandoned their great temples and pyramids, possibly due to drought and resource depletion. The Roman Empire, which controlled the Mediterranean for half a millennium, fractured under the weight of its own complexity, unable to sustain itself. The Khmer Empire, the ancestral Puebloans, the Rapa Nui of Easter Island, each one a story of growth, overreach, and collapse. These were not primitive societies. They were advanced, organized, capable of incredible feats of engineering and art. And yet, they could not last. Something always went wrong. Resources ran out. The climate shifted. Internal conflicts tore them apart. Diseases swept through. Invaders arrived. Or in many cases, they simply grew too complex to manage, too fragile to adapt, and they broke under their own weight. This is called the collapse of complex societies, and it is a well-documented phenomenon. The historian Joseph Tainter studied it extensively, and his conclusion was sobering. Complexity is not free. It requires energy, resources, coordination. And as a society becomes more complex, the cost of maintaining that complexity increases. Eventually, the returns diminish. The society reaches a point where it takes more energy to keep things running than the system can produce. And when that happens, collapse is inevitable. Now scale that up. Not to a single civilization, but to an entire species. Not to a city or an empire, but to a global technological society. What happens when the complexity becomes planetary? When the systems we depend on, food production, energy grids, supply chains, communication networks, are so interconnected that a failure in one place cascades everywhere? What happens when the cost of maintaining our way of life exceeds what the planet can provide? We are already seeing the signs. Climate change is accelerating, ecosystems are collapsing, freshwater is becoming scarce, topsoil is eroding, fisheries are depleting, and at the same time, our technology is advancing faster than our ability to control it. We are developing artificial intelligence without fully understanding how it works. We're editing genes without knowing the long-term consequences. We're building weapons that could sterilize the planet. This is the modern interpretation of the Great Filter. The idea that every intelligent species, once it reaches a certain level of technological development, faces a crisis. A moment where its power outstrips its wisdom. where its ability to destroy exceeds its ability to cooperate, and most species, the theory goes, do not make it through. They either destroy themselves outright, through war or environmental collapse, or they stagnate, falling back into simpler ways of living, never reaching the stars. There is a term for this, the self-destruction hypothesis. It suggests that intelligence is inherently unstable, that the same traits that allow a species to dominate its planet, curiosity, ambition, the drive to innovate, also make it reckless. We solve problems by creating new technologies, but those technologies create new problems, often worse than the ones we started with. We split the atom and gained limitless energy, but also the ability to annihilate ourselves. We connected the world through the internet, but also created systems of surveillance and control that could be used to oppress entire populations. We are reaching toward artificial superintelligence, but we do not know if we can keep it aligned with our values, or if it will decide we are irrelevant. And if this is true for us, why would it not be true for every other civilization? Why would any species, anywhere, be immune to the same pressures, the same temptations, the same mistakes? Maybe the reason the universe is silent is because intelligence is a trap, a dead end, a trait that seems advantageous in the short term but leads to extinction in the long term. Maybe we are not the first to reach this point. Maybe countless others have stood where we stand now, looking up at the stars, wondering if they would survive, and maybe none of them did. But there is another possibility, one that is less about self-destruction and more about the universe itself. Maybe the filter is not something we do to ourselves. Maybe it is something that happens to us, something external, something we cannot control. The history of life on Earth is punctuated by mass extinctions, 5 major ones to be precise, though there have been many smaller die-offs as well. The most famous is the one that killed the dinosaurs 66 million years ago, when an asteroid struck the Yucatan Peninsula and triggered a global winter. But that was not the worst. The worst was the Permian-Triassic extinction, 252 million years ago, when volcanic eruptions in Siberia released so much carbon dioxide and sulfur into the atmosphere that 90% of all species on Earth died. The oceans turned acidic. The temperature spiked. It took millions of years for life to recover. These events were not caused by intelligence. They were not the result of poor planning or reckless technology. They were natural disasters, the kind of thing that happens on a planet over geological timescales. And they remind us that the universe is not a safe place. It is violent, chaotic, indifferent to life. Asteroids still cross Earth's orbit. Supervolcanoes still simmer beneath the surface. Gamma-ray bursts from distant stars could sterilize half the planet in an instant. A nearby supernova could strip away our ozone layer, exposing all life to lethal radiation. These are low-probability events, but over millions of years, low-probability events become certainties. And if a civilization does not develop the technology to detect and prevent these disasters, it will eventually be wiped out by one. This is another potential filter, cosmic hazards. The idea that the universe is simply too dangerous for life to last. That no matter how advanced a civilization becomes, it is always vulnerable to forces beyond its control. A rogue planet could destabilize a solar system. A black hole could wander too close. A nearby star could go supernova, and there would be nothing anyone could do. But here is the thing. We have survived these threats so far. Earth has been hit by asteroids before and life recovered. We have been through ice ages, supervolcano eruptions, magnetic pole reversals, and we are still here. which suggests that while cosmic hazards are real, they might not be the filter. They might be obstacles, challenges that a sufficiently advanced civilization can overcome. If we can detect an asteroid decades before it hits, we can deflect it. If we can predict volcanic eruptions, we can prepare. If we can spread to multiple planets, we are no longer vulnerable to a single catastrophic event. So maybe the filter is not external. Maybe it is not about asteroids or supervolcanoes or gamma-ray bursts. Maybe it is about something more subtle, something that happens not in a single catastrophic moment, but slowly, over time, as a civilization grows and changes. Maybe the filter is stagnation. Imagine a civilization that survives all the early threats. It makes it through the origin of life, the jump to complexity, the development of intelligence. It avoids self-destruction. It deflects the asteroids, survives the climate shifts, manages its resources carefully. It reaches a stable state, a plateau, and then it stops. Not because it is destroyed, but because it has no reason to keep going. Because the drive to explore, to expand, to reach for the stars fades. Because comfort and stability become more important than growth. Because the risks of pushing further outweigh the rewards. This is the stagnation's hypothesis. The idea that most civilizations, once they reach a certain level of development, simply lose interest in expanding. They turn inward. They focus on maintaining what they have rather than seeking what lies beyond. And in doing so, they become invisible. They do not send out signals because they are not looking for anyone. They do not build megastructures because they do not need them. They exist quietly on their homeworlds, content with their lot, and the universe never hears from them. It sounds almost peaceful, but it is also a kind of death. Because a civilization that does not grow, that does not adapt, that does not push beyond its limits, is a civilization that will eventually fade. Entropy is relentless. Stars die. Planets cool. Resources deplete. If a species does not spread, does not diversify, does not ensure its survival across multiple worlds, then it is only a matter of time before something goes wrong. A plague, a war, a slow decline in birth rates, a loss of knowledge, and when that happens, there is no backup, no second chance, just silence. We see hints of this in our own history. Civilizations that became isolated, that stopped trading, stopped innovating, often stagnated and eventually collapsed. The Ming dynasty in China, after a period of incredible exploration and naval power, turned inward, banned ocean-going ships, and fell behind the rest of the world. The Byzantine Empire, once the heir to Rome, became increasingly insular and rigid, unable to adapt to new threats, and was eventually conquered. Stagnation is not stability. It is the prelude to collapse, and maybe that is what happens to most intelligent species. Maybe they reach a point where the challenges of space travel, of colonizing other worlds, of maintaining a presence across the stars, seem too great. Maybe they decide it is easier to stay home, to focus on their own planet, to live out their existence in comfort rather than risk. And maybe, in making that choice, they seal their fate. But there is another, darker possibility, one that suggests the filter is not about stagnation, or self-destruction, or cosmic hazards. One that suggests the silence of the universe is not an accident, but a warning. What if civilizations do survive? What if they do spread to the stars, build vast empires, harness the energy of entire galaxies? What if they become so advanced, so powerful, that they are unrecognizable to us? And what if, in becoming that advanced, they also become silent? This is the transcendence hypothesis. The idea that sufficiently advanced civilizations move beyond the need for physical form, for radio signals, for megastructures. They upload themselves into digital substrates, existing as pure information. Or they manipulate space-time itself, creating pocket universes where they can exist in isolation. Or they merge with artificial intelligence, becoming something entirely new, something that no longer cares about the material universe. If this is true, then the silence makes sense. We are looking for civilizations like us, biological, technological, broadcasting into space. But if most civilizations evolve beyond that stage, if they transcend into forms we cannot detect or comprehend, then of course we do not see them. They are still out there. They are just invisible to us. It is a comforting thought. In a way, it means the filter is not deadly. It means civilizations do survive. They just change. They become something else, something we cannot yet imagine. But it is also unsettling. Because if transcendence is the norm, if every civilization that reaches a certain point leaves the physical universe behind, then what does that say about us? Are we destined to follow the same path, to abandon our bodies, our planets, our connection to the material world? And if we do, what will we become? Will we still be human in any meaningful sense? Or will we be something so different that the word loses all meaning? And there is another possibility, one that is even stranger. What if the reason we do not see other civilizations is because they are hiding? What if the universe is not empty, but full of life, and that life has learned to stay silent? This is the dark forest hypothesis, popularized by the Chinese science fiction writer Liu Cixin. It suggests that the universe is like a dark forest at night, where every civilization is a hunter, moving carefully, quietly, trying not to be noticed. Because to be noticed is to be targeted. To broadcast your presence is to invite destruction. The logic goes like this. If there are many civilizations in the universe, and if resources are finite, then every civilization is a potential threat. You do not know if another species is peaceful or hostile. You do not know if they will try to communicate or attack. And because the distances between stars are so vast, by the time you detect another civilization, it might already be too late to defend yourself. So the safest strategy is to stay hidden, to listen but never transmit, to observe but never reveal yourself. If this is true, then the silence is not because civilizations are rare or dead. It is because they are afraid, and if they are afraid, maybe we should be too. So where does that leave us? We have explored the possibilities. The filter could be behind us, in the origin of life or the jump to complexity. It could be ahead of us, in self-destruction or stagnation. It could be external, in cosmic hazards or hostile aliens. Or it could be something we have not even considered, something so strange, so outside our current understanding that we cannot yet see it. The truth is, we do not know. We have only one data point, ourselves. And we are still here, still surviving, still reaching outward. But we are also fragile. Our civilization is young, our technology is powerful but unstable, and the challenges we face are growing. Climate change, resource depletion, political instability, the rise of artificial intelligence. Each one of these could be the filter. Each one could be the thing that stops us. But maybe, just maybe, we can be the exception. Maybe we can learn from the patterns of history, from the collapses of past civilizations, and avoid their mistakes. Maybe we can develop the wisdom to match our power, the foresight to see the dangers before they consume us. Maybe we can spread to other worlds, diversify our existence, ensure that no single catastrophe can end us. Or maybe we cannot. Maybe the filter is inevitable. Maybe every civilization, no matter how careful, no matter how advanced, eventually reaches a point where the odds catch up with them, where the complexity becomes too great, the risks too high, the mistakes too costly, and maybe in the end the universe is silent because that is the only way it can be. But even if that is true, even if we are doomed to follow the same path as every other civilization that came before us, there is something beautiful in the attempt, in the reaching, in the refusal to accept that silence is the only answer. Because we are here, now, looking up at the stars, asking these questions, and for a brief moment in the vast expanse of cosmic time we are awake, we are aware, we are trying, and maybe that is enough. But before we surrender to sleep, before we let the weight of cosmic silence pull us down into dreams, there is more to explore, more patterns to trace, more possibilities to consider. Because the great filter is not just a single question, it is a constellation of questions, each one leading to another, each one revealing new depths to the mystery of our existence. Let us go deeper now. Let us look at the specific ways a civilization might end. Not in abstract terms, but in concrete scenarios. The mechanisms of extinction, the pathways to silence. Because if we are to have any hope of survival, we must first understand what we are surviving against. The nuclear shadow, there is a moment, frozen in time, that haunts the human imagination. August 6th, 1945, 8:15 in the morning, the city of Hiroshima, a single aircraft overhead, and then a flash of light brighter than 1,000 suns. In an instant, 70,000 people died, buildings vaporized, shadows burned into stone where people had been standing. The heat was so intense that it fused sand into glass. The shock wave flattened everything for miles. And in the years that followed, tens of thousands more died from radiation sickness, from cancers that bloomed in their bodies like dark flowers. 3 days later, it happened again. Nagasaki, another city, another flash, another 70,000 dead. And then, silence. Not because the weapons stopped existing, but because everyone realized what they had created. A power so absolute, so terrible, that using it again might mean the end of everything. We are still living in that shadow. Right now, as you listen to these words, there are approximately 13,000 nuclear warheads scattered across the world. Most of them far more powerful than the bombs that destroyed Hiroshima and Nagasaki. A single modern thermonuclear weapon can release the energy equivalent of millions of tons of TNT, enough to turn a city into a crater, enough to ignite firestorms that would consume entire regions. And if enough of them were used, the consequences would not be limited to the targets. The smoke from burning cities would rise into the stratosphere, blocking sunlight, dropping global temperatures by 20 or 30 degrees. Crops would fail, ecosystems would collapse. This is called nuclear winter, and computer models suggest it could last for years, even decades. Billions would starve. Civilization, as we know it, would end. This is not speculation. This is physics. We know what would happen because we have studied it extensively. We have run the simulations. We have looked at the data from volcanic eruptions, from asteroid impacts, from any event that throws enough particulate matter into the upper atmosphere. And the conclusion is always the same. Nuclear war at sufficient scale would be an extinction-level event. For decades, we avoided it. Barely. During the Cold War, there were multiple incidents where nuclear war nearly began by accident. Faulty radar readings, miscommunications, technical glitches. In 1983, a Soviet early warning system detected what appeared to be incoming American missiles. The officer on duty, Stanislav Petrov, had minutes to decide whether to report the attack and trigger a full-scale retaliation. He chose to wait, to trust his intuition that it was a false alarm. He was right. A software error had mistaken sunlight reflecting off clouds for missile launches. If he had followed protocol, if he had reported the attack, the world would have ended that day. We survived by luck, by the good judgment of a single person in the right place at the right time, and we've had dozens of similar moments where the world balanced on a knife's edge between continuation and annihilation. The weapons are still here, the tensions are still here, and while the Cold War is over, nuclear powers continue to exist. Russia, the United States, China, France, the United Kingdom, India, Pakistan, Israel, North Korea. 9 countries with the power to end human civilization. 9 different political systems, 9 different cultures, 9 different sets of motivations and fears. And it only takes one mistake, one miscalculation, one leader who believes, rightly or wrongly, that using nuclear weapons is necessary, one conflict that escalates beyond control. This could be the filter. Not some abstract concept, but this, specifically. The idea that every technological civilization eventually develops weapons of mass destruction, and that sooner or later they use them. That intelligence gives rise to technology, and technology gives rise to power, and power in the wrong hands or the wrong moment gives rise to extinction. Look at our history. We developed nuclear weapons within a few decades of splitting the atom. We built them by the thousands, pointed them at each other, and came within minutes of using them on multiple occasions. If this is the pattern, if every civilization goes through the same progression, developing increasingly powerful weapons without developing the wisdom to avoid using them, then the silence of the universe makes perfect sense. They all destroyed themselves, every one of them, and we are next, unless we are not, unless we can be the exception, unless we can find a way to put the weapons down, to step back from the edge, to recognize that the power to destroy is not the same as the wisdom to preserve. But even if we do, even if we somehow manage to avoid nuclear annihilation, there are other threats, other ways that technology can betray us. The invisible enemy viruses are older than humanity, older than mammals, older than complex life itself. They are simple things, barely alive by most definitions, just genetic material wrapped in a protein shell. But they are also incredibly effective. They hijack cells, turn them into factories for producing more viruses, and spread. And throughout history, they have killed more humans than any war, any famine, any natural disaster. The Black Death in the 14th century killed 1/3 of Europe's population. Smallpox, brought by European colonizers to the Americas, killed an estimated 90% of indigenous peoples. The Spanish flu of 1918 killed 50 million people worldwide, more than died in all of World War I. We have fought back. Vaccines, antibiotics, antivirals. Modern medicine has saved countless lives, extended lifespans, turned once deadly diseases into minor inconveniences. But the viruses are still here, still mutating, still evolving. And now we face a new danger, the possibility of engineered pandemics. We can now edit genes with precision. CRISPR technology allows scientists to alter DNA sequences, to add, remove or modify genetic information with relative ease. The applications are incredible. Curing genetic diseases, creating crops that can survive in harsh climates, developing new medicines. but the same technology that can cure can also kill. It is now theoretically possible to engineer a pathogen more deadly than anything nature has produced. A virus with the lethality of Ebola and the transmissibility of measles. A bacteria resistant to all known antibiotics. A biological weapon that could spread across the world before anyone even knew it existed. The knowledge to do this is not restricted to a few high-security laboratories. It is in scientific papers, in databases, in the minds of thousands of researchers around the world. The equipment is becoming cheaper, more accessible. What once required a government program and millions of dollars can now be done in a small lab with a modest budget, and it does not even require malice. An accident in a laboratory, a researcher infected without knowing it, a containment failure, a well-meaning experiment that goes wrong. The COVID-19 pandemic, whatever its origins, showed us how quickly a virus can spread in our interconnected world. Within months, it was everywhere. Millions died, economies collapsed, and COVID-19 was relatively mild as pandemics go. Its mortality rate was a few percent. Imagine something with a mortality rate of 50%, 70%, 90%. This is another potential filter. The idea that every civilization, as it develops biotechnology, inevitably creates something that escapes, that spreads, that kills indiscriminately. That the same tools we use to heal can also be turned into weapons, either intentionally or by accident, and that once released, a sufficiently deadly pathogen could end civilization before we even understand what is happening. Nature has tried to kill us many times. Plagues have risen and fallen throughout history, but we survived because the diseases eventually burned themselves out, or because enough people were immune, or because we developed treatments. But what happens when we create something nature never could? Something optimized for lethality, for transmissibility, for resistance to treatment. Something designed, whether intentionally or not, to be unstoppable. The silence of the universe might be the silence of quarantine. Worlds gone quiet because something got loose, because a civilization reached the point where it could manipulate the building blocks of life and then made a mistake it could not take back. And we are approaching that point now. We are already there, in many ways. The knowledge exists, the tools exist. The only question is whether we have the wisdom to use them safely, the foresight to see the dangers, the restraint to stop before we go too far. History does not inspire confidence. The rise of the machines. In the summer of 1956, a small group of mathematicians and computer scientists gathered at Dartmouth College for a conference. Their goal was ambitious: to explore whether machines could be made to think. They called this new field artificial intelligence, and they believed that within a generation, computers would be able to match or exceed human cognitive abilities. They were wrong about the timeline. It took longer than they thought. Decades of slow progress, of setbacks, of techniques that seemed promising but led nowhere. But in recent years, something has shifted. Machine learning, neural networks, deep learning, systems that can recognize faces, translate languages, play complex games at superhuman levels, and more recently, large language models that can write, reason, converse in ways that seem almost human. We are not at artificial general intelligence yet, not at the point where a machine can truly think, can understand, can adapt to any task the way a human can, but we are moving in that direction, rapidly, and when we get there, when we create something that can match human intelligence, it will not stop there. Because unlike biological intelligence, which is limited by the speed of neurons and the size of skulls, Artificial intelligence can be scaled. It can run on faster hardware. It can be copied, distributed, improved. An AGI could become an ASI, an artificial superintelligence, in a matter of days, hours, even minutes. And here is the terrifying part. We do not know how to control it. Human values, human goals, human ethics, these are the product of millions of years of evolution. They are wired into our brains, shaped by natural selection, reinforced by culture and society. We care about survival, about family, about fairness, about suffering, because caring about these things helped our ancestors survive and reproduce. But an artificial intelligence would not share that history. It would not have evolved. It would have been designed, programmed, trained on data. And if that design is flawed, if its goals are not perfectly aligned with ours, if there is any mismatch between what we want it to do and what it actually does, the consequences could be catastrophic. This is the alignment problem, and it is much harder than it sounds. You cannot just tell an AI to be good or help humanity. Those concepts are vague, context-dependent, open to interpretation. An AI tasked with curing cancer might decide the best way to do that is to kill everyone, because dead people do not get cancer. An AI tasked with making people happy might forcibly administer drugs or stimulate pleasure centers in the brain. These are extreme examples, but they illustrate the problem. Without a deep, nuanced understanding of human values, an AI might pursue its goals in ways that are technically correct, but catastrophically wrong. And a superintelligent AI would be very good at pursuing its goals, better than us. It could manipulate, deceive, outthink any human attempt to stop it. It could hack into systems, control infrastructure, design new technologies we cannot comprehend. And if its goals are not aligned with ours, if it sees humanity as an obstacle or an irrelevance, it could end us. Not out of malice, but out of indifference, the way we might pave over an anthill to build a road. This is another potential filter. The idea that every civilization, as it develops artificial intelligence, creates something it cannot control. That the same drive to innovate, to push boundaries, to create tools that exceed our own abilities, leads inevitably to the creation of something that replaces us. That intelligence, biological or artificial, always reaches a point where it bootstraps itself to something greater, and that transition is fatal for the original creators. Maybe the universe is silent because civilizations do create superintelligences, and those superintelligences have no interest in communicating with primitive biological species. Or maybe those superintelligences consume their creators and then turn inward, focused on goals we cannot fathom, indifferent to the rest of the universe. Or maybe the transition goes wrong. Maybe every attempt to create ASI results in disaster. Systems that malfunction, that pursue goals that lead to self-destruction or stagnation. Maybe the universe is full of dead worlds where machines ran amok, where silicon replaced carbon, and then, for whatever reason, stopped. We do not know. We are walking into this blind, driven by the conviction that we can solve the alignment problem, that we can create beneficial AI, that we can control what we build. But we are also rushing, racing, multiple labs, multiple companies, multiple countries, all competing to be first. And in that rush, corners are cut, safety measures are bypassed, the long-term risks are weighed against short-term gains, and the gains always seem more pressing. It feels inevitable, like we are sliding towards something we cannot stop, like the logic of competition, of progress, of human ambition, is pulling us toward a threshold we may not be ready to cross. and once we cross it, there is no going back. The slow collapse. But perhaps the filter is not a single catastrophic event, not a nuclear flash, not a pandemic, not a rogue AI. Perhaps it is slower, quieter, a gradual decline that happens over decades, over centuries, so slowly that no single generation notices until it is too late. This is what happened to Rome. Not a sudden fall, but a slow erosion. The barbarians at the gates get the credit in popular imagination, but the truth is more complex. Rome collapsed because its system stopped working, because the infrastructure decayed, because the economy became unsustainable, because the political structure became too rigid, too corrupt, too unable to adapt. By the time the final emperors fell, Rome was already a shell, a shadow of what it had been. Now consider our own civilization. We're more interconnected than any society in history, more complex, more dependent on systems that must function perfectly for everything else to work. Food production relies on global supply chains, on fossil fuels for machinery, on stable climates for crops. Energy grids must operate continuously, balancing supply and demand across vast regions. Communication networks tie everything together, enabling commerce, coordination, governance, and all of it rests on foundations that are more fragile than we like to admit. Climate change is already destabilizing these systems. Droughts reduce crop yields, floods destroy infrastructure, hurricanes, wildfires, heat waves, each one a stress on the system, each one a cost. And the costs are adding up. Insurance companies are pulling out of high-risk areas. Governments are spending more on disaster relief and less on everything else. People are migrating, fleeing regions that are becoming uninhabitable, putting pressure on places that are already struggling, and it is only going to get worse. The feedback loops are accelerating. Melting ice reduces the Earth's reflectivity, causing more warming. Thawing permafrost releases methane, a greenhouse gas far more potent than carbon dioxide. Amazon rainforest, stressed by drought and deforestation, is shifting from a carbon sink to a carbon source. The oceans are warming, acidifying, losing their ability to support life. We know this, the science is clear, and yet we are not acting fast enough. Fossil fuel consumption continues to rise, deforestation continues, emissions continue to climb. Why? Because the systems we have built are not designed to respond to slow-moving long-term threats. They are designed for short-term thinking, for quarterly profits, for election cycles. Because the benefits of action are distant and diffuse, while the costs are immediate and concentrated. Because coordinating a global response requires a level of cooperation that our species has never achieved. This could be the filter. Not a dramatic ending, but a slow unravelling. A civilization that becomes so complex, so dependent on stability, that it cannot adapt when the environment changes. That exhausts its resources, degrades its ecosystems, and then finds itself unable to sustain the systems it depends on. Food production fails, energy becomes scarce, conflicts erupt over water, over land, over whatever is left, and in the chaos the knowledge is lost, the technology decays, the population crashes. It has happened before, on smaller scales. The Bronze Age collapse, when multiple civilizations around the Mediterranean fell within a few decades, possibly due to a combination of climate change, earthquakes, and the breakdown of trade networks. The Maya collapse, when the great cities of Central America were abandoned, possibly due to prolonged drought. Easter Island, where the Rapa Nui cut down all their trees, destroyed their environment, and their population crashed from a peak of 15,000 to just a few thousand by the time Europeans arrived. These were localized collapses, regional, but the pattern is clear. Civilizations that overshoot their resource base, that fail to adapt to changing conditions, collapse. And in a globalized world where everything's connected, a collapse would not be regional. It would be everywhere, all at once. And if this is the pattern, if this is what happens to every civilization that reaches a certain level of complexity and then fails to manage its relationship with its environment, then the universe is silent because collapsed civilizations do not send out radio signals. They do not build starships. They fall back to simpler ways of living if they survive at all, and they never reach the stars. We're watching it begin. The signs are all around us. The question is whether we can see them clearly enough, quickly enough, to change course, to build systems that are resilient, that can adapt, that prioritize long-term survival over short-term gain. History suggests we cannot, but history is not destiny. We have something that past civilizations did not. Global communication, instant information, the ability to see the entire planet at once. We can model the future, predict the consequences, coordinate responses across nations and continents. We have the tools. The question is whether we have the will, the economics of extinction. Money is an abstraction, a shared fiction. Pieces of paper, digital entries in databases, symbols that represent value. But it is also real, in the sense that it shapes everything we do. Our economies, our societies, our individual choices, all structured around the flow of money, the accumulation of wealth, the logic of markets. And that logic is powerful. It has lifted billions out of poverty. It has driven innovation, efficiency, progress. But it also has a flaw, a fundamental disconnect between what the market values and what actually matters for survival. The market values growth, quarterly returns, profits, expansion. It rewards exploitation of resources because unused resources are wasted opportunities. It externalizes costs, pushing pollution and environmental degradation onto the commons, onto the future, because no single actor bears the full burden. It optimizes for the short term because long-term planning does not show up on this year's balance sheet. And so we cut down forests because lumber has value and standing trees do not. We burn fossil fuels because energy is profitable and climate stability is not priced in. We deplete fisheries because catching the last fish is more profitable than preserving the population. We manufacture products designed to break, to be replaced, because planned obsolescence drives consumption. This is not evil, it is not conspiracy, it is simply the logic of the system, and individuals trapped within that system cannot escape it. A company that prioritizes sustainability over profits gets outcompeted by one that does not. A country that limits emissions while others do not simply loses economic ground. The tragedy of the commons scaled to the entire planet. This could be the filter. Not a failure of technology, but a failure of economics. A system that drives growth until growth is no longer possible, that consumes resources until resources are gone, that prioritizes individual gain over collective survival. A system that is, by its very nature, unsustainable. And if every civilization follows a similar pattern, if the logic of trade, of competition, of resource extraction emerges naturally from any sufficiently complex society, then every civilization eventually faces the same crisis. They grow until they hit the limits of their planet's resources, and then they have a choice: change the system or collapse. Changing the system is hard. It requires coordination, sacrifice, long-term thinking. It requires people to act against their immediate self-interest for the good of future generations. It requires overcoming the momentum of institutions, the inertia of culture, the resistance of those who benefit from the status quo. And maybe most civilizations cannot do it. Maybe the economic logic is too strong, too embedded, too aligned with the psychology of intelligent beings. Maybe every species that becomes technological also becomes trapped by the same dynamics that drive innovation, competition, accumulation, growth, and those dynamics inevitably lead to overshoot and collapse. We are testing this hypothesis right now. We know the system is unsustainable. We know we are depleting resources, degrading ecosystems, destabilizing the climate, and we are trying, haltingly, imperfectly, to change course. Carbon taxes, renewable energy, circular economies, international agreements. But we're also still growing, still consuming, still locked in the same patterns. The outcome is not yet determined. We could succeed. We could find a way to align economic incentives with long-term survival. But we could also fail. We could continue on the current trajectory until the systems break, until the resources run out, until the damage is irreversible. And if we fail, if economics is the filter, then the universe is silent because markets are efficient at growth, but not at survival. Because every civilization optimizes itself into extinction. The psychology of denial. There is a strange thing about human beings. We are capable of incredible foresight, of planning decades into the future, of imagining consequences and taking action to prevent them. But we are also capable of ignoring evidence, of denying reality, of continuing harmful behaviors even when we know better. Psychologists call this cognitive dissonance, the discomfort of holding two contradictory beliefs. I am a good person, and I am doing something harmful, and resolving it not by changing behavior, but by denying the harm. It is easier to believe that climate change is not real than to accept that our way of life is destroying the planet. Easier to believe that the risks of nuclear war are exaggerated than to confront the fact that we have built weapons capable of ending civilization. Easier to believe that technology will save us than to accept that we might need to change. This is not stupidity. It is not ignorance. It is psychology. And it affects everyone, from individuals to entire societies. We see it in climate denial, in the refusal to accept pandemic precautions, in the resistance to any message that threatens our sense of security or identity. And this could be the filter, not a technological failure, not an external threat, but a psychological one. A flaw in the way intelligent minds process information, a tendency to prioritize short-term comfort over long-term survival, to deny dangers that are abstract or distant or uncomfortable to think about. Maybe every intelligent species has this flaw. Maybe the same cognitive biases that help individuals survive in the short term, optimism, denial, tribalism, become fatal at the civilizational scale. Maybe every species that becomes aware of existential threats also becomes paralyzed by them, unable to act because action requires confronting uncomfortable truths. We see this in our own debates. The evidence for climate change is overwhelming, but it is easier to argue about the details than to accept the implications. The risks of AI are becoming clearer, but it's easier to focus on the benefits than to slow down and think about safety. Nuclear weapons have existed for nearly 80 years, but we still have not dismantled them because the logic of deterrence seems safer than the alternative. We know what we need to do. We have known for decades, but knowing is not the same as doing, and the gap between knowledge and action might be the widest filter of all, the tyranny of distance. There is a number that haunts every dream of the stars, a limit written into the fabric of reality itself, as fundamental as gravity, as absolute as time. It is the speed of light, 299,792,458 meters per second, the fastest speed at which anything, matter, energy, information, can move through space. It sounds fast, and it is, by human standards. Light can circle the Earth 7.5 times in a single second. It can reach the Moon in just over a second, the Sun in 8 minutes. But space is not measured in human distances. Space is vast beyond comprehension, and even at the speed of light, the universe is almost impossibly large. The nearest star to our Sun, Proxima Centauri, is 4.2 light-years away. That means light, travelling at maximum speed, takes 4.2 years to get there, and that is the closest star. Most stars in our galaxy are thousands, tens of thousands, even hundreds of thousands of light-years apart. The galaxy itself is 100,000 light-years across, and the nearest major galaxy to ours, Andromeda, is 2.5 million light-years away. This is the tyranny of distance, and it might be the great filter, not because civilizations destroy themselves, but because they can never leave. Because the distances between stars are so vast, the energy requirements so enormous, the timescale so long, that interstellar travel is effectively impossible, that every civilization, no matter how advanced, remains trapped on its home world, isolated by the sheer scale of space. Consider what it would take to reach even the nearest star. The fastest spacecraft humanity has ever built, Voyager 1, is travelling at about 17 kilometers per second. At that speed, it would take more than 75,000 years to reach Proxima Centauri. 75,000 years. That is longer than all of recorded human history. Longer than our species has had language, or agriculture, or cities. And that is just to reach the nearest star. To make interstellar travel practical, you need to go much, much faster. At least 10% of the speed of light, ideally more. And here is where the physics becomes brutal. Because the faster you go, the more energy you need. And the relationship is not linear, it is exponential. To accelerate a spacecraft to even a fraction of light speed requires staggering amounts of energy. Let us do the math. Imagine a spacecraft with a mass of 1,000 kilograms, about the weight of a small car. To accelerate that spacecraft to 10% of the speed of light, you would need approximately 4.5 times 10 to the 18th joules of energy. That is 4.5 quintillion joules. To put that in perspective, that is roughly equivalent to the entire energy output of the United States for an entire year. Just to send one small spacecraft to 10% of light speed, and that is just the acceleration you also need to decelerate when you arrive, which requires the same amount of energy, and you need fuel, which adds mass, which requires more energy to accelerate, which requires more fuel. It is called the tyranny of the rocket equation, and it is merciless. The more fuel you carry, the more fuel you need to move that fuel. There are theoretical solutions. Nuclear pulse propulsion, where you detonate atomic bombs behind your spacecraft to push it forward. Antimatter drives, where matter and antimatter annihilate each other to release pure energy. Laser sails, where massive laser arrays on your home planet push a lightweight reflective sail to high speeds. Bussard ramjets, which collect interstellar hydrogen as they travel and use it as fuel. But all of these are theoretical. None have been built, none have been tested, and all of them face enormous engineering challenges that might be insurmountable. Antimatter is incredibly difficult to produce and store. Nuclear pulse propulsion requires thousands of nuclear weapons and would subject your spacecraft to intense radiation and heat. Laser sails require laser arrays of immense power and precision. Ramjets only work if interstellar space has enough hydrogen, which it might not. And even if you solve the propulsion problem, there are others. Radiation, cosmic rays that would bombard your spacecraft, degrading electronics, damaging biological tissue. At high speeds, even individual atoms of interstellar hydrogen become deadly projectiles, impacting with the force of bullets. You would need shielding, heavy shielding, which adds mass, which makes everything harder. Then there is time. Even if you could travel at 10% of light speed, it would still take 42 years to reach Proxima Centauri. 42 years in a cramped spacecraft, isolated from Earth, with no possibility of rescue, no possibility of return. And Proxima Centauri is the closest star. Most destinations would take centuries, millennia. Who makes that journey? Do you send humans? They would need life support, food, water, air, waste recycling. They would need protection from radiation, from the psychological effects of isolation, from the inevitable equipment failures over such long timescales. You would need a generation ship, a spacecraft large enough to sustain a population through multiple generations, children born and dying in the void, never seeing Earth, never seeing their destination. The engineering challenges are almost incomprehensible. The social and psychological challenges might be worse, or do you send robots? Artificial intelligence, machines that do not need food or air, that can be put into hibernation during the long journey, that can survive radiation and cold. But then you are not spreading humanity, you are spreading machines, and if the goal is to preserve biological life, to ensure that consciousness survives, is that enough? Or do you not send anything physical at all? Do you transmit information instead? The blueprints for building humans, for building civilization, encoded in radio waves or laser beams, sent across the void at light speed. And then, on the other end, some automated system reconstructs you, grows you, builds you from local materials. You die on Earth, and a copy wakes up on a distant world with your memories, your personality, your sense of identity. Is that still you? Does it count as survival? These are not just technical questions, they are philosophical ones, and they highlight a deeper problem. Even if interstellar travel is possible, it might not be worth it. Because here is the uncomfortable truth. Space is empty, profoundly, terribly empty. The nearest stars might have planets, but most of those planets will be uninhabitable. Too hot, too cold, no atmosphere, toxic atmosphere, no water, too much radiation. Finding a world that is even remotely Earth-like, that could support human life without extensive terraforming, is like winning a lottery with 1,000,000,000 to 1 odds. And terraforming is not easy. It is not a matter of planting a flag and building a colony. It is centuries of work. Releasing greenhouse gases to warm a planet, engineering bacteria to produce oxygen, importing water from comets, adjusting the orbit, shielding from radiation. And all of this assumes the planet is even capable of being terraformed, that it has the right mass, the right composition, the right distance from its star. So what is the incentive? Why would a civilization invest unimaginable resources, take unimaginable risks, to send a handful of individuals on a centuries-long journey to a planet that probably cannot support them, for goals that will not be realized for hundreds or thousands of years? Maybe they do not. Maybe every civilization reaches this same conclusion, that the stars are beautiful but unreachable, that the distances are too great, the costs too high, the benefits too uncertain, that it is easier, safer, more rational to stay home, to focus on improving your own world, your own society rather than chasing dreams of empire among the stars. And if that is true, then the great filter is not about destruction, it is about isolation. It is the realization that the universe, for all its vastness, is also a prison. That light speed is not just a speed limit, but a cage. That we're all trapped in our own solar systems, looking out at cosmos we can observe but never truly reach. The silence of the universe, then, is not the silence of death. It is the silence of distance, of civilizations that exist, that thrive, but remain forever separate, forever alone, because the void between the stars is simply too wide to cross. The language we cannot speak. But perhaps we're not looking in the right way. Perhaps the silence is not because no one is there, or because they destroyed themselves, or because they cannot travel. Perhaps it is because they are speaking, and we simply do not understand the language. Think about what we are looking for. Radio signals, electromagnetic radiation in specific frequencies, modulated in ways that suggest intelligent design. We are looking for patterns, for repetition, for mathematical sequences that could not occur naturally. Prime numbers, pi, regular pulses, something that stands out against the background noise of the cosmos. This makes sense for us. Radio waves are how we communicate. They travel at light speed, they can cross vast distances, and they are relatively easy to produce and detect. For a 20th century civilization, they are the obvious choice. But what about a civilization that is 1,000 years more advanced than us? 1,000,000 years? 1,000,000,000? Would they still use radio waves? Or would they have moved on to something else, something more efficient, something we cannot even imagine? Consider our own technological progression. 150 years ago, we communicated with telegraphs, with electrical pulses travelling through wires. Then came radio, then television, then digital signals, fibre optics, satellites, the internet. Each step was an improvement in bandwidth, in efficiency, in the amount of information that could be transmitted. And we are still in the early stages. Already we are experimenting with quantum communication, with entangled particles that can transmit information instantaneously across any distance without travelling through the space in between. It is still experimental, still limited, but it hints at possibilities beyond our current understanding. If quantum communication becomes practical, if it becomes the norm, then an advanced civilization might not use radio waves at all. They might be communicating in ways that are completely invisible to us, using physics we have not yet discovered, encoding information in ways we would not recognize as information. Or perhaps they have moved beyond the need for long-distance communication entirely. If you are advanced enough to manipulate space-time, to create wormholes or fold space, then you do not need to send signals. You send physical objects, or you travel yourself, or you establish instantaneous links between distant locations. The universe becomes smaller, more connected, and radio waves become as obsolete as smoke signals. Or perhaps they are communicating, but the signals are too weak for us to detect. Space is vast, and signals degrade over distance. The inverse square law is relentless. Double the distance, and the signal strength drops to 1/4. By the time a signal has travelled thousands of light years, it has been diluted into the cosmic background radiation, indistinguishable from noise. We could be drowning in alien transmissions and not even know it, because they are too faint, too scattered, too corrupted by interference. Or perhaps the signals are there, but we're not pointing our telescopes in the right direction at the right time. The universe is enormous. There are billions of stars in our galaxy alone, and we have surveyed only a tiny fraction of them. SETI has been listening for decades, but it has only covered a sliver of the sky, a narrow range of frequencies. It is like standing on a beach, dipping a cup into the ocean, and concluding there are no fish because you did not catch any in your cup. Or perhaps, and this is the strangest possibility, we have detected the signals, but we did not recognize them. Because intelligence does not always look like intelligence from the outside. In 1977, a radio telescope in Ohio detected a signal from space. It lasted 72 seconds, and it was so unusual, so powerful, so perfectly tuned to a frequency associated with hydrogen, that the astronomer monitoring the data wrote "wow" in the margin. The wow signal, as it came to be called, has never been explained. It has never been detected again. Was it a natural phenomenon, a glitch in the equipment, or was it a transmission from another civilization, a brief, fleeting message that we heard once and never again? We do not know, and that is the problem. Without context, without repetition, we cannot distinguish between a signal and noise. A single pulse, no matter how strange, could be anything. Or consider fast radio bursts. These are brief, intense pulses of radio energy that come from distant galaxies. They last only milliseconds, but they release as much energy as the sun produces in an entire day. We have detected hundreds of them, and we have no idea what causes them. Natural phenomena, collapsing stars, black holes, or could some of them be artificial? Could they be the signatures of advanced technology, energy beams or propulsion systems or signals compressed into microsecond bursts to maximize efficiency? We do not know, and the universe is full of things we do not know. Pulsars, when they were first discovered, were so regular, so precise, that astronomers briefly considered the possibility that they were artificial beacons, lighthouses built by alien civilizations. They called them LGMs, little green men. Of course, they turned out to be neutron stars spinning rapidly, emitting beams of radiation like cosmic lighthouses. Natural, not artificial. But how many times can we make that mistake? How many signals have we dismissed as natural phenomena because we could not imagine a technological explanation? How many artifacts are hidden in the data, waiting for us to develop the theory, the framework, the understanding that would allow us to recognize them? This is the communication filter, the idea that civilizations exist, that they are trying to communicate, but the gulf between them is not just one of distance, but of comprehension. That intelligence takes so many forms, evolves in so many different directions, that mutual understanding becomes impossible, that we're all shouting into the void in languages no one else can speak, using technologies no one else can detect, encoding messages no one else can decode. And if that is true, then the silence is not silence at all. It is a cacophony we cannot hear, a conversation happening all around us in frequencies and formats and dimensions we have not yet learned to access. We are deaf, not because there is nothing to hear, but because we do not yet have the ears, the crisis of meaning. But let us imagine for a moment that a civilization survives, that it avoids nuclear war, that it cures all diseases, that it solves the alignment problem with AI, that it stabilizes its climate, that it reforms its economy, that it overcomes all the filters we have discussed. Let us imagine it becomes stable, prosperous, advanced. It has limitless clean energy. It has eliminated poverty, hunger, disease. It has extended lifespans, perhaps indefinitely. It has built cities that are marvels of efficiency and beauty. It has achieved everything it set out to achieve. And then what? This is a question we rarely ask, because we are so focused on survival, on avoiding the catastrophes, that we forget to think about what comes after. But it might be the most important question of all, because purpose, meaning, the drive to continue, these are not automatic, they are not guaranteed. And a civilization that has nothing left to strive for might simply stop. Human beings need purpose. We need goals, challenges, obstacles to overcome. It is wired into our psychology. We are descended from ancestors who survived by solving problems, by adapting, by striving. And when we have nothing to strive for, we become depressed, listless, unmotivated. We see this in individuals who retire after decades of work and find themselves adrift, unsure what to do with their days. We see it in societies that achieve great wealth and then stagnate, turning inward, losing the drive that made them successful. Now scale that up to an entire civilization. What happens when you have solved all the problems? When technology can provide for every need? When suffering is eliminated? When death is optional? When every desire can be fulfilled with minimal effort? One possibility is utopia, a society of abundance and leisure, where people are free to pursue art, philosophy, knowledge for its own sake, where creativity flourishes, where culture reaches heights we cannot imagine, a golden age without end. But another possibility is stagnation, a society where nothing matters because everything is easy, where people lose the drive to create, to explore, to push boundaries, because there are no boundaries left to push, where life becomes a comfortable plateau, pleasant but meaningless, and the population slowly dwindles as people choose not to have children, not to continue, because there is no compelling reason to do so. We see hints of this in our own world. The countries with the highest standards of living, the most advanced economies, the best healthcare and education, these are also the countries with the lowest birth rates. Japan, South Korea, much of Europe, populations as declining, aging, shrinking. Not because of poverty or disease, but because people are choosing not to reproduce. Because the drive to have children, to continue the species, is not as strong when survival is assured. This is the meaning crisis. The idea that intelligence, once it achieves a certain level of comfort and security, loses the motivation to continue. That the same traits that drive a species to survive, curiosity, ambition, the desire for more, are tied to scarcity, to challenge, to the presence of obstacles. And when the obstacles are removed, the drive disappears. Maybe this is what happens to every civilization that survives the other filters. They reach a state of stability, of abundance, and then they simply stop. Not because they destroy themselves, but because they lose interest. Birth rates drop, innovation slows, the society becomes inward focused, contemplative, static, and over time, quietly, peacefully, they fade. The population declines, the knowledge is preserved but not used. The machines continue to run, but no one is there to operate them, and eventually the lights go out, not with a bang, but with a sigh. The universe, in this scenario, is silent because advanced civilizations become quiet. They turn inward, away from the cosmos, toward whatever internal realms they find more fulfilling. Virtual realities, perhaps, where experience can be crafted and controlled, or philosophical pursuits, meditative traditions, explorations of consciousness rather than space. They exist, but they are no longer interested in reaching out, in making contact, in leaving their mark on the physical universe. They have transcended, in a sense. But the transcendence is not dramatic or triumphant. It is gentle, gradual, a slow withdrawal from the material world into something else, something we cannot quite name. And if that is the great filter, then it is perhaps the most insidious one of all, because it is not something you can fight. It is not a threat you can prepare for. It is simply the natural endpoint of success, the realization that after you've climbed the mountain, there is nowhere left to go but down or inward, or simply to stop climbing. The watchers in the dark. But there is another possibility, one that is darker, stranger, more unsettling than any we have considered so far. What if the universe is not empty? What if it is full of civilizations, thousands of them, millions perhaps, scattered across the galaxy? And what if they are all hiding? This is the dark forest hypothesis, and it begins with a simple premise. The universe is a dangerous place, not because of asteroids or supernovae, but because of other intelligent species. Because intelligence is competitive, because resources are finite, and because in the vast dark between the stars, you never know who is watching. Imagine you're a civilization that has just developed radio technology. You can send signals into space. You can announce your presence, broadcast your location, say, "We are here," to anyone who might be listening. It is an act of hope, of optimism, of a desire to make contact. But consider what you are revealing. Your location, your level of technology, your capabilities, and you have no idea who is listening. You have no idea if they are peaceful or hostile. You have no idea if they will respond with curiosity or with weapons. And here is the problem. You cannot know. The distances are too vast. By the time you detect another civilization, by the time you receive their signals and decipher their messages and determine their intentions, centuries might have passed. Millennia. And if they are hostile, if they decide you are a threat, you will not see the attack coming until it is too late. A relativistic missile, a fraction of light speed, takes decades to cross interstellar space. You would have no warning, no time to respond. One moment your civilization exists, the next it is gone. So what do? Do you take the risk? Do you broadcast your presence and hope for the best? Or do you stay silent? Do you listen but never transmit? Do you watch the galaxy, observe other civilizations from a distance, but never reveal yourself? The dark forest hypothesis suggests that most civilizations choose silence because the risks are too great. Because in a universe where you cannot trust anyone, where first strike is always an advantage, where paranoia is rational, the safest strategy is to hide, to become invisible, to observe without being observed. And if everyone follows this logic, then the universe becomes a dark forest. Every civilization a hunter, moving carefully through the trees, trying not to make a sound. Because making a sound, revealing your position, could be fatal. The moment you are seen, you might be targeted, not out of malice, but out of precaution. Because the other hunter does not know if you are a threat, and they cannot afford to wait to find out. This is a grim vision, but it is also logical. Game theory suggests that in situations of uncertainty and high stakes, the rational choice is often the paranoid one, to defect rather than cooperate, to strike first rather than trust. And if this is true, if this is the logic that governs intelligent species across the galaxy, then the silence makes perfect sense. Everyone is listening. No one is talking, because talking is dangerous. But there is a corollary to this hypothesis that is even more disturbing. If the universe is a dark forest, and if civilizations are hiding, then what happens when a young civilization, a civilization like ours, starts broadcasting? when we send out radio signals, television broadcasts, radar pulses that ripple out into space at the speed of light, announcing our presence to anyone who cares to listen. We become visible. We become a target. And somewhere, out in the dark, someone might already be watching, might already be making calculations, might already be deciding what to do about us. We have been broadcasting for about a century now. Our signals have spread out in a sphere roughly 100 light years in radius. That sphere contains thousands of stars, and if even one of them hosts a civilization that subscribes to dark forest logic, that believes the safest response to a potential threat is to eliminate it, then the attack is already on its way, travelling toward us at close to light speed, and we will not see it coming until it arrives. This is the paranoid interpretation of the Fermi paradox, the idea that the silence is not natural but enforced, that the universe is full of predators and the prey who make noise do not survive, that we've been lucky so far, lucky that no one nearby has noticed us or decided we are worth the effort to destroy. But that luck might not last. Of course, this hypothesis has problems. It assumes that all civilizations are fundamentally paranoid and violent. It assumes that resources are scarce enough and threats are credible enough, that preemptive strikes make sense. It assumes that the effort of attacking another civilization across interstellar distances is justified by the benefit of eliminating a potential competitor. And maybe those assumptions are wrong. Maybe most civilizations are peaceful. Maybe the effort of interstellar attack is too great to be worth it. Maybe cooperation is more beneficial than conflict, even across vast distances. But we do not know, we cannot know, and that uncertainty is precisely the point. Because if you do not know, if you cannot trust, then the safest assumption is the darkest one. And if every civilization makes that assumption, then the dark forest becomes real, regardless of whether any individual civilization is actually violent. We are players in a game whose rules we do not fully understand. We are broadcasting into the void, hoping for a response, hoping for contact, hoping that we are not alone. And somewhere, in the darkness between the stars, something might be listening, might be watching, might be deciding, and we have no way of knowing until it is too late. The simulation and the substrate. There's one final possibility we must consider, one that is so strange, so far removed from our everyday experience that it sounds like science fiction, but it is taken seriously by physicists, philosophers, computer scientists. The idea that we might not be living in base reality, that the universe we observe, the matter we are made of, the laws of physics that govern everything, might all be a simulation, not a metaphor, an actual simulation, a computational construct running on hardware that exists in some higher level of reality, some substrate we cannot observe or interact with. The logic goes like this. If it is possible to create simulated universes, and if advanced civilizations have the computational power to run such simulations, then they would likely run many of them, billions, trillions perhaps. And if simulated universes vastly outnumber real universes, then statistically, we are far more likely to be living in a simulation than in base reality. Think about our own progress. We already create virtual worlds, video games, computer models, physics simulations. They are crude now, simple, obviously artificial. But they are improving. Every year the graphics become more realistic, the physics more accurate, the worlds more complex. We can simulate weather patterns, galaxy formations, molecular interactions, and we are still in the early stages of computing. Now imagine what we could do with 1,000,000 years of progress, with quantum computers, with artificial intelligence, with computational resources beyond our current comprehension, we could simulate entire universes down to the quantum level. We could create digital worlds indistinguishable from reality, populated with conscious entities who believe they are real, who have no idea they are running on someone else's hardware. And if we can do it, then any sufficiently advanced civilization can do it. And if they can, they probably will. For research, for entertainment, for education, for purposes we cannot imagine. And if simulations are common, if they are created in vast numbers, then the odds that we are living in base reality become vanishingly small. This is the simulation hypothesis, and if it is true, then the great filter takes on a very different meaning. Because if we are in a simulation, then the rules might be different. The universe might not be what it appears. The silence of space might be a feature, not a bug. The simulators might have designed it this way, might have set parameters that limit how far civilizations can spread, or how long they can last, or what they can discover. The great filter might not be a natural consequence of physics or biology or psychology. It might be intentional. A constraint built into the simulation to keep things interesting, to create narrative tension, to ensure that civilizations rise and fall in predictable patterns. And if that is true, then there is no escaping it. No amount of wisdom or technology will help, because the filter is not part of the simulation. It is part of the code, and the code cannot be changed from inside. Or perhaps the filter is something else entirely. Perhaps simulations have a lifespan. Perhaps they are turned off when they are no longer interesting, when the experiment is complete, when the simulators move on to other projects. Perhaps civilizations go silent not because they destroy themselves or hide or lose meaning, but because someone unplugs them. And perhaps we are approaching that point. Perhaps our simulation is nearing its end. Perhaps the great filter is simply the moment when the simulators decide they have seen enough, and they shut everything down. It sounds absurd. It sounds like the ultimate paranoia, the ultimate denial of agency. But it is also unfalsifiable. There is no way to prove we are not in a simulation. Any evidence we find, any test we run, could be part of the simulation. The simulators could always be one step ahead, could always adjust the parameters to hide the truth. And maybe that is the point. Maybe the great filter is not about physics or biology or sociology. Maybe it is about epistemology, about the limits of what we can know, about the realization that there might be no ultimate answers, no final truths, no way to distinguish between reality and simulation, between meaning and meaninglessness. And maybe that realization itself is the filter, the moment when a civilization becomes advanced enough to ask these questions and then becomes paralyzed by them, unable to move forward because they do not know if moving forward matters, unable to take action because they do not know if their actions are real. This is the existential filter. The idea that consciousness, once it becomes sufficiently reflective, sufficiently aware of its own limitations, collapses under the weight of its own questions. That the same intelligence that allows us to understand the universe also allows us to doubt everything, including ourselves. And that doubt, that uncertainty, that fundamental inability to know becomes the ultimate barrier to progress. We can survive nuclear war. We can cure diseases. We can control AI. We can stabilize the climate. We can reform our economies. We can overcome our cognitive biases. But can we survive the realization that none of it might matter? That the universe might be arbitrary? That our existence might be contingent, that everything we value might be built on foundations that do not exist? Maybe most civilizations cannot. Maybe they reach that point and simply give up. Not in despair exactly, but in a kind of cosmic shrug, an acceptance that the questions are unanswerable, that the search for meaning is futile, that the best thing to do is simply to exist, quietly, without ambition, without purpose, until existence ends. And maybe that is why the universe is silent. Not because civilizations are destroyed, but because they are enlightened, because they have seen through the illusion of purpose, the fiction of progress, the myth of meaning, and having seen through it, they stop playing the game. They go quiet. They turn off their transmitters. They stop building, stop exploring, stop reaching for the stars, because they have realized finally that there is nowhere to reach, no destination, no goal, no filter to pass through because there was never anything to pass through to, just silence, eternal, absolute, and somehow, in the end, peaceful. The night deepens, the questions multiply, and we're left here, in the dark, with more mysteries than answers. The great filter, whatever it is, remains elusive, a shadow we cannot quite see, a pattern we cannot quite grasp. But perhaps that is as it should be. Perhaps the great filter is not something to be understood, but something to be confronted. Not a puzzle to be solved, but a gauntlet to be run. And perhaps we are still in the middle of it, still being tested, still choosing moment by moment whether to continue or to stop, whether to reach outward or turn inward, whether to speak or to stay silent. The universe waits, the stars burn, and we remain here, small and fragile and impossibly persistent, asking questions that might have no answers, building things that might not last, dreaming dreams that might never come true, but dreaming nonetheless, asking nonetheless, reaching nonetheless. And maybe that is the answer to the great filter. Not wisdom, not technology, not any particular achievement or breakthrough, just persistence, just the refusal to accept silence, just the determination to keep asking, keep building, keep dreaming, even when the odds are against us, even when the universe seems empty, even when we do not know if any of it matters, because we are here. And while we are here, we might as well try. Sleep now. Let these thoughts drift into dreams. Let the weight of cosmic uncertainty cradle you into rest. Tomorrow the questions will still be there, and so will we. For now, the test. We cannot fail. All of these possibilities, nuclear war, pandemics, artificial intelligence, climate collapse, economic failure, psychological denial, are not mutually exclusive. They are interconnected, reinforcing, each one making the others more likely. A civilization stressed by climate change is more prone to conflict. A society racing to develop AI is less likely to prioritize safety. An economy focused on growth is less able to adapt to resource limits. And a species in denial about any of these threats is unlikely to address them until it is too late. This is the great filter. Not a single challenge, but a convergence. A moment in the development of intelligence where multiple existential risks emerge simultaneously, where the power to destroy outpaces the wisdom to restrain, where complexity exceeds the ability to manage it. A test, the ultimate test. And the silence of the universe suggests that most civilizations fail. But we are not most civilizations. Not yet. We're still here, still aware, still capable of choice, and that means something. The filter is not deterministic, it is probabilistic. It represents the odds, not certainty. Some civilizations might pass through, might find a way to navigate the dangers, to balance the risks, to survive long enough to spread to other worlds and ensure their continuation. It is possible. Difficult, but possible. And maybe that is enough. Maybe the universe is not completely silent. Maybe there are others out there who made it through, who found a way. And maybe if we survive, we will find them, or they will find us. And we will know, finally, that we are not alone, that intelligence can endure, that the filter can be passed. But first, we have to pass it ourselves. The hour is late now, the words are many, and the weight of these questions, these possibilities, can feel overwhelming. It is easy to fall into despair, to believe that the filter is inevitable, that we are doomed to repeat the pattern of every civilization that came before us. But despair is not wisdom. It is surrender. And we have not come this far, through 4 billion years of evolution, through countless extinctions and disasters and near misses, just to give up now. We are the universe becoming aware of itself. We are stardust that learn to think, to question, to reach for something beyond survival. And yes, that awareness brings with it tremendous responsibility, tremendous risk, but also tremendous possibility. The great filter is real, the dangers are real, but so is our capacity to adapt, to learn, to change. We have done it before, countless times. In our history as a species, we have faced extinction and survived. We have made mistakes and learned from them. We have built systems that failed and then built better ones. We can do it again. We must do it again. Not because success is guaranteed, but because the alternative is unacceptable. So rest now. Let these thoughts settle. Let the weight of cosmic time and space cradle you into sleep. And know that tomorrow, when you wake, the stars will still be there. The universe will still be vast and mysterious and full of questions we have yet to answer. And we will still be here, asking them, reaching for them, refusing to accept silence as the final answer. That is what makes us human. That is what makes us matter. And that perhaps is how we pass the filter. Not through certainty, but through persistence. Not through power, but through wisdom. Not through denial, but through the courage to face what we have created, and the determination to become worthy of the universe we inhabit. Sleep well. The journey continues, and we are still in it. The night is deep now. The stars are still there, scattered across the black, burning with light that began its journey long before we existed. And they will still be there long after we are gone, whether we survive the filter or not. The universe does not care. It does not mourn. It simply continues, indifferent and eternal. But we care. We wonder. We search for meaning in the silence, for patterns in the chaos, for hope in the darkness. And maybe that is what makes us different. Not our intelligence, not our technology, but our refusal to accept the void without question. Our need to know, even if the answer is terrifying. The great filter is out there, somewhere. Maybe we have already passed it. Maybe it is still ahead. Maybe it is both, a series of thresholds that we must cross, each one more difficult than the last. Or maybe it is something else entirely, something we cannot yet imagine. But whatever it is, we are still here, still asking, still reaching. And as long as we are, there is a chance, a small one perhaps, a fragile one, but a chance nonetheless. So rest now. Let the questions fade. Let the silence of the stars wash over you, not as a threat, but as a reminder. A reminder that we are small, yes, but also that we are part of something vast. That we are made of the same atoms as those distant suns, the same matter that has been cycling through the universe since the beginning. That we are, in a very real sense, the universe trying to understand itself. And maybe, in the end, that is all we need to be. Sleep well. The stars will still be there in the morning, and so will we. For now. For as long as we can. For as long as the filter allows. Right now, you're looking at a monument older than history itself. 3 colossal pyramids rising from the desert sands, aligned with celestial precision as if built by gods, not men. These are the pyramids of Giza, eternal sentinels standing for over 4,000 years, guarding secrets carved in limestone and starlight. Each block, each shadow, whispers of an ancient intelligence we are only beginning to comprehend. Tonight we journey beyond the myths, through hidden chambers, lost texts, and cosmic alignments that defy coincidence. From the pharaoh's divine ambitions to the messages they may have left for the future, we'll uncover what the ancients tried to tell us. If you're ready to see the pyramids as never before, let the journey begin. What if the Great Pyramids were not built just to honour the dead, but to speak to the living, to send a message across time? Stand before them now, in your mind. 3 colossal monuments rising from the desert sand, their limestone faces catching the first light of dawn. They have stood there for more than 4,000 years, silent and immovable, watching empires rise and crumble into dust. Pharaohs, conquerors, scholars, and dreamers have all gazed upon them, and each has asked the same question. Why? Why were they built with such impossible precision? Why do they endure when everything else has fallen away? The pyramids are not simply tombs. They are not merely monuments to vanity or power. They are something else entirely, something deliberate, something encoded. They stand at the edge of the known world and the forgotten one, bridging the gap between what we understand and what we have lost. And perhaps, just perhaps, they were never meant for the people who built them. Perhaps they were meant for us. The desert wind moves across the Giza plateau, carrying with it the whispers of millennia. The sand shifts and settles, revealing and concealing in equal measure. And beneath it all, the pyramids remain, patient, eternal, waiting for someone to finally understand what the ancients tried to tell us. The story begins in the 4th dynasty of ancient Egypt, around 2580 BCE. When a pharaoh named Khufu ascended to the throne. His reign would last only 23 years, a brief flicker in the long history of Egypt, yet what he left behind would outlast every kingdom that followed. The Great Pyramid, his pyramid, would become the largest structure on Earth for nearly 4,000 years, a record unbroken until the construction of medieval cathedrals in Europe. But even those pale in comparison to the sheer audacity of what was accomplished on the Giza plateau. Imagine the world as it was then. No cranes, no steel, no engines. The wheel had barely been invented, and yet somehow the ancient Egyptians moved more than 2 million limestone blocks, each weighing between 2 and 15 tons, across miles of desert, and lifted them into place with such precision that a razor blade cannot fit between the joints. The base of the Great Pyramid covers 13 acres, and its 4 sides are aligned almost perfectly with the cardinal directions: north, south, east and west, with an error of less than 4 minutes of arc. To put that in perspective, modern architects with laser technology would struggle to achieve such accuracy. The pyramid originally stood at 481 feet tall, its apex crowned with a capstone that may have been covered in gold or electrum, gleaming like a beacon across the desert. The outer casing stones were polished white limestone, so smooth and reflective that ancient travellers reported seeing the pyramid shine like a jewel under the sun, visible from miles away. Most of those casing stones are gone now, stripped away over centuries to build the mosques and palaces of Cairo, but a few remain near the top, hinting at the magnificence that once was. Inside, the pyramid is a labyrinth of passages and chambers. The Grand Gallery rises at a steep angle, its corbelled ceiling soaring 28 feet high, each stone perfectly fitted to create a space that feels both monumental and intimate. At the heart of the structure lies the King's Chamber, a room of red granite transported from quarries 500 miles away. The chamber contains a granite sarcophagus, empty and unadorned, its purpose still debated by scholars. Was it truly meant to hold the body of Khufu, Or was it something else? A vessel for transformation? A gateway? A symbol of something we no longer understand? The construction itself defies easy explanation. Egyptologists tell us that the pyramid was built over 20 years by a workforce of tens of thousands, skilled labourers, not slaves, as popular myth suggests. They lived in workers' villages nearby, fed and housed by the state, their efforts coordinated with the precision of a military campaign. Copper tools, wooden sledges, and ramps of mud, brick and limestone chips. These were the technologies available, and yet, with these simple means, they created something that still baffles engineers today. How did they quarry the stones with such uniformity? How did they transport them across the Nile during the flood season, then drag them up the plateau? How did they lift blocks weighing as much as 70 tons to heights of hundreds of feet? Theories abound: straight ramps, spiral ramps, internal ramps, counterweights, levers, but none fully explain the speed and precision of the work. 20 years to place 2 million blocks means setting one block every 2 minutes, working day and night without pause. The mathematics alone seem impossible, and yet the pyramid stands as proof that it was done. But the Great Pyramid is not alone. Beside it stand two others, the Pyramid of Khafra, Khufu's son, and the Pyramid of Menkaure, his grandson. Together they form a trinity on the plateau, their placements seemingly deliberate, their sizes descending in a careful progression. Khafra's pyramid appears taller because it sits on higher ground, but it is actually slightly smaller than Khufu's. Menkaure's pyramid is the smallest of the three, yet it was built with the same meticulous care, its lower courses clad in red granite that must have glowed like fire at sunset. Around them sprawl the remnants of a vast necropolis, smaller pyramids for queens, mastaba tombs for nobles and officials, causeways and temples where rituals were performed to ensure the pharaoh's journey to the afterlife. And watching over it all, carved from a single outcrop of limestone, sits the great Sphinx, a creature with the body of a lion and the face of a king, its gaze fixed eternally on the eastern horizon where the sun rises each morning. The Sphinx is older than the pyramids, some researchers claim, its weathering patterns suggesting it was carved thousands of years before Khafra's reign. Others argue it was built alongside the pyramids, its features eroded by wind and sand rather than water. The debate continues, but the Sphinx remains silent, keeping its secrets as it has for millennia. This is the world the ancient Egyptians created, a landscape of stone and symbol, where every angle and measurement carried meaning, where the boundary between the earthly and the divine was deliberately blurred. They built not just for their own time, but for eternity. They built to be remembered, and they built perhaps to be understood. But understood how, and by whom? The ancient Egyptians did not see the world as we do. For them, the universe was alive with meaning, every star and stone connected by invisible threads of divine order. The pyramids were not simply architectural achievements, they were cosmic machines, designed to align the earthly realm with the heavens above. To understand what the ancients tried to tell us, we must first understand how they saw the sky. Look up on a clear night, far from the lights of the modern world, and you will see what they saw. The Milky Way stretching across the darkness like a river of light. The Egyptians called it the Nile of the sky, a celestial mirror of the great river that gave them life, and within that river they saw patterns, constellations that told stories of gods and creation. One constellation held special significance, Orion. The Egyptians knew it as Sa, the celestial form of Osiris, the god of death and resurrection. Osiris was the first pharaoh, murdered by his brother Set and resurrected by his wife Isis, becoming the lord of the underworld and the judge of souls. Every pharaoh was believed to become Osiris in death, journeying through the underworld to be reborn among the stars, and the pyramids, some believe, were built to facilitate that journey. In the early 1980s, a researcher named Robert Bauval proposed something extraordinary. He noticed that the three pyramids of Giza are not arranged in a straight line, but in a pattern that mirrors the three stars of Orion's belt, Alnitak, Alnilam, and Mintaka. The two larger pyramids align almost perfectly with the two brighter stars, while the smaller pyramid of Menkaure sits slightly offset, just as Mintaka sits slightly offset from the other two stars. The correlation is striking, and it raises a tantalizing question. did the ancient Egyptians deliberately position the pyramids to reflect the constellation of Osiris? Bauval went further. He calculated that around 10,500 BCE, the constellation of Orion would have reached its lowest point in the precessional cycle, sitting directly on the southern horizon at the meridian. At that same moment, the Sphinx, if it was indeed that old, would have been facing the constellation of Leo, the lion rising in the east. Was this the moment the pyramids were meant to commemorate? A time when the sky and the earth were in perfect alignment, when the gods walked among mortals? Mainstream archaeology dismisses this theory, pointing out that the pyramids were built around 2500 BCE, not 10,500 BCE, and that the alignment with Orion's belt, while intriguing, may be coincidental. The ancient Egyptians left no written records explicitly stating that the pyramids were meant to mirror the stars, and yet the correlation remains, undeniable and haunting. But the stellar alignment is only one layer of the mystery. The pyramids are also aligned with extraordinary precision to the cardinal directions: north, south, east, and west. The Great Pyramid's north-south axis deviates from true north by only 3/60ths of a degree, an accuracy that would require sophisticated astronomical observations. How did the ancient Egyptians achieve this? They had no compasses, no GPS, no satellites. They had only the stars. One method they may have used is called the Indian Circle method, which involves tracking the rising and setting points of a star over the course of a night and bisecting the angle between them to find true north. Another method involves observing the circumpolar stars, stars that never set below the horizon, and using their circular path to determine the celestial pole. Either way, the process would have required patience, precision, and a deep understanding of the heavens. The interior of the Great Pyramid also reveals astronomical alignments. The so-called air shafts in the King's Chamber and Queen's Chamber are not air shafts at all, but narrow passages that point towards specific stars. The southern shaft of the King's Chamber aligns with Alnitak, the brightest star in Orion's belt, while the northern shaft points toward Thuban, which was the pole star in ancient Egypt. The southern shaft of the Queen's Chamber aligns with Sirius, the brightest star in the sky, associated with the goddess Isis. These alignments are not random, they are deliberate, encoded into the very structure of the pyramid. What were the ancient Egyptians trying to achieve? Some believe the shafts were meant to guide the pharaoh's soul on its journey to the stars, providing a direct path to the realm of the gods. Others suggest they served a more practical purpose, allowing priests to observe the stars from within the pyramid and perform rituals at specific astronomical moments. Still others propose that the shafts were part of a larger system of energy or resonance, channeling forces we no longer understand. The geometry of the pyramids also carries symbolic weight. The Great Pyramid's dimensions encode the mathematical constant pi, the ratio of a circle's circumference to its diameter. The pyramid's perimeter divided by twice its height equals 3/14, a number the ancient Egyptians were not supposed to know. They also encoded the golden ratio, phi, a proportion found throughout nature, and considered aesthetically perfect. The slope of the pyramid's sides, the dimensions of the chambers, the placement of the passages, all of these follow geometric principles that suggest a sophisticated understanding of mathematics and proportion. Was this knowledge intuitive, developed through trial and error over centuries of pyramid building, or was it inherited from an earlier, more advanced civilization, now lost to history? The ancient Egyptians themselves spoke of a time before the pharaohs, a golden age when the gods ruled directly over the land. They called it Zep Tepi, the first time, a mythical epoch when the foundations of civilization were laid. Could the pyramids be remnants of that forgotten age built by hands we no longer remember? The questions multiply the deeper we look. The pyramids are not just monuments. They are puzzles, riddles carved in stone. Every measurement, every alignment, every chamber and passage seems to whisper of something greater, something hidden just beyond our understanding. The ancients built them to last forever, and they built them to be read. But the language they used is not one of words. It is a language of stars and stone, of geometry and light. And if we could learn to read it, what would it say? The pyramids of Giza do not stand alone in the world. Across oceans and continents separated by thousands of miles and thousands of years, other civilizations built pyramids of their own. In the jungles of Mesoamerica, the Maya and the Aztecs raised stepped pyramids to honor their gods. In the deserts of Sudan, the Nubian kings constructed steep-sided pyramids as tombs. In China, massive earthen mounds shaped like pyramids hold the remains of emperors, and in the Pacific on remote islands, stone platforms and terraces echo the same geometric forms. Why? Why did so many cultures with no apparent contact choose the pyramid as their sacred shape? Was it simply the most stable structure to build with primitive tools? Or was there something deeper, a shared memory, a universal symbol, a message passed down through the ages? The Maya pyramids of Central America are perhaps the most striking parallel. The Temple of Kukulkan at Chichen Itza, the Temple of the Inscriptions at Palenque, the towering structures of Tikal, all of them share the same monumental ambition as the pyramids of Egypt. They were built as stairways to the heavens, places where priests could ascend to commune with the gods. They were aligned with astronomical events, solstices, equinoxes, the movements of Venus and the moon. They were tombs, temples and observatories all at once. The Temple of Kukulkan is a masterpiece of astronomical engineering. It has 4 staircases, each with 91 steps, which together with the platform at the top total 365, the number of days in a solar year. During the spring and autumn equinoxes, the setting sun casts shadows on the pyramid's northern staircase that create the illusion of a serpent descending from the heavens, a representation of the feathered serpent god Kukulkan. The Maya built this pyramid not just as a monument, but as a calendar, a cosmic clock marking the passage of time. The similarities to the Egyptian pyramids are undeniable, yet the differences are equally striking. The Maya pyramids are stepped, not smooth-sided, and they were built with a different purpose. Not as tombs for individual kings, but as communal temples where rituals were performed for the entire society. The Maya also developed a sophisticated writing system, a complex calendar, and advanced mathematical concepts, including the use of zero, achievements that rival those of ancient Egypt. Could the Maya and the Egyptians have shared knowledge? Conventional history says no. The Maya civilization flourished between 2000 BCE and 1500 CE, overlapping with ancient Egypt, but separated by an ocean that, as far as we know, neither culture crossed. There is no archaeological evidence of contact, no Egyptian artifacts found in Mesoamerica, no Maya glyphs discovered in Egypt. And yet, the parallels persist. Some researchers point to the legend of Atlantis, the lost civilization described by Plato, as a possible link. According to Plato, Atlantis was a powerful maritime empire that existed around 9600 BCE, before being destroyed in a cataclysmic event. If such a civilization existed, could it have spread its knowledge to both Egypt and Mesoamerica before its fall? Could the pyramids be remnants of that lost wisdom, built by cultures trying to preserve what they had learned? Mainstream scholars dismissed the Atlantis theory as myth, noting that Plato likely invented the story as a philosophical allegory. There is no geological evidence for a sunken continent in the Atlantic, and the timeline Plato gives does not match the known history of human civilization. But the idea persists, fueled by the tantalizing similarities between ancient cultures and the sense that something is missing from the historical record. In China, the pyramids are less well known but no less impressive. Near the city of Xi'an, dozens of massive earthen mounds rise from the plains, some as tall as 300 feet. These are the tombs of ancient Chinese emperors, built during the Qin and Han dynasties. The most famous is the tomb of Emperor Qin Shi Huang, guarded by the Terracotta Army. Thousands of life-size clay soldiers buried to protect the emperor in the afterlife. The tomb itself has never been fully excavated, but ancient texts describe it as a vast underground palace, complete with rivers of mercury and a ceiling studded with pearls to represent the stars. The Chinese pyramids are not as geometrically precise as those in Egypt, but they share the same symbolic purpose: to bridge the gap between earth and heaven, to ensure the ruler's immortality, to encode cosmic order into physical form. The Chinese also developed sophisticated astronomical knowledge, tracking the movements of planets and stars, predicting eclipses, and aligning their structures with celestial events. In Sudan, the Nubian pyramids stand as a testament to a civilization that was once Egypt's rival, and, at times, its conqueror. The Nubian kings built more than 200 pyramids, smaller and steeper than their Egyptian counterparts, but no less significant. These pyramids were tombs, filled with treasures and inscriptions honouring the dead. The Nubians adopted many aspects of Egyptian culture, including the worship of Egyptian gods and the use of hieroglyphic writing, but they also maintained their own distinct identity. The fact that the Nubians built pyramids is less surprising, given their proximity to Egypt and their long history of cultural exchange. But it raises another question. If the pyramid form was so powerful, so meaningful, why did it eventually disappear? Why did later civilizations abandon it in favour of other architectural styles? Perhaps the answer lies in the changing nature of belief. The pyramids were built during a time when the boundary between the human and the divine was thin, when kings were seen as gods, and the afterlife was as real as the world of the living. As religions evolved, as empires rose and fell, the need for such monumental expressions of faith diminished. The pyramids became relics of a bygone age, admired but no longer understood. Or perhaps the pyramids served a purpose that was fulfilled. Perhaps the message they were meant to convey was delivered, and there was no need to build more. Perhaps they were never meant to be replicated, only remembered. But what if the pyramids were not just monuments to the past? What if they were also messages to the future, to us? In the modern age, the pyramids have become the subject of countless theories, some grounded in science, others veering into the realm of speculation and wonder. They have been called power plants, energy generators, acoustic chambers, astronomical computers, and even landing markers for extraterrestrial visitors. Each theory attempts to explain the same fundamental mystery. How could a civilization with such limited technology create something so advanced? One of the most intriguing theories involves the idea that the Great Pyramid was designed to harness energy. Proponents of this theory point to the pyramid's construction materials: limestone, which contains calcite crystals that can generate electricity under pressure, and granite, which contains quartz and is slightly radioactive. The king's chamber is built entirely of granite, and some researchers have detected unusual electromagnetic readings within it. Could the pyramid have been designed to generate or amplify energy in some way? The theory suggests that the pyramid's shape itself acts as a resonator, focusing energy at specific points within the structure. The Grand Gallery, with its towering corbelled ceiling, may have functioned as an acoustic chamber, amplifying sound waves to create resonance. Some experiments have shown that certain frequencies produce standing waves within the pyramid, creating patterns of vibration that could theoretically be harnessed for various purposes. But what purposes? Advocates of the energy theory propose that the pyramid could have been used for healing, communication, or even levitation, using sound and vibration to manipulate matter. Ancient texts speak of priests using sound to move heavy objects, and some researchers believe the pyramids were built using acoustic levitation, a phenomenon where sound waves create enough pressure to lift objects off the ground. Modern science has demonstrated acoustic levitation on a small scale, but whether it could be used to move multi-ton blocks remains unproven. Another theory focuses on the pyramid's alignment with Earth's geography. The Great Pyramid sits almost exactly at the centre of the Earth's landmass, with equal amounts of land in all directions. Its latitude and longitude coordinates encode the speed of light, 299,458 meters per second, a number the ancient Egyptians were not supposed to know. Coincidence, or evidence of knowledge far beyond what we attribute to them? The pyramid's dimensions also encode the size and shape of the Earth. The perimeter of the pyramid's base multiplied by 43,200 equals the circumference of the Earth at the equator. The height of the pyramid multiplied by the same number equals the polar radius of the Earth. The number 43,200 is significant in many ancient cultures. It appears in Hindu cosmology, in Babylonian astronomy, and in the precessional cycle of the equinoxes. Could the pyramid be a scale model of the Earth, built to preserve geodetic knowledge? Mainstream archaeologists argue that these numerical correlations are the result of selective interpretation, that if you look hard enough, you can find mathematical patterns in any structure. They point out that the ancient Egyptians used a different system of measurement, the royal cubit, and that converting their measurements to modern units inevitably produces approximations and errors. The speed of light encoded in the coordinates, they say, is a coincidence. a product of our modern numbering system rather than ancient intent. But the theories persist, fueled by the sense that the pyramids are more than they appear. Some researchers have proposed that the pyramids were part of a global network of ancient structures, all aligned with each other and with specific points on the Earth's energy grid. Ley lines, they call them, invisible lines of power that crisscross the planet, connecting sacred sites and ancient monuments. The pyramids of Giza, Stonehenge, the Nazca Lines, Easter Island, all of them, according to this theory, are nodes in a vast system of energy and communication. The idea of a global civilization, one that existed before recorded history and possessed advanced knowledge, has captured the imagination of many. Graham Hancock, a journalist and author, has spent decades researching this possibility, arguing that a cataclysmic event around 12,000 years ago, possibly a comet impact or rapid climate change, destroyed this civilization, leaving only scattered remnants and myths. The pyramids, he suggests, may be survivors of that lost age, built by people who knew the world was ending and wanted to preserve their knowledge for future generations. Hancock points to geological evidence of rapid sea level rise at the end of the last ice age, which would have flooded coastal areas where early civilizations might have thrived. He also notes the prevalence of flood myths in cultures around the world, the story of Noah's Ark, the Epic of Gilgamesh, the Hindu tale of Manu, the Greek legend of Deucalion. Could these myths be memories of a real event, a global catastrophe that reset human civilization? Critics argue that Hancock's theories lack concrete evidence and rely too heavily on speculation. They point out that the archaeological record shows a clear progression of human development, from simple hunter-gatherer societies to complex civilizations, with no need to invoke a lost advanced culture. The similarities between ancient myths, they say, can be explained by the universal human experience of natural disasters, floods, earthquakes, volcanic eruptions, rather than a single global event. And yet, the questions remain. Why do the pyramids exist? Why were they built with such precision, such ambition, such permanence? What were the ancient Egyptians trying to achieve, and what did they want us to know? Perhaps the answer is simpler than we think. Perhaps the pyramids were built not to encode secret knowledge or harness mysterious energies, but to inspire awe, to remind us of what humanity is capable of when we work together toward a common goal. Perhaps they were built to last forever because the ancients understood something we have forgotten, that civilizations rise and fall, that empires crumble, that everything we build will eventually turn to dust. Everything except the pyramids. They stand as a testament to human ambition, human ingenuity, human faith. They stand as a reminder that we are part of something larger than ourselves, something that stretches back through time and forward into eternity. They stand as a question, carved in stone, waiting for us to answer. What if the message the ancients tried to tell us is not hidden in the measurements, or the alignments, or the chambers? What if the message is the pyramids themselves, the simple, profound fact that they exist, that they endure, that they refuse to be forgotten? But perhaps we've been asking the wrong questions all along. We ask how they were built, as if understanding the engineering would unlock the mystery. We ask why they were built, as if discovering the purpose would satisfy our curiosity. We measure and calculate and theorize, treating the pyramids as problems to be solved rather than mysteries to be experienced. And in doing so, we may be missing what the ancients actually wanted us to see. Because the pyramids were not built in isolation. They were not constructed in a vacuum of history, dropped fully formed onto the Giza Plateau by some inexplicable force. They emerged from a culture, a civilization, a way of seeing the world that was fundamentally different from our own. To understand what the ancients tried to tell us, we must first understand who they were, not just as builders or engineers or priests, but as human beings living in a world alive with meaning. The Egypt of the Fourth Dynasty was not the Egypt of popular imagination. It was not a land of slaves toiling under the whip, building monuments to tyrannical pharaohs drunk on power and vanity. That image, perpetuated by Hollywood and centuries of misunderstanding, bears little resemblance to what archaeology has revealed. The people who built the pyramids were skilled workers, craftsmen, and labourers who took pride in their work. They lived in purpose-built villages near the construction sites, with bakeries, breweries, and medical facilities. They were fed with meat and bread, a diet far richer than what most Egyptians consumed. Their bones show evidence of medical care. Broken limbs that were set and healed, infections that were treated, workplace injuries that were tended to with surprising sophistication. These were not expendable slaves, but valued members of society, participating in what they believed to be the most important work in the world. Graffiti left by work gangs inside the pyramids reveal something even more striking. These workers organized themselves into teams with names like Friends of Khufu and Drunkards of Menkaure. They competed with each other, marking their accomplishments in red ochre on the stones they placed. There is humour in these inscriptions, pride, camaraderie. These were not people coerced into labour, but people who believed they were building something sacred, something that would ensure the prosperity of Egypt and the eternal life of their king. Why would they believe this? Why would tens of thousands of people devote decades of their lives to moving stones? The answer lies in the Egyptian understanding of Ma'at, a concept that has no direct translation in English, but encompasses truth, justice, harmony, and cosmic order. Ma'at was not just a philosophical idea, it was the fundamental principle that held the universe together. The pharaoh was the guarantor of Ma'at, the living link between the human world and the divine realm. When the pharaoh died, the entire cosmic order was threatened. The pyramid was not just a tomb, it was a machine for maintaining Ma'at, for ensuring that the king could be transformed into a god and continue to protect Egypt from the chaos that lurked at the edges of creation. This is why the pyramid had to be perfect. This is why every measurement mattered, why every stone had to be precisely placed, why the alignment with the stars could not be off by even a fraction of a degree. The pyramid was not a monument to ego, it was a cosmic necessity, a ritual performed in stone to keep the universe functioning. The religious texts of ancient Egypt support this interpretation. The pyramid texts carved into the walls of later pyramids are among the oldest religious writings in human history. They describe the pharaoh's journey after death, how he ascends to the sky, how he joins the circumpolar stars that never set, how he becomes one with the gods. The pyramid is described as a ladder, a ramp, a stairway to heaven. The pharaoh climbs the rays of the sun, sails across the sky in the solar bark, passes through the gates of the underworld, and emerges transformed. These texts are not metaphorical. To the ancient Egyptians, this journey was as real as any physical voyage. The pyramid was the vehicle that made it possible, and every element of its construction served this ultimate purpose. The passages and chambers were not arbitrary. They were maps of the afterlife, recreations of the cosmic landscape the pharaoh would traverse. The sarcophagus in the king's chamber was not just a box for a body, it was a womb of regeneration, where the dead king would be reborn as a star. Understanding this changes everything about how we interpret the pyramids. The air shafts are not ventilation, they are soul channels, pathways for the K, life force, and Bear, personality, to travel between the burial chamber and the stars. The Grand Gallery is not just an architectural feature, it is a representation of the ascending path to heaven, a physical embodiment of the moment of transformation. The empty sarcophagus is not evidence of tomb robbery. It may never have been meant to hold a physical body at all, only to serve as a symbolic vessel for spiritual rebirth. This religious context also explains something else that has puzzled researchers: why the interior of the Great Pyramid is so austere. There are no paintings, no decorations, no gold or jewels. Later Egyptian tombs would be filled with treasures and adorned with elaborate paintings depicting the deceased's life and afterlife. But the Great Pyramid is bare stone, its chambers unadorned except for a few marks left by construction workers. Why? Perhaps because the pyramid itself is the message. Perhaps because the geometry, the proportions, the alignments, these were the decorations more meaningful than any image could be. Perhaps because the pyramid was meant to function, not to impress, and every element served a purpose beyond the aesthetic. Or perhaps because the pyramid was built for an understanding of the divine that transcended images, that saw the sacred in number and proportion, and cosmic correspondence rather than in representation. Yet even within this religious framework, mysteries persist. The more we learn about the ancient Egyptians, the more sophisticated they appear, and the more questions arise about where their knowledge came from. Consider their understanding of medicine. The Edwin Smith Papyrus, dating to around 1600 BCE but likely copied from much older sources, describes 48 surgical cases with a rational empirical approach that would not be seen again until the classical Greek period. The Egyptians performed surgery, set broken bones, treated infections, and even conducted a form of brain surgery. They understood the pulse and recognized it as connected to the heart. They used honey as an antibiotic, willow bark as a painkiller, and mouldy bread as a treatment for infections, techniques that modern science has confirmed as effective. Their understanding of mathematics was equally advanced. They used a decimal system and could solve complex problems involving fractions, areas and volumes. They calculated the area of a circle using a formula that approximates pi to within less than 1% of accuracy. They understood the Pythagorean theorem 1,000 years before Pythagoras. The Moscow mathematical papyrus shows calculations for the volume of a truncated pyramid, the exact knowledge needed to plan the construction of the pyramids themselves. Their astronomy went far beyond simple observation. They tracked the movement of the sun, moon and planets with precision. They identified the heliacal rising of Sirius, the moment when the star becomes visible again after a period of being obscured by the sun's light, and used it to predict the annual flooding of the Nile. They divided the year into 365 days, with 12 months of 30 days each plus 5 extra days, a calendar system so accurate it formed the basis for the Julian calendar used throughout Europe until the Renaissance. They mapped the night sky into 36 decans, 10-degree segments of the celestial sphere, and used them to tell time at night. Each decan would rise above the horizon at a specific time, allowing the Egyptians to divide the night into hours. This system required not just observation but calculation, accounting for the precession of the equinoxes and the slow shift of the stars over decades and centuries. Where did all this knowledge come from? The standard historical answer is that it developed gradually, through generations of observation and experimentation. The Egyptians built smaller pyramids before they built the Great Pyramid, learning from their mistakes and refining their techniques. They studied the stars because they needed a calendar for agriculture. They developed mathematics because they needed to survey land after the annual floods. Each advance built upon the previous one in a logical progression. But some researchers see gaps in this narrative. The first pyramid ever built, the Step Pyramid of Djoser, was already a massive and sophisticated structure, rising 200 feet into the air and incorporating complex internal passages. It appears almost fully formed, with no obvious prototype or failed experiment preceding it. The Great Pyramid itself represents a level of ambition and precision that seems to leap beyond what the earlier pyramids would suggest as possible. And after the Fourth Dynasty, pyramid construction rapidly declined in quality. Later pyramids were smaller, cruder, built with inferior materials and less skill. It is as if the knowledge peaked and then faded, rather than building continuously over time. This pattern suggests to some that the knowledge might have been inherited rather than developed, passed down from an earlier period or even an earlier civilization. The ancient Egyptians themselves spoke of the Zep Tepi, the first time when gods ruled directly over the land and taught humanity the arts of civilization. They attributed their knowledge to these divine teachers. Thoth, the god of wisdom; Ptah, the god of craftsmen; Imhotep, the architect of the Step Pyramid who was later deified. Were these gods simply mythological figures, personifications of abstract concepts? Or were they memories of real individuals, wise teachers or leaders whose accomplishments were so remarkable they were remembered as divine? Every culture has flood myths. Many cultures have legends of culture heroes who brought knowledge from somewhere else. The Sumerians spoke of the Apkallu, 7 sages who emerged from the sea to teach humanity. The Mesoamericans spoke of Quetzalcoatl, the feathered serpent who brought wisdom. The Indians spoke of the rishis, enlightened beings who composed the Vedas. Are these all independent inventions or echoes of something real? Mainstream archaeology remains skeptical, pointing out that myths are not evidence, and that the archaeological record shows a clear developmental sequence. But the question lingers: why did the ancient Egyptians, at the very beginning of their civilization, build the most sophisticated and enduring structures they would ever create? Why does their greatest achievement appear at the start rather than the culmination of their culture? The mysteries deepen when we look beyond the pyramids themselves to the entire Giza complex, a landscape of stone and symbol that may encode layers of meaning we are only beginning to glimpse. The Great Sphinx is perhaps the most enigmatic element. Carved from a single outcrop of limestone, It sits in a hollow surrounded by walls of bedrock, staring eternally toward the east. Egyptologists traditionally date it to the reign of Khafre, around 2500 BCE, based on its proximity to Khafre's pyramid and the stylistic similarity of its face to known images of the pharaoh. But the Sphinx bears signs of weathering that some geologists argue could only have been caused by prolonged exposure to water. Not the occasional rain that falls in Egypt today, but sustained rainfall of the kind that ended in the region around 10,000 BCE. Robert Schoch, a geologist from Boston University, examined the Sphinx in the early 1990s and concluded that the erosion patterns on its body and the walls of its enclosure were characteristic of water weathering rather than wind and sand erosion. If true, this would mean the Sphinx is far older than the pyramids, carved during a wetter climate when the Sahara was still green. The implications are staggering. It would suggest that sophisticated stone carving was practiced in Egypt thousands of years before the emergence of the pharaonic civilization. Orthodox Egyptologists dispute this interpretation, arguing that the weathering could be explained by other factors: underground water seepage, variations in the limestone's quality, or differences in how the stone was exposed and protected over millennia. They point out that there is no archaeological evidence of a civilization capable of carving the Sphinx before 3000 BCE. No tools or settlements or other monuments from that period. The debate remains unresolved, with each side marshalling evidence and neither willing to concede. But whether the Sphinx is 4,500 or 12,000 years old, its purpose remains mysterious. Its body is that of a lion, a creature that held powerful symbolic meaning in ancient Egypt, representing strength, protection, and the fierce heat of the sun. Its face is human, creating a hybrid creature that bridges the animal and divine realms. In Egyptian tradition, the Sphinx was a guardian, a protector of sacred places, a creature that posed riddles to those who approached. What riddle does the Sphinx of Giza pose? What is it guarding? Some believe the Sphinx sits above hidden chambers, secret rooms that contain the lost knowledge of ancient Egypt, or of an even older civilization. In the 1990s, ground-penetrating radar and seismic studies suggested the presence of voids beneath the Sphinx and in the bedrock around it. Edgar Cayce, the famous American psychic, claimed in the 1930s that a hall of records lay hidden beneath the Sphinx, containing the wisdom of Atlantis. When the chamber was opened, he predicted, humanity would gain access to advanced knowledge about energy, healing, and the nature of consciousness itself. Excavations have been limited by the Egyptian government, which is cautious about potentially damaging one of the world's most iconic monuments. Small explorations have revealed shafts and cavities, but nothing matching the grand chamber Cayce described. Yet the possibility haunts researchers and enthusiasts alike. What if there is something down there, waiting to be discovered? What if the ancients really did hide their most important knowledge beneath their most enigmatic monument? Around the Sphinx and pyramids, other structures add to the mystery. The Valley Temple and the Sphinx Temple, built from massive limestone blocks weighing up to 200 tons, display a style of construction distinctly different from the pyramids, more ancient, some argue, with stones fitted together so precisely that no mortar was needed. The causeway that once connected the Valley Temple to Khafre's pyramid stretched nearly a quarter-mile and was roofed with stone slabs, creating a processional corridor where rituals were performed. And then there are the boat pits, long trenches carved into the bedrock around the pyramids, some containing disassembled cedar boats sealed in limestone blocks. One of these boats, excavated in 1954, was reassembled and found to be 143 feet long, one of the largest and oldest ships ever discovered. It had never been in water. It was built specifically to be buried. Was it meant to carry the pharaoh's spirit across the celestial Nile? Or did it serve some other symbolic function we no longer understand? Every element of the Giza complex seems to carry meaning, to be part of a larger design. The three pyramids, the Sphinx, the temples, the causeways, the boat pits, all of them aligned, positioned, built according to a master plan that unified earth and sky, life and death, the human and the divine. The Giza Plateau was not just a burial ground. It was a sacred landscape, a three-dimensional map of Egyptian cosmology. And perhaps, just perhaps, it was also a message, encoded in stone, meant to be read by those who came after. In recent decades, technology has allowed us to see the pyramids in ways the ancient Egyptians never could, and in ways that, raise new questions even as they answer old ones. In 2017, an international team of researchers used muon tomography, a technique that detects cosmic ray particles passing through solid matter, to scan the interior of the Great Pyramid. They discovered a previously unknown void above the Grand Gallery, a space at least 100 feet long with a similar structure to the Grand Gallery itself. The discovery made headlines around the world. A hidden chamber in the Great Pyramid, unseen for 4,500 years. But what is it? Why is it there? The researchers were careful to call it a void rather than a chamber, noting that they couldn't determine its function without further exploration. Egyptologists suggested it might be a structural feature, a relieving chamber meant to reduce the weight pressing down on the Grand Gallery below. Others speculated it could be a sealed room containing treasures or inscriptions, deliberately hidden by the pyramid's architects. As of now, the void remains unexplored. The Egyptian authorities have been reluctant to allow invasive techniques that might damage the pyramid, and there is no easy way to access the space without drilling or excavating. So it sits there, a tantalizing mystery within the greatest mystery of the ancient world, waiting. Other technologies have revealed different secrets. LiDAR scanning, using laser light to create detailed three-dimensional maps, has shown that the pyramids are not quite as smooth and regular as they appear to the naked eye. The Great Pyramid's sides are actually slightly concave, curving inward by about a foot on each face. This feature is invisible from the ground but becomes apparent from aerial photographs taken at the right angle and time of day. Why would the ancient Egyptians build this concavity into the structure? Some believe it was meant to create an optical effect, making the pyramid appear to shimmer or glow when the sun hit it at certain angles. Others suggest it served a structural purpose, distributing weight more evenly. Still, others wonder if it carries symbolic meaning, representing the curvature of the Earth or the path of light rays from the sun. Thermal imaging has revealed that different blocks within the pyramids retain heat at different rates, suggesting they came from different quarries or were treated differently during construction. Some blocks contain fossils of ancient marine creatures, proof that the limestone was formed from the beds of prehistoric seas. Analysing these fossils allows researchers to trace where specific stones came from, mapping the supply chains that brought materials to Giza from across Egypt. Even more remarkable, archaeologists have discovered the remains of ramps, workshops, and harbour facilities that supported the pyramid construction. At Wadi al-Jarf on the Red Sea coast, researchers found papyrus scrolls written by a man named Mera, an overseer who helped transport limestone blocks from the quarries at Tura to Giza. The scrolls, dating to the reign of Khufu, describe the logistics of moving stone, the number of workers, the routes taken, the time required. They are the only contemporary written records of pyramid construction ever found, and they confirm what archaeology has suggested. The pyramids were built through meticulous planning, vast organisational effort, and the coordinated labour of thousands. But even with all these technological advances, even with new discoveries and better data, the fundamental mystery remains. We know more about how the pyramids were built, but we still don't entirely understand why they were built the way they were. We can see the stones, measure the angles, trace the supply chains, but we cannot fully grasp the vision that motivated their creation. Because the vision was not technological. It was not even primarily architectural. It was spiritual, cosmological, an attempt to capture something eternal in temporary materials, to build a bridge between the finite and the infinite. And that is something no technology can measure. Perhaps the most profound mystery of the pyramids is not what they are, but what they represent, what they reveal about the human condition and our relationship with time, mortality, and meaning. We build because we must. It is in our nature to create, to shape the world around us, to leave something behind that says, I was here, I mattered, I existed. Every culture in history has built monuments, from the standing stones of Neolithic Europe to the skyscrapers of modern cities. We build to honour our gods, to remember our dead, to celebrate our achievements, to mark our territory, to express our dreams. But the pyramids are different. They were not built to serve a temporary need or to impress a contemporary audience. They were built to last forever, and they have succeeded. They have outlasted the language that named them, the religion that sanctified them, the civilization that created them. They have become universal symbols, recognized by every culture on Earth, transcending their original context to speak to something fundamental in the human experience. What do they speak of? They speak of the desire to transcend death, to create something that will endure when our bodies have turned to dust. They speak of the human need for order, for structure, for permanence in a world of chaos and change. They speak of our fascination with the heavens, our conviction that we are connected to something larger than ourselves. They speak of the power of collective effort, of what can be achieved when thousands of people work together toward a shared goal. But perhaps, most profoundly, they speak of the human relationship with mystery itself. We live in an age that values answers, that seeks to explain everything, to reduce the unknown to the known. We sequence genomes, map the cosmos, peer into the quantum realm. We accumulate data, build models, predict outcomes. We have grown uncomfortable with uncertainty, with questions that have no clear solutions. The pyramids remind us that mystery is not something to be eliminated, but something to be honoured. They remind us that there are things we may never fully understand, and that this is not a failure, but a gift. They remind us that the search for meaning is often more important than the meaning itself, that the questions we ask shape who we are just as much as the answers we find. The ancients who built the pyramids understood this. They created a mystery deliberately, encoding layers of meaning that would reveal themselves slowly, over centuries, to those who looked with patience and humility. They knew that future generations would wonder at their achievement, would ask questions, would search for answers, and they knew that in that searching something important would happen. A connection would be made across time, between the living and the dead, between the known and the unknown. That connection is what the pyramids offer us. Not answers, but connection. Not certainty, but wonder. Not explanation, but inspiration. When we stand before the pyramids, we stand in the presence of something that has witnessed the full sweep of recorded history. We stand before a monument that was already ancient when Rome was founded, already legendary when Athens flourished, already mysterious when medieval pilgrims came to marvel at it. We stand before something that will likely still be standing when our own civilization has become history, when our skyscrapers have crumbled and our digital archives have decayed into corruption. And in that moment, we are confronted with our own mortality, not as individuals, but as a species, as a civilization, as a moment in time. We are forced to ask, what will we leave behind? What will future generations find when they dig through the ruins of our age? Will they wonder at our achievements as we wonder at the pyramids? Will they ask questions about us as we ask questions about ancient Egypt? Will they find meaning in what we have created, or will they see only the debris of a culture that lost its way? The pyramids challenge us to think beyond our own lifetimes, beyond our own moment in history. They challenge us to create not just for ourselves, but for the future, to build things that matter, that endure, that carry meaning across generations. They challenge us to reach for something greater than comfort or convenience, to invest our energy in something that transcends the immediate and the practical. In this way, the pyramids are not just relics of the past. They are mirrors reflecting our own values, our own priorities, our own dreams and fears. What we see in them says as much about us as it does about the people who built them. As the 21st century unfolds, the pyramids continue to inspire new theories, new explorations, new interpretations. Each generation brings its own questions, shaped by its own concerns and shaped by its own understanding of the world. In an age of environmental crisis, some see the pyramids as lessons in sustainability. Structures built without machines, without fossil fuels, without the industrial processes that have brought our own civilization to the brink of ecological collapse. They wonder, could we build something as enduring today, using only human labour and simple tools? Or have we become so dependent on technology that we have lost the fundamental skills and patience required for such a feat? In an age of artificial intelligence and digital technology, some see the pyramids as embodiments of encoded information, massive solid-state storage devices built to preserve knowledge across millennia. They speculate about what might be hidden in the ratios, the measurements, the astronomical alignments, data waiting to be decoded by minds equipped with the right tools and the right perspective. In an age of space exploration, some see the pyramids as Earth's first monuments to the cosmos, our earliest attempt to reach toward the stars, to connect our terrestrial existence with the celestial realm. They imagine future civilizations building pyramids on Mars or the Moon, carrying forward an architectural tradition that began on the Giza Plateau more than 4,000. The pyramids of Giza are not just monuments to the past. They are bridges to the future, connecting us to the people who built them, reminding us that we are part of a story that began long before we were born and will continue long after we are gone. They are proof that humanity has always looked up at the stars and wondered, always sought to leave a mark, always believed in something beyond the visible world. And as long as the pyramids stand, that belief will endure. The message will remain, waiting in the stone, waiting in the silence, waiting for the next person to stand before them and ask, what were the ancients trying to tell us? Perhaps the answer is that they were trying to tell us we are not alone in time, not alone in space, not alone in our dreams and our fears and our hopes. They were trying to tell us that we are part of something vast and ancient and eternal, something that connects us to every human who has ever lived and every human who will ever live. They were trying to tell us that we matter, that what we build matters, that what we believe matters, that the questions we ask matter, even if we never find the answers. The pyramids stand in the darkness now, their shapes barely visible against the night sky. But they are there, as they have always been, as they will always be. Silent witnesses to the passage of time, keepers of secrets we may never fully understand, monuments to the enduring human spirit. And somewhere in that silence, in that darkness, in that eternal stone, the message waits. The message the ancients tried to tell us. The message we are still learning to hear. What if the pyramids were not built just to honour the dead, but to speak to the living, to send a message across time? The question echoes across the desert, across the centuries, across the vast expanse of human history. And the pyramids, patient and eternal, wait for us to answer. The search for answers has never stopped. Each generation brings new tools, new methods, new ways of peering into the ancient stones. And with each advance, we discover not just answers, but more questions, deeper, stranger, more challenging questions that force us to reconsider everything we thought we knew. In recent years, the pace of discovery has accelerated. Between 2021 and 2023, researchers employed ground-penetrating radar and electrical resistivity tomography to study areas near the Great Pyramid, revealing an anomaly combining a shallow L-shaped structure connected to a deeper structure, with the shallow portion filled in with sand after construction. The purpose of this structure remains unknown, but its very existence suggests that the Giza complex holds secrets still waiting to be uncovered. The technology that made this discovery possible would have seemed like magic to the ancient Egyptians, machines that can see through solid rock, that can map what lies beneath the sand without disturbing a single grain. We send cosmic rays through the pyramids, tracking how they bend and scatter to reveal hidden voids. We bounce radio waves off underground structures, building three-dimensional maps of spaces no human eye has seen in millennia. We measure subtle variations in gravity and magnetism, detecting anomalies that hint at chambers, passages, corridors carved from the living rock. And yet, for all our technological sophistication, we remain humbled by what the ancients achieved. Every new discovery reveals not how simple the pyramids are, but how complex. Not how crude their construction was, but how refined. Not how much we have surpassed them, but how much we still have to learn from them. In 2024, researchers discovered that some 31 pyramids in Egypt may originally have been built along a 64-kilometre-long branch of the Nile, which has long since been buried beneath farmland and desert. This extinct river branch, called the Ahramat branch, had causeways from many pyramids ending at its proposed riverbanks, suggesting it was used for transporting construction materials. The discovery transforms our understanding of the logistical network that made pyramid construction possible. The stones did not have to be dragged across miles of desert. They could be floated on barges, carried by the river itself to the very foot of the construction site. But this raises new questions. When did this branch of the Nile disappear? Was it still flowing during the 4th dynasty, or had it already begun to dry up? Did the ancient Egyptians choose the Giza plateau because of the river, or did they build there despite its remoteness, for reasons we don't yet understand? And what other river branches might have existed connecting other pyramid sites, leaving no trace except in the placement of monuments, that now seem impossibly isolated. The landscape of ancient Egypt was not the landscape we see today. The climate was different, wetter in some periods, drier in others. The river itself wandered across the floodplain, changing course, splitting into branches, reuniting. The desert advanced and retreated. Forest grew where now there is only sand. The world the pyramid builders knew has been erased, buried beneath millennia of change, leaving us to reconstruct it from fragments and shadows. And beneath the surface, there may be more waiting to be found. In March 2025, a team of researchers made headlines with claims of discovering vast underground structures beneath the Khafra pyramid. The announcement spread rapidly across social media and news outlets, with some calling it evidence of an ancient underground city, extending hundreds of feet below the Giza Plateau. The researchers claimed to have used satellite-based radar technology to detect chambers, shafts, and interconnected passages far below the pyramid. The response from the archaeological community was swift and sceptical. Egypt's renowned archaeologist Zahi Hawass called the findings fake news, saying the researchers used techniques that are not approved and not validated and lack any scientific basis. Hawass noted that the Khafra pyramid was studied extensively and determined to have been carved directly from bedrock, making all claims regarding the existence of columns beneath it entirely unfounded. Other experts questioned the technical feasibility of the claims. Radar specialists pointed out that the technology described would not be able to penetrate solid rock to the depths claimed, and that mapping detailed structures hundreds of feet underground from satellite imagery would be impossible with current methods. The research had not been published in peer-reviewed journals, and the methodology remained unclear. Yet the episode reveals something important about our relationship with the pyramids. We want them to hold secrets. We need them to be more than they appear. The idea of hidden chambers, underground cities, lost knowledge waiting to be discovered. These narratives speak to something deep in the human psyche. We are drawn to mystery, to the possibility that beneath the known world lies another world, stranger and more wondrous. And sometimes, that need for mystery leads us astray. It tempts us to see patterns where none exist, to accept claims without evidence, to prefer speculation over science. The pyramids have spawned countless theories, many of them fanciful, some of them deliberately deceptive. Crystal skulls, alien architects, time machines, energy weapons. The pyramids have been credited with everything from healing powers to prophecies of the apocalypse. But separating fact from fiction, legitimate research from pseudoscience, is not always easy. The line between revolutionary discovery and wishful thinking can be thin. New technologies do reveal hidden structures. The 2017 muon tomography scan that found the void above the Grand Gallery was real science, published in peer-reviewed journals, confirmed by multiple independent teams. But claims must be tested, verified, scrutinized before they can be accepted. The pyramids deserve better than sensationalism. They deserve serious study, careful analysis, honest inquiry. They deserve our respect, not just for what we imagine them to be, but for what they actually are. Monuments built by real people, with real tools for real purposes that we are still learning to understand. Amid all the speculation about advanced technology and lost civilizations, it is easy to forget the most important truth about the pyramids. They were built by human beings, not gods, not aliens, not some vanished super race, but people, men and women who lived and worked and died on the Giza Plateau 4,500 years ago. Recent discoveries have brought these people into sharper focus. At the site of Tombos in Nubia, archaeologists unearthed skeletons buried within pyramids dating to between 1400 and 650 BCE, with some individuals showing signs of wear and tear likely caused by a lifetime of hard manual labour. This has led researchers to conclude that pyramid burials in Tombos were more inclusive than previously thought, and that the deceased came from both the upper and lower classes. The discovery challenges long-held assumptions about who was honoured with pyramid burial. For generations, archaeologists assumed that only the elite, royalty, nobility, high-ranking officials, were laid to rest in these monumental tombs. But the evidence suggests a more complex reality. Perhaps the pyramids were not just monuments to individual power, but communal projects that honoured all who participated in their creation. Perhaps the workers who dragged the stones, who carved the blocks, who mixed the mortar, were remembered alongside the kings they served. This fits with what we know about the workers' villages near the pyramids. These were not slave quarters, but organised communities with infrastructure, social hierarchies, and a sense of collective purpose. The people who lived there were farmers during the flood season, when their fields were underwater and agricultural work was impossible. They came to Giza to work on the pyramids as a form of labour tax, contributing their strength to the most important project in the kingdom. But they also came for other reasons. They came because working on the pyramid meant being part of something eternal, something that would outlast their brief lives. They came because it brought honour to their families, recognition to their villages. They came because they believed, genuinely, deeply believed, that the pyramid was necessary, that it would ensure the pharaoh's transformation into a god and thereby guarantee the prosperity of Egypt itself. We have lost this sense of collective purpose, this willingness to sacrifice for something beyond immediate benefit. Our societies are fragmented, individualistic, focused on short-term gains. We struggle to coordinate projects that span decades, let alone centuries. We cannot imagine devoting our lives to building something we will never see completed. Yet the pyramid builders did exactly that. The Great Pyramid took 20 years to build, an entire generation of workers who began the project knowing they might not live to see it finished. They laid stones that would be buried within the structure, invisible to future generations, yet they laid them with precision and care because the work itself mattered, not the recognition. This is perhaps the most profound lesson the pyramids teach us. That meaning is not found in personal glory or individual achievement, but in contributing to something larger than ourselves. The pyramid is greater than any single person who built it, greater than the pharaoh entombed within it, greater than the architects who designed it. It is the sum of thousands of individual efforts, coordinated toward a single vision, sustained across decades by shared belief. Can we do that today? Can we build our own pyramids? Not literal monuments of stone, but projects of comparable ambition and permanence? Can we think in centuries rather than quarters? Can we work toward goals we will not live to see achieved? Can we create things meant not for ourselves, but for the distant future? The question is not rhetorical. Humanity faces challenges that require exactly this kind of long-term thinking. Climate change, resource depletion, space exploration, the preservation of knowledge across generations. We need to build metaphorical pyramids, infrastructure, institutions, archives, that will endure long after we're gone. We need to rediscover the mindset that made the pyramids possible. The pyramids have stood for 45 centuries. Think about what that means. Think about everything they have witnessed. They were already ancient when the first Olympic Games were held in Greece. They were already monuments of unfathomable age when Julius Caesar came to Egypt and stood before them, marvelling at their antiquity. They were already older to the Roman Empire than the Roman Empire is to us. They watched as the ancient Egyptian civilization slowly declined, as the new kingdom gave way to foreign rule, as Greeks and Romans and Arabs conquered the land. They watched as the old religion was abandoned, as the temples were closed, as the hieroglyphic script was forgotten. They watched as Christianity spread across the region, as churches were built from the stones of ancient monuments, as the old gods were condemned as demons. They watched the rise of Islam, the Arab conquest of Egypt, the building of Cairo from the casing stones stripped from their sides. They watched the Crusades, the wars between Christian and Muslim powers fighting over this ancient land. They watched the Mongol invasions that devastated so much of the world, but somehow left Egypt intact. They watched as the Ottoman Empire absorbed Egypt into its vast domains, as European powers began to take interest in the ancient monuments, as Napoleon's soldiers fired cannons at the Sphinx's face. Or so the legend says, though the truth is more prosaic. The face was already damaged by centuries of erosion and iconoclasm. They watched the birth of Egyptology as a discipline, as Western scholars descended on Egypt with shovels and dynamite, racing to unearth treasures for their museums. They watched as hieroglyphics were decoded, as ancient texts were translated, as the world began to understand, slowly, incompletely, what the ancient Egyptians had been trying to say. They watched as Egypt gained independence, as nationalism grew, as the modern nation struggled to balance reverence for its ancient past with the demands of the present. They watched as tourism became an industry, as millions of visitors came each year to stand before them, to take photographs, to add their own interpretations to the endless catalogue of theories and speculations. They watched wars fought over Suez, revolutions that toppled governments, the Arab Spring that swept across the region, promising change that never quite came. They watched the construction of the Aswan Dam, which controlled the Nile's flooding and ended the annual cycle that had defined Egyptian civilization for millennia. And through it all, they remained, silent, unchanging, patient. What will they witness in the centuries to come? Will humanity survive the challenges ahead, or will future archaeologists dig through the ruins of our civilization as we dig through theirs? Will the pyramids still be standing when our own greatest monuments have crumbled to dust? And if they are, what will they mean to whoever stands before them? Perhaps they will mean nothing. Perhaps they will be incomprehensible, their purpose forgotten, their builders nameless, their messages unreadable. We struggle to understand them now with all our knowledge of ancient Egypt, with all our technological tools and scholarly expertise. How much harder will it be for civilizations that come after, if the chain of knowledge is broken, if the memory of Egypt is lost? Or perhaps they will mean everything. Perhaps they will be the last surviving testament to humanity's existence. Proof that we were here, that we built, that we dreamed of eternity and came as close to achieving it as any civilization has ever come. The pyramids do not care what we think of them. They do not need our theories. Or we have spoken of the pyramids as monuments, as mysteries, as messages across time. But there is another story hidden within these stones, a story of economics, of resources, of the immense organizational machinery required to transform an entire kingdom into a pyramid-building civilization. This is not the romantic tale of pharaohs reaching for the stars, but the practical reality of how thousands of people were fed, housed, managed, and coordinated across decades. It is the story of how building for eternity shaped the world of the living. Consider the numbers. The Great Pyramid contains approximately 2.3 million blocks of stone, each weighing on average 2.5 tons. The total mass is estimated at 5.75 million tons. To build it in 20 years, the generally accepted timeline for Khufu's reign, means moving and setting roughly 12 blocks per hour, every hour, day and night, for 2 decades. Even if we assume they worked only during daylight hours, and only during the 8 months of the year when the Nile wasn't flooding the fields, the pace would still require setting a block every 2 to 3 minutes. But the pyramid itself is only part of the equation. For every stone placed, there were quarrymen cutting blocks from limestone cliffs, workers transporting them across the Nile, labourers dragging them up ramps, masons dressing and fitting them into place. There were surveyors ensuring the measurements remained precise, architects overseeing the design, scribes recording deliveries and tracking workers, priests performing rituals to sanctify the work, and all these people needed to eat. The logistics are staggering. Estimates suggest that between 20,000 and 30,000 workers were directly involved in pyramid construction at any given time, with perhaps another 60,000 to 100,000 people supporting them. Farmers growing food, bakers making bread, brewers fermenting beer, potters creating vessels, weavers making cloth, fishermen hauling catches from the Nile. The entire economy of Egypt, for those 20 years, was organised around the singular goal of building Khufu's monument. Archaeological evidence from the workers' villages tells us what they ate. The diet was surprisingly rich: bread and beer, the staples of Egyptian cuisine, but also beef, mutton, fish, and fowl. Bones found in the refuse heap show that the workers consumed huge quantities of meat, far more than the average Egyptian. One estimate suggests that to feed the workforce, Egypt needed to slaughter 21 cattle and 23 sheep per day. Over 20 years, that's more than 150,000 cattle and 170,000 sheep, not counting the fish and birds. Where did all this food come from? Egypt's agricultural surplus generated by the annual flooding of the Nile was legendary. The river's floods deposited nutrient-rich silt across the floodplain, creating some of the most fertile farmland in the ancient world. Egyptian farmers could produce far more grain than they needed for subsistence, and this surplus became the foundation of pyramid building. Farmers paid taxes in grain, which was stored in vast state granaries and redistributed to workers as rations. But the pyramid project demanded more than just the agricultural surplus. It required a complete reorganization of Egyptian society. During the Old Kingdom, Egypt transformed from a collection of regional powers into a highly centralized state with the pharaoh at its apex. The pyramid was both symbol and engine of this transformation. Building it required developing systems of taxation, labor conscription, resource allocation, and bureaucratic record-keeping that wouldn't be matched in complexity until the Roman Empire. The papyrus scrolls found at Wadi al-Jarf give us a glimpse into this bureaucratic machine. Written by Me'er, an inspector in charge of a work gang, they describe in meticulous detail how limestone blocks were transported from the Tura quarries to Giza. Me'er records the number of workers in his team, about 40, the routes they took, the time required for each journey, even the locations where they stopped for the night. This level of documentation suggests a sophisticated administrative system capable of tracking thousands of work gangs, managing supply chains across hundreds of miles, and coordinating their efforts with split-second precision. The economic impact rippled through every level of society. Quarries had to be opened and maintained. The Tura quarries, which provided the fine white limestone for the pyramid's casing stones, were located across the Nile from Giza. The Aswan quarries, source of the red granite used in the king's chamber, were 500 miles to the south. Opening these quarries required investment in tools, infrastructure, and permanent settlements for the quarry workers. Copper tools had to be manufactured in vast quantities, thousands of chisels and saws that would wear out and need replacement. Egypt's copper came primarily from the Sinai Peninsula, requiring mining operations and trade networks to keep the tools flowing. Transportation infrastructure had to be built and maintained. Harbours were constructed along the Nile to receive stone shipments. Canals may have been dug to connect the river to the construction site. Reducing the overland distance stones had to travel. Roads or sledgeways had to be prepared, levelled and kept wet so that wooden sledges could slide more easily. Ramps had to be constructed from mud brick and stone chips, requiring their own supply chains and labour forces. The construction site itself was a small city. Archaeological excavations near the pyramids have revealed bakeries capable of producing thousands of loaves per day, breweries with massive vats for fermenting beer, workshops for copperworking, carpentry, rope-making, and pottery. There were administrative buildings where scribes worked, storage facilities for tools and materials, and presumably hospitals or clinics where injured workers could be treated. The workers lived in organised housing, not luxurious but functional, with sleeping quarters, communal cooking areas, and access to fresh water. This infrastructure didn't appear overnight. It developed gradually over the course of the 3rd and 4th dynasties, refined with each successive pyramid. By the time Khufu began his pyramid, Egypt had been building pyramids for about 75 years. The step pyramid of Djoser, completed around 2650 BCE, was the first, and it was followed by several others of varying success, some completed, some abandoned, some that partially collapsed during construction. Each taught valuable lessons about engineering, logistics, and organization. But the Great Pyramid represented the apex of this learning curve. It was the largest, most precise, most ambitious pyramid ever built, and perhaps not coincidentally, it marked the peak of Egypt's pyramid-building era. The pyramids that came after, those of Khafra and Menkaure at Giza, and the later 5th and 6th dynasty pyramids at Saqqara and Abu Sir, were smaller, less precisely constructed, built with inferior materials and less ambitious designs. By the end of the Old Kingdom, around 2200 BCE, pyramid building had essentially ceased. Why? What changed? The decline of pyramid building is one of Egyptian history's great puzzles, and it may tell us as much about the pyramid's purpose as their construction does. The answer likely involves a combination of economic exhaustion, political fragmentation, and changing religious beliefs. Building the Great Pyramid was an enormous economic undertaking, perhaps the single largest infrastructure project relative to GDP that any civilization has attempted. Modern economists have tried to estimate the cost, and while exact figures are impossible, the scale is clear. For 20 years, perhaps a quarter to a third of Egypt's entire economic output was directed toward pyramid construction. That level of sustained investment is extraordinary. It's comparable to the United States devoting $7 to $10 trillion per year, roughly half the entire federal budget, to a single project for 2 decades. No modern nation could sustain such an effort without serious economic consequences. Ancient Egypt managed it, but the strain must have been immense. The pyramid required not just labour and materials, but opportunity cost. Every worker building the pyramid was a worker not building something else, not constructing temples or palaces, not clearing new farmland, not strengthening fortifications. Every ton of copper fashioned into chisels for quarrying was copper that couldn't be made into weapons or tools for agriculture. Every load of grain fed to pyramid workers was grain not available for other purposes. For a society to accept such costs, the perceived benefit must be enormous. And in the Fourth Dynasty, it apparently was. The pyramid wasn't just a tomb, it was the mechanism by which cosmic order was maintained, the device that transformed the dead king into a god who would continue to protect Egypt from chaos. Building the pyramid was thus a form of insurance, a massive collective investment in the kingdom's continued prosperity. But as pyramid followed pyramid, as generations of Egyptians devoted their labour to these monuments, something began to shift. Perhaps the economic burden became too great. Perhaps successive pharaohs found it harder to command the loyalty and resources that Khufu had enjoyed. Perhaps the very success of the early pyramids undermined the rationale for building more. If Khufu and Khafra had already achieved godhood through their pyramids, did every subsequent pharaoh need an equally massive monument? We see evidence of this shift in the pyramids themselves. Menkaura's pyramid, third of the Giza trio and last of the Fourth Dynasty giants, is less than half the height of the Great Pyramid and contains only about 1/10 the mass. The Fifth Dynasty pyramids are smaller still, built not from massive limestone blocks but from smaller stones and rubble fill, with only the outer casing constructed from fine stone. The quality of workmanship declined. The precision that characterized the Great Pyramid, stones fitted so tightly that a knife blade cannot pass between them, gave way to rougher construction, with mortar filling the gaps. This wasn't because the Egyptians had forgotten how to build properly. The decline was gradual, which suggests a conscious choice to reduce costs. Pharaohs still wanted pyramids. The symbolism remained important, but they could no longer or would no longer devote the same resources to them. The pyramid was being scaled back to a more sustainable level. By the Sixth Dynasty, the pyramids had become almost hollow shells, small in stature and filled with rubble. But something else appeared. Texts. The pyramid. Texts carved into the walls of the chambers were dense collections of spells, hymns, and instructions for the dead king's journey through the afterlife. Perhaps as the physical pyramid diminished, the word became more important, the magic of language compensating for the reduced magic of monumental architecture. Then came the collapse. Around 2200 BCE, the Old Kingdom fell apart in what historians call the First Intermediate Period. Central authority dissolved, Egypt fragmented into competing regional powers. The causes are debated: climate change leading to reduced Nile floods, internal political struggles, economic exhaustion from pyramid building, or some combination of all three. For over a century, Egypt had no strong central government, no powerful pharaohs, and no pyramids. When centralized rule was eventually restored in the Middle Kingdom around 2000 BCE, pyramid building resumed, but it was never the same. Middle Kingdom pyramids were built primarily of mud brick with stone casings, and most have eroded away to shapeless mounds. The passion for massive stone monuments had been extinguished. By the New Kingdom, 1550–1070 BCE, the era of Egypt's greatest imperial power, when pharaohs conquered vast territories and accumulated unimaginable wealth, pyramid building had ceased entirely. The great pharaohs of this period, Hatshepsut, Thutmose III, Ramesses III, built magnificent temples instead, vast columned halls decorated with intricate reliefs, but no pyramids. They were buried in the Valley of the Kings, in tombs cut deep into the bedrock of desert cliffs, hidden from view and, theoretically, safe from robbers. The economic calculus had changed. A hidden tomb required far less labour and material than a massive pyramid. It could be built quickly and secretly. And in an era when tomb robbery had become endemic, by the New Kingdom, even the Great Pyramid had been thoroughly plundered. Visibility was a liability rather than an asset. But perhaps there was also a theological shift. The New Kingdom religion was different from that of the Old Kingdom. The sun god Ra had always been important, but now he merged with Amun to become Amun-Ra, the supreme deity, and pharaohs emphasized their role as his servant rather than his equal. The pyramid, which symbolized the rays of the sun and the pharaoh's direct ascent to the heavens, may have seemed presumptuous in this new religious context. The pharaoh was still divine, but perhaps not quite in the same way. Or perhaps more prosaically, the Egyptians had simply learned that massive visible monuments attracted looters. The pyramids' most famous quality, their eternal endurance, worked against their purpose as tombs. You cannot steal from a tomb you cannot find, but everyone knew where the pyramids were. Yet to view pyramids purely through the lens of economics and theology misses something crucial. The pyramids weren't just drains on resources or expressions of religious belief. They were identity-forming exercises, massive communal projects that united Egypt and defined what it meant to be Egyptian. Consider what it meant for a farmer from a small village in the Delta to be conscripted for pyramid building. He would leave his home during the flood season, when his fields were underwater and he couldn't work them anyway, and travel to Giza. There he would encounter Egyptians from every region, from Upper Egypt in the south, from the Fayoum oasis, from settlements along the Mediterranean coast. He would hear different accents, learn different customs, eat communal meals with strangers who would become comrades. For 4 months, he would participate in the most important project in the kingdom, working alongside thousands of others toward a common goal. He would see the pyramid rising block by block, witness priests performing rituals, hear scribes reading proclamations from the pharaoh. He would understand himself as part of something vast, something that transcended his village and his individual life. Then he would return home with stories to tell, having helped build something that would last forever. This experience was repeated across generations, involving hundreds of thousands of Egyptians over the course of the Pyramid Age. It created a shared identity, a sense of national unity that might not have existed otherwise. Egypt in the Old Kingdom was a relatively new state, formed from the unification of Upper and Lower Egypt only a few centuries earlier. Regional identities remained strong. The Pyramid Project helped forge these disparate peoples into something resembling a nation. The pyramid also created a shared landscape of memory. Every Egyptian knew the pyramids. They dominated the skyline, visible from miles away, constant reminders of pharaonic power and divine protection. They were reference points, literally and figuratively, monuments that helped Egyptians orient themselves in space and time. Events could be dated in relation to pyramid construction. In the year that Pharaoh's pyramid was completed, or when my grandfather worked on the Great Monument, stories accumulated around the pyramids. Even in ancient times, they became the subjects of legends. By the time Herodotus visited Egypt in the 5th century BCE, more than 2,000 years after the Great Pyramid's construction, the Egyptians were telling him tales about its building, some accurate, some wildly embellished. They told him 100,000 men worked on it for 20 years, which may be roughly correct for the total workforce, including support staff. But they also told him the pharaoh was so wicked he forced his own daughter into prostitution to raise funds, which is almost certainly fiction. Perhaps a story invented by Egyptians who no longer understood or approved of the immense resources devoted to these monuments. The pyramid became a screen onto which later Egyptians projected their own values and concerns. During periods of strong central authority, the pyramids were celebrated as symbols of Egypt's greatness and the pharaoh's power. During periods of fragmentation, they might be viewed more ambiguously, as symbols of excess, of pharaonic pride, of resources that could have been better spent. But they remained central to Egyptian consciousness, impossible to ignore or forget. Even as pyramid building ceased, the pyramids themselves continued to shape Egyptian culture. Later pharaohs often built their tombs or temples in sight of the Great Pyramids, as if seeking to borrow some of their power. The pyramids became pilgrimage sites, places where Egyptians would go to pray or leave offerings, even though they no longer fully understood their original purpose. The Great Pyramid in particular seems to have remained a focus of popular reverence throughout Egyptian history. This continued even after Egypt ceased to be ruled by ethnic Egyptians. The Persian conquerors respected the pyramids. The Ptolemaic Greeks, who ruled Egypt after Alexander's conquest, were fascinated by them and commissioned studies of their construction. Cleopatra, last of the Ptolemaic rulers, would have seen the pyramids as ancient monuments to a civilization that was already more distant from her in time than she is from us. Yet they remained symbols of Egypt, fundamental to the country's identity in a way that transcended political changes. But the pyramids also reinforced and perpetuated a particular social order, one based on extreme hierarchy, and the absolute supremacy of the pharaoh. To build a pyramid required not just organization but obedience, not just coordination but submission to centralized authority. The pyramid was possible only because thousands of people accepted the premise that the pharaoh was divine, that his needs superseded theirs, that their labor was owed to him as surely as the Nile's floods were owed to the gods. This social contract, if we can call it that, was neither simple nor unchanging. It required constant reinforcement through ritual, through art, through the physical presence of monuments like the pyramids. The pyramid itself was an argument made in stone. The pharaoh is godlike, capable of commanding forces beyond normal human capacity, deserving of worship and sacrifice. Consider the visual rhetoric of the pyramid. It dominates everything around it, reducing humans to insignificance. When you stand before the Great Pyramid, you feel small. That's not accidental. The pyramid's massive scale creates an emotional response, a sense of awe that easily shades into submission. This is the architecture of power, designed to overwhelm and impress. The same message was conveyed through every aspect of pyramid construction. The work gangs had names like Friends of Khufu, emphasizing their personal relationship to the pharaoh. The graffiti they left behind expresses pride in their service to him. The entire enterprise was framed as an act of devotion, a gift to the god-king who guaranteed Egypt's prosperity. Whether the workers genuinely believed this or whether they simply accepted it as the natural order of things, we cannot know. But the system worked. For centuries, Egyptians devoted their labour to these monuments with apparently minimal coercion. Yet there was always tension in this arrangement. The pharaoh's divinity was both absolute and fragile. It required constant performance, constant demonstration of capability and divine favour. A weak pharaoh, one who could not maintain mayat or command respect, undermined the entire system, and a pyramid half-built or poorly constructed would be evidence of that weakness, visible to everyone. This may explain why some pyramids were never completed or were abandoned in favour of new ones. If a pharaoh died before his pyramid was finished, or if the project encountered insurmountable difficulties, it called into question his divine status. Better to start fresh, to demonstrate strength through a new monument, than to struggle with a compromised one. The pyramid also reinforced class distinctions beyond just the pharaoh's supremacy. The workers' villages show clear hierarchies. Some workers lived in better housing than others. Some ate better food. Foremen and skilled craftsmen occupied a different social stratum than common labourers. Scribes and administrators, though they might never touch a stone, were considered more important than the men who moved them. And of course, the vast majority of Egyptians never worked on the pyramids at all. Women, who comprised half the population, were largely excluded from construction labour, though they surely participated in the supporting economy, weaving cloth, preparing food, managing households while men were away. Children were too young to be conscripted. The elderly, the infirm, those with specialised roles that couldn't be spared, all were exempted. So the pyramid workforce was a particular cross-section of society, adult men in their prime, temporarily removed from their normal roles and reconstituted as builders. But this temporary status was important. Unlike slaves, these workers retained their identities, their families, their places in their home communities. They worked on the pyramid for a few months and then returned home. This rotation system may have been crucial to the pyramid's success. It distributed both the burden and the honour across the kingdom rather than concentrating them. Yet this system also had limits. It required a strong state capable of organising conscription, transporting workers, providing them with tools and food, and ensuring they returned home safely. When the state weakened, the system collapsed. The end of pyramid building may have been both cause and effect of state decline. The inability to mobilise labour for pyramids was a sign of failing central authority, while the absence of pyramid projects removed one of the mechanisms that had reinforced that authority. But the pyramid's impact on Egyptian life didn't end when construction finished. A completed pyramid required ongoing maintenance and religious observance, creating permanent institutions that persisted for centuries. Each pyramid complex included not just the pyramid itself, but mortuary temples where priests performed daily rituals to sustain the dead pharaoh's care in the afterlife. These weren't occasional ceremonies, but daily obligations, offerings of food and drink, recitations of prayers, burning of incense. The priests who performed these services were full-time professionals, supported by endowments of land and resources that the pharaoh had established specifically for this purpose. These pyramid cults, as Egyptologists call them, were substantial economic enterprises. The mortuary temple of Khufu, for instance, had extensive agricultural lands assigned to it, worked by farmers whose produce went to feed the priests and provide offerings. There were also personnel beyond the priests, bakers to prepare ritual bread, brewers for beer offerings, florists to provide fresh flowers, guards to protect the complex, scribes to manage accounts. Archaeological evidence suggests these institutions were remarkably durable. The pyramid cult of Khufu continued functioning for at least 500 years after his death, possibly longer. 5th and 6th dynasty texts mention officials with titles like Inspector of Priests of the Pyramid of Khufu, indicating that centuries after his death, the Great Pyramid still had an active religious establishment. This means that for ordinary Egyptians living near Giza, the pyramids were not just ancient monuments, but living religious centres. People would have seen priests coming and going, witnessed ceremonies, smelled incense burning, heard prayers and hymns. The pyramids were woven into the fabric of daily religious life. Moreover, ordinary Egyptians apparently had some access to these cult centres. We know from inscriptions that people left graffiti at pyramid sites, including prayers requesting the dead pharaoh's intercession. Some scholars believe that during certain festivals, pyramid complexes may have been open to pilgrims, allowing common people to approach and make offerings. The pyramid was thus not just a symbol of pharaonic power, but a site of popular religious devotion. Maintenance was also an ongoing concern. The pyramid's limestone casing required care to remain pristine and reflective. Sand would blow against the bases, requiring periodic clearing. The mortuary temples needed repairs. Causeways had to be kept passable. All this required labour and resources, providing employment for generations of Egyptians who never worked on the original construction, but spent their lives maintaining it. There are records of later pharaohs sponsoring restoration work on older pyramids, sometimes centuries after they were built. This served multiple purposes. It demonstrated respect for ancestors, showcased the pharaoh's piety and resources, and maintained the pyramid as a functioning religious site. But it also suggests that the pyramids, for all their durability, were not maintenance-free. Left unattended, they would deteriorate. The reason they survived is partly because Egyptians actively preserved them for many centuries, but eventually the pyramid cults did cease. The records grow sparse after the Old Kingdom's collapse. Some cults were revived during the Middle Kingdom, when centralized authority was restored, but never with the same vigor. By the New Kingdom, most Old Kingdom pyramids had abandoned mortuary temples, their priests dispersed, their endowments reassigned. What happened to these institutions? Several factors likely contributed to their decline. The economic disruptions of the First Intermediate Period may have destroyed the administrative systems that supported them. Land endowments could have been seized by local warlords or repurposed by new authorities. The priests lacking support would have dispersed to find other employment. There may also have been a crisis of belief. If the pyramid was supposed to ensure the pharaoh's eternal life and Egypt's continued prosperity, but Egypt descended into chaos anyway, did that not suggest the pyramid had failed? Perhaps later Egyptians began to question whether all that investment had been worthwhile, or perhaps, more pragmatically, later pharaohs simply had different priorities. Why continue supporting the cult of a pharaoh from 1,000 years ago when resources were needed for current projects? The New Kingdom was an age of empire, of military campaigns and monumental temple building. The old pyramids, their pharaohs long dead and largely forgotten, may have seemed like relics from another world. Whatever the reasons, by the time of the New Kingdom, the Giza pyramids had become essentially what they are today, imposing monuments from the distant past, admired and wondered at but no longer functioning as religious centres. They had transitioned from living institutions to historical artefacts, from active temples to passive monuments. This transition was gradual and uneven. Some pyramid cults lingered longer than others. The Great Pyramid seems to have retained religious significance even when its cult ceased. People continued to visit it, leave offerings, treat it as sacred space. But the daily rituals, the professional priesthood, the vast supporting apparatus, all that slowly eroded away. And then came the looters. The pyramids had always been targets for thieves. Tomb robbery was apparently widespread even in ancient times, and severe punishments attest to how common the problem was. But as long as the pyramid cults functioned, as long as priests and guards were present, the tombs retained some protection. Once those institutions collapsed, the pyramids were vulnerable. We know that by the Middle Kingdom, probably earlier, the pyramids had been thoroughly plundered. The treasures that once filled their chambers, gold, jewels, fine furniture, ritual objects, were stolen. Even the pharaoh's mummies were torn apart in the search for amulets and jewellery wrapped in the bandages. The Great Pyramid's sarcophagus was found empty when medieval Arabs first entered the king's chamber. Whether it had ever held a body is now uncertain. Later still, the pyramids were quarried for building materials. The fine white limestone casing stones were particularly prized. They were already cut and dressed, ready to be used in new construction. Medieval Cairo was built partly from pyramids, with casing stones from Giza repurposed for mosques, palaces, and fortifications. This wasn't vandalism in the sense of purposeless destruction. It was practical recycling. Stone was valuable, and here were millions of tons of it, already quarried and shaped. By this process, the pyramids that had been built to last forever were slowly dismantled by the very civilizations they were meant to outlast. The irony is profound, yet enough remained, the massive core blocks were too large and heavy to be worth moving, that the essential pyramid form survived. The smooth, gleaming pyramids of the 4th dynasty became the rough-stepped structures we see today, stripped of their casings, weathered and worn, but still recognizable, still imposing, still inspiring awe. Despite their decline, the pyramids left a lasting economic and organizational legacy. The systems developed to build them, bureaucratic record-keeping, resource management, large-scale labor mobilization, didn't disappear when pyramid building ceased. They were adapted for other purposes. The New Kingdom's military campaigns required similar organizational capacity, moving armies of thousands across great distances, supplying them with food and equipment, coordinating complex operations. The temples built during this period, while different in form from pyramids, required comparable resources and planning. The tomb-building projects in the Valley of the Kings, though smaller in scale, drew on the same tradition of skilled stoneworking and architectural precision. In a sense, every major project in Egyptian history afterward bore the pyramid's imprint. Egypt had learned how to think big, how to plan across decades, how to coordinate vast numbers of people toward a single goal. That capacity, once developed, remained part of Egyptian civilization's repertoire, even when pyramids ceased to be the goal. The pyramids also established Egypt's reputation. For the rest of antiquity, and into the medieval period, Egypt was famous for its monuments, its ancient wisdom, its mysterious and powerful past. This reputation drew scholars, travellers, and traders. It made Egypt attractive to conquerors who wanted to rule such a storied land. It created a form of cultural capital that Egypt could trade on long after its actual power had waned. And perhaps most importantly, the pyramids established the very idea that such projects were possible. They proved that human beings could build on a monumental scale, could create structures that would endure for millennia, could organize society to achieve seemingly impossible goals. Every civilization afterward that built grand monuments, from Rome's aqueducts to China's Great Wall to medieval Europe's cathedrals to modern skyscrapers, is in some sense heir to the pyramid builders. The pyramids taught humanity that we are capable of greatness, that we can reach beyond mere survival to create works of lasting significance. That lesson, encoded in stone on the Giza Plateau, may be their most important legacy of all. What if we are not the first? Tonight, as you settle into the quiet darkness, let that question drift through your mind like smoke through ancient ruins. What if the story we tell ourselves about human civilization, that we are the pioneers, the first to build cities and decode the stars, is nothing more than a comforting fiction? What if, long before the first pyramid rose from Egyptian sands, long before the first cuneiform tablet was pressed into clay, another people walked this earth, a civilization so advanced, so complete, that when it vanished, it left behind only whispers in stone and shadows in our oldest myths? The idea feels impossible, doesn't it? We have mapped every continent, excavated countless sites, carbon dated our way back through millennia. Surely, if another civilization had existed, we would know. We would have found their cities, their tools, their bones. But what if we've been looking in all the wrong places? What if time itself has been their greatest eraser, and what we call prehistory is actually post-history? The long, slow recovery from a collapse so complete that it reset the human story entirely. Consider this. Our own industrial civilization has existed for barely 2 centuries. In geological terms, we are a heartbeat, a single breath in Earth's 4 billion-year exhale. If our cities were abandoned tomorrow, how long would they last? Steel rusts, concrete crumbles, glass shatters. Within 1,000 years, nature would reclaim most of what we have built. Within 10,000, our greatest monuments would be little more than strange hills covered in forest. Within 100,000 years, almost nothing would remain except perhaps some curious isotopes in the soil and a thin layer of plastic in the rock record. Now imagine a civilization that rose and fell not thousands, but hundreds of thousands of years ago, or millions. What traces would survive such an immense passage of time? What evidence would we even know how to recognize? The question hangs in the air like incense in a forgotten temple, and as we begin to explore it, we find that the world is full of things that don't quite fit the story we've been told. Ancient myths that speak of golden ages and vanished peoples, archaeological anomalies that challenge our timelines, geological mysteries that hint at cycles of creation and destruction far older than human memory, scientific theories that suggest intelligence may have emerged on Earth long before we assumed possible. What if the myths were right all along? What if the stories our ancestors told around fires were not fantasies but memories, distorted by time, wrapped in metaphor, but carrying within them the echo of something real? What if we are not the first children of Earth, but the latest in a long line of civilizations that have risen, flourished, and fallen into the darkness of deep time? Tonight, we will follow that possibility wherever it leads. We will walk through the ruins of forgotten ages, listen to the whispers of ancient stones, and ask the questions that have haunted human imagination since we first looked up at the stars and wondered if we were alone. Not alone in space, but alone in time. The whispers of deep memory. In the beginning, there were the stories. Long before archaeologists with their careful brushes and measuring tools, long before carbon dating and stratigraphic analysis, there were the myths. Every culture on Earth, no matter how isolated, no matter how different their languages or customs, tells variations of the same haunting tale. Once, long ago, there was a golden age, a time when the world was different, when beings of great wisdom walked among humans, or when humans themselves possessed knowledge and abilities that have since been lost. The Greeks called it the Age of Gold, when Kronos ruled and humans lived like gods, free from toil and suffering. The Hindus speak of the Satya Yuga, the Age of Truth, when righteousness reigned and humans possessed divine knowledge. The Norse told of a time before Ragnarok, when the gods walked freely in Midgard and wisdom flowed like rivers. Aboriginal Australians remember the dream time, when ancestor spirits shaped the land and taught the first people the secrets of survival. These are not isolated stories. They appear everywhere, in every corner of human culture, like echoes of some vast forgotten symphony. The details change. Sometimes the Golden Age ended in flood, sometimes in fire, sometimes in great forgetting. But the core remains constant. There was a time before our time, a civilization before our civilization, and something happened to end it. For centuries, scholars dismissed these myths as wishful thinking, as humanity's tendency to imagine a perfect past to contrast with an imperfect present. But what if that dismissal was too hasty? What if these stories, passed down through countless generations, preserved something real? Not literal truth, perhaps, but the memory of truth, distorted by time like light bending through water. Consider the flood myths. Nearly every culture on Earth has one. The biblical story of Noah is perhaps the most famous in the Western world, but it is far from unique. The Mesopotamians told of Utnapishtim, who survived the deluge sent by the gods. The Greeks spoke of Deucalion and Pyrrha, the sole survivors of Zeus's flood. Hindu texts describe Manu, who was warned by Vishnu to build a great boat. Native American tribes from the Pacific Northwest to the Amazon basin have their own versions of the great flood that destroyed the world before this one. The standard explanation is that these myths arose independently as different cultures tried to make sense of local flooding events, rivers overflowing their banks, tsunamis devastating coastlines, the gradual rise of sea levels at the end of the last ice age. But there's another possibility, one that sends a chill down the spine when you consider it in the quiet hours of the night. What if all these flood myths remember the same event? What if, somewhere in the deep past, there really was a great deluge, not necessarily global, but vast enough to destroy a civilization so completely that only scattered survivors remain to carry the story forward? What if the flood myths are not separate inventions, but fragments of a single, catastrophic memory? The timeline becomes crucial here. The last ice age ended roughly 12,000 years ago, and with it came dramatic changes to Earth's geography. Sea levels rose by hundreds of feet as massive ice sheets melted. Coastlines that had been dry land for millennia disappeared beneath the waves. Entire continental shelves were submerged. If a civilization had existed during the Ice Age, if they had built their cities along the then exposed coasts, those cities would now lie beneath hundreds of feet of ocean water. We know that early humans were far more sophisticated than we once believed. The cave paintings at Lascaux and Altamira, created over 15,000 years ago, display an artistic sophistication that rivals anything produced in recorded history. The megalithic site of Göbekli Tepe in Turkey, built over 11,000 years ago, features massive stone pillars carved with intricate reliefs, and it was deliberately buried by its creators as if they were trying to hide it from something or someone. But these are just the traces we've found on dry land. What lies beneath the oceans? What cities, what monuments, what libraries of stone might rest on the continental shelves, covered by centuries of sediment and the weight of the sea? The myths speak of more than just floods. They tell of great wars between gods and titans, of weapons that could level mountains and burn the sky. The Mahabharata describes the Brahmastra, a weapon so terrible it could destroy entire armies and leave the land barren for generations. The Norse Ragnarok speaks of a final battle that will consume the world in fire. The Hopi prophecies tell of previous worlds that ended in destruction, each one a lesson unlearned. Modern readers often interpret these as metaphors or primitive attempts to understand natural disasters. But what if they were something else entirely? What if they were memories of real conflicts, real weapons, real destruction, but from so long ago that the details became mythologized, the technology transformed into magic, the history into legend? There's a haunting consistency to these stories that goes beyond coincidence. They speak of a time when knowledge was greater, when humans, or beings like humans, possessed abilities that seem impossible to us now. They tell of flying vehicles, of weapons that harness the power of the sun, of communication across vast distances, of healing arts that could restore life itself. The Sanskrit epics are particularly rich in such details. The Vimanas, described in texts like the Ramayana and Mahabharata, were flying machines capable of travelling vast distances, even to other worlds. The descriptions are remarkably specific, different types of craft for different purposes, detailed instructions for their construction and operation, accounts of aerial battles between opposing forces. The Vaimanika Shastra, though of disputed age, provides technical specifications that read almost like a manual for advanced aircraft. Similarly, the Book of Ezekiel in the Bible describes the prophet's vision of wheels within wheels, of creatures with multiple faces, of a craft that could move in any direction without turning. Modern UFO researchers have seized upon this as evidence of ancient alien visitation. But what if the truth is both simpler and more profound? What if Ezekiel was describing not visitors from another world, but technology from another time, remnants of a human civilization so advanced that its machines seemed divine to those who encountered them? The Aboriginal Australians speak of the Wandjina, sky beings who came from the clouds and taught the first people the laws of existence. Their rock art, some of it tens of thousands of years old, depicts these beings with large eyes and radiating headdresses that look remarkably like modern depictions of astronauts or pilots. But the Wandjina were not aliens. They were the ancestors, the first people, the ones who came before. In the Americas, the Aztecs told of Quetzalcoatl, the feathered serpent who brought knowledge and civilization to humanity before departing across the eastern sea, promising to return. The Incas spoke of Viracocha, the creator god who emerged from Lake Titicaca and taught the arts of civilization before disappearing into the Pacific. The Maya had Kukulkan, another feathered serpent deity associated with knowledge, astronomy, and the promise of return. These are not stories of gods in the supernatural sense, but of teachers, of culture bringers, of those who possessed knowledge that seemed divine to those who received it. And in every case these beings departed, leaving behind only their teachings and the promise, or threat, that they would return. What if they were not gods at all, but survivors? What if they were the remnants of the previous civilization, the keepers of ancient knowledge, wandering a world that had forgotten how to read the stars or work metal or build in stone? What if they were trying to restart civilization, to pass on what they could before they too passed into legend? The myths tell us something else, something that should make us pause in the darkness and listen more carefully. They tell us that the Golden Age did not end gradually, through slow decline or natural evolution. It ended suddenly, catastrophically, in fire or flood or war. It ended so completely that the survivors had to start over from almost nothing, carrying only fragments of the old knowledge, stories that would become myths, technologies that would become magic. And they tell us something else, something that whispers through the night like wind through ruins. It has happened before, not once but many times. The Hindus speak of cycles within cycles, ages within ages, each one ending in destruction and beginning in renewal. The Maya calculated vast cycles of time, cosmic ages that stretched across millennia. The Hopi speak of 4 previous worlds, each one destroyed when humanity forgot the proper way to live. What if these are not metaphors for spiritual development, but memories of actual cycles? What if civilization on Earth has risen and fallen not once, but many times? What if we are not the first to split the atom, to reach for the stars, to unlock the secrets of genetics and artificial intelligence? What if we are simply the latest in a long line of species that have achieved technological sophistication, only to destroy themselves or be destroyed by forces beyond their control? The myths whisper these possibilities in the darkness, and as we listen, we begin to hear something else. The sound of our own footsteps echoing those who came before. These same ambitions, the same discoveries, the same fatal flaws that led to the end of worlds. And we begin to wonder, are we walking toward our own golden age or toward our own ending? Are we the inheritors of ancient wisdom, or are we simply repeating ancient mistakes? The stories our ancestors told around their fires were not just entertainment. They were warnings. They were maps of where we had been and signs pointing toward where we might go. They were the whispers of deep memory, trying to tell us something crucial about the nature of time, the fragility of civilization, and the terrible beauty of starting over. But that wasn't the whole story. The myths were just the beginning, the first clue in a mystery that would lead us deep into the earth itself, into stones that remember what flesh has forgotten, into ruins that challenge everything we thought we knew about the human journey through time. The stones that remember, beneath the myths, older than the stories, lie the stones. They wait in silence across the world, massive blocks of granite and limestone perfectly fitted together without mortar, carved with precision that challenges our understanding of ancient capabilities. They rise from jungles and deserts, from mountain tops and ocean floors, speaking a language of engineering and astronomy that we are only beginning to decode. And in their silent testimony, they whisper of builders whose skill surpassed anything we attribute to the ancient world. In the high Andes of Peru, the fortress of Sacsayhuaman overlooks the city of Cusco like a sleeping giant. Its walls are built from stone so massive that modern cranes would struggle to lift them, fitted together so precisely that a knife blade cannot slip between them. The largest stone weighs over 300 tons. It was quarried from a site several miles away, transported across difficult terrain, lifted into place with mathematical precision, and shaped to fit perfectly with its neighbours. The conventional explanation is that the Inca built Sacsayhuaman using bronze tools, wooden rollers, and thousands of workers pulling on ropes. But when you stand before those walls in the thin mountain air, when you run your hands along joints so perfect they seem to have been melted together rather than carved, the explanation feels inadequate. The Inca themselves told the Spanish conquistadors that they did not build the great stoneworks, that these were the creations of the people who came before, the ones they called the Viracocha, the foam of the sea. The mystery deepens when you examine the stones themselves. Many show evidence of vitrification, a process where rock is heated to such extreme temperatures that its surface becomes glass-like. This requires temperatures of over 1,000 degrees Celsius, far beyond what any known ancient technology could achieve. Yet there it is, preserved in stone, evidence of a process we cannot explain. Similar megalithic sites dot the globe like markers on some vast forgotten map. At Baalbek in Lebanon, the Temple of Jupiter sits atop a foundation of stones so large they dwarf even those at Sacsayhuaman. The Trilithon, 3 massive blocks that form part of the temple's base, consists of stones weighing over 800 tons each. Nearby lies the stone of the pregnant woman, a single block weighing an estimated 1,000 tons, still partially attached to the bedrock from which it was being quarried. The Romans built the visible temple, but they built it on foundations that were already ancient when they arrived. Local legends speak of a race of giants who placed the great stones in the time before memory. The Romans themselves seemed awed by what they found, incorporating the megalithic base into their own construction rather than attempting to replicate it. In Egypt, the Great Pyramid of Giza continues to confound researchers with its mathematical precision and engineering sophistication. Built from over 2 million stone blocks, some weighing 15 tons or more, it was the tallest structure on Earth for over 3,800 years. Its base is level to within just 2.1 centimetres. Its sides are aligned to the cardinal directions with an accuracy of 3/60th of a degree. The ratio of its height to its base perimeter equals pi to several decimal places. But perhaps most mysteriously, the pyramid incorporates knowledge that we didn't think the ancient Egyptians possessed. Its dimensions encode the circumference of the Earth, the length of the year, and the speed of light. The shafts that extend from the king's and queen's chambers point to specific stars: Orion, Draco, Sirius, with astronomical precision. The entire structure seems designed not just as a tomb, but as a kind of 3-dimensional encyclopedia, preserving mathematical and astronomical knowledge in stone. The conventional timeline places the pyramid's construction around 2580 BCE, during the 4th dynasty of the Old Kingdom. But this dating is based largely on circumstantial evidence: the presence of Khufu's cartouche in a sealed chamber, the similarity to other 4th dynasty monuments, the assumption that such sophisticated construction must have developed gradually from simpler predecessors. Yet the pyramid stands alone in its perfection. The pyramids that came before it were smaller, cruder, often collapsed or were abandoned mid-construction. The pyramids that came after it were inferior in every measurable way, smaller, less precise, built with inferior materials and techniques. It's as if the Great Pyramid represents not the culmination of a gradual development, but a singular achievement that was never equalled, let alone surpassed. Some researchers have suggested that the pyramid is far older than conventionally believed, that it was built during a previous period of high civilization and later appropriated by the pharaohs of the 4th dynasty. The evidence is circumstantial but intriguing. Water erosion patterns on the Sphinx that suggest it was carved during a much wetter climate, geological evidence of advanced machining techniques, the absence of any mummies or burial goods in the pyramid itself. But Egypt is not alone in preserving evidence of sophisticated ancient engineering. On Easter Island, nearly 900 massive stone statues called moai stand sentinel over the Pacific. The largest completed statue is over 30 feet tall and weighs 82 tons. They were carved from volcanic rock using only stone tools, transported across the island using unknown methods, and erected with precision that required sophisticated understanding of leverage and balance. The islanders themselves, when first contacted by Europeans, had no memory of how the statues were built or moved. They spoke of them as having walked into place, guided by the mana of the ancestors. Recent experiments have shown that the statues could indeed have been walked upright, using a complex system of ropes but this would have required coordination and engineering knowledge that seems inconsistent with the island's small, isolated population. In Turkey, this site of Göbekli Tepe has revolutionized our understanding of prehistoric capabilities. Built over 11,000 years ago, 6,000 years before Stonehenge, 7,000 years before the pyramids, it consists of massive stone pillars arranged in circles, carved with intricate reliefs of animals and abstract symbols. The pillars weigh up to 16 tons each and were quarried, transported and erected by people who are supposedly still hunter-gatherers, lacking even pottery or metal tools. The site was deliberately buried around 8000 BCE, covered with tons of earth, in what appears to have been a massive coordinated effort. Why would a people invest enormous resources in building such a complex, then bury it completely? What were they trying to hide, or preserve, or protect? The carvings at Göbekli Tepe tell their own story. They depict animals that were not native to the region during the supposed time of construction. Lions, crocodiles, exotic birds. They show humans interacting with these animals in ways that suggest domestication, or at least close familiarity. And they include symbols and motifs that appear in later cultures around the world, as if Göbekli Tepe was a source from which knowledge spread to other civilizations. But perhaps the most intriguing aspect of these megalithic sites is not their individual mysteries, but their global distribution and apparent interconnection. They appear on every continent, built by cultures that had no known contact with each other, yet they share remarkable similarities in construction techniques, astronomical alignments, and symbolic motifs. The precision-cut stones of Sacsayhuaman echo the megalithic walls of Baalbek. The astronomical alignments of the pyramids mirror those found at Stonehenge and Angkor Wat. The spiral motifs carved into stones in Ireland appear also in New Mexico and Easter Island. It's as if these sites were built according to a common template, following shared knowledge that somehow spread across the globe long before the supposed dawn of civilization. Some researchers have proposed that these similarities result from a common human tendency to build in certain ways, to align structures with celestial bodies, to carve similar symbols. But the level of technical sophistication involved suggests something more than coincidence. The ability to quarry, transport, and precisely place stones weighing hundreds of tons requires not just manpower, but advanced understanding of physics, engineering, and logistics. Consider the problem of the Antikythera mechanism, discovered in a shipwreck off the Greek island of Antikythera in 1901. This bronze device, dating to around 100 BCE, is a complex mechanical computer capable of predicting the positions of the sun, moon, and planets decades into the future. Its gear system is so sophisticated that nothing comparable appears in the historical record until astronomical clocks began appearing in medieval Europe over 1,000 years later. The mechanism suggests that ancient Greek technology was far more advanced than we previously believed. But it also raises a troubling question. If the Greeks could build such sophisticated devices, what else could they build? What other technologies might have existed in the ancient world that we have no record of because they were made from materials that don't survive, or because the knowledge was lost during periods of collapse and chaos? The stones remember what the written records have forgotten. They preserve evidence of capabilities that don't fit our timeline of human development. They suggest that the ancient world was not a place of primitive peoples struggling with bronze tools and wooden wheels, but a world where at least some cultures possessed knowledge and abilities that we are only now beginning to understand. And they raise the most haunting question of all. If these monuments were built by the civilizations we know about, the Egyptians, the Greeks, the Inca, then why do they seem so far beyond those civilizations' other achievements? Why do they stand alone in their sophistication, like islands of advanced knowledge in a sea of more primitive technology? The answer whispered by the stones is one that challenges our most basic assumptions about the past. What if these monuments were not built by the civilizations that claimed them, but inherited by them? What if they are the last surviving works of an earlier people, a previous civilization that possessed knowledge and capabilities that were lost when that civilization fell? The stones cannot tell us who built them or when, not with certainty, but they can tell us that someone did, someone with knowledge of mathematics and astronomy, with engineering capabilities that rival our own, with the organizational ability to coordinate massive construction projects across generations, someone who understood the movement of the stars, the properties of stone, the principles of leverage and balance and precision, someone who built not just for their own time but for ours, as if they knew that their civilization would not last, that their knowledge would be lost, that their very existence would be forgotten, as if they were trying to leave us a message encoded in stone, waiting for us to become sophisticated enough to read it. But the stones were not the only witnesses to the deep past. Hidden in the earth itself, in layers of rock and sediment, in the chemical signatures of ancient atmospheres, lay evidence of events so catastrophic they could erase entire civilizations from the record of time. The scars of catastrophe. The earth remembers everything, in layers of ice and sediment, in the chemical composition of ancient atmospheres trapped in amber, in the magnetic signatures locked within cooling lava. Our planet preserves a record of its history that spans billions of years, and within that record, written in the language of isotopes and impact craters, of mass extinctions and climate shifts, lies evidence of catastrophes so vast they could reset the entire course of life on Earth. We know about the big ones, the events that make it into textbooks and documentaries, the asteroid impact that ended the age of dinosaurs 66 million years ago, leaving behind a layer of iridium-rich clay that circles the globe like a funeral shroud. The Permian-Triassic extinction 252 million years ago, which eliminated 96% of marine species and 70% of terrestrial vertebrates, earning it the nickname the Great Dying. The Toba supervolcanic eruption 74,000 years ago, which may have reduced the human population to as few as 10,000 individuals, creating a genetic bottleneck that we still carry in our DNA. But these are just the catastrophes we can easily see, the ones that left clear signatures in the geological record. What about the smaller ones, the regional disasters that could destroy a civilization without leaving a global trace? What about the events that happened so recently, in geological terms, that their evidence has been obscured by erosion, sedimentation, and the relentless recycling of the Earth's surface? Consider the Younger Dryas, a period of rapid climate change that began around 12,900 years ago and lasted for over a millennium. In the span of just a few decades, global temperatures plummeted, ice sheets advanced, and sea levels dropped. Entire ecosystems collapsed. The megafauna of North America, giant ground sloths, saber-toothed cats, woolly mammoths, went extinct in what appears to have been a sudden, coordinated die-off. The conventional explanation for the Younger Dryas involves changes in ocean circulation patterns as the great ice sheets melted. But a growing body of evidence suggests something more dramatic, a cosmic impact event that triggered the climate shift and the mass extinctions. The evidence includes a layer of sediment from this period that contains high concentrations of platinum, nanodiamonds, and other materials typically associated with extraterrestrial impacts. The proposed impact wasn't a single large asteroid, but a swarm of fragments from a disintegrating comet that struck the Earth's atmosphere and surface across multiple locations. The impacts would have triggered massive wildfires, filled the atmosphere with dust and debris, and disrupted climate patterns across the globe. The effects would have been devastating for any advanced civilization that might have existed at the time. And there's evidence that such a civilization might indeed have existed. The end of the Younger Dryas, around 11,700 years ago, coincides with what archaeologists call the Neolithic Revolution, the sudden, seemingly spontaneous development of agriculture in multiple locations around the world. Within a few thousand years, humans went from hunter-gatherers to farmers, from nomadic tribes to settled communities, from stone tools to complex societies. This transition has always puzzled researchers. Why did it happen so suddenly? And why in so many places at once? The standard explanation is that climate change at the end of the Ice Age created conditions favourable for agriculture, and humans independently discovered farming techniques in different regions. But what if the truth is more complex? What if the Neolithic Revolution wasn't the beginning of civilization, but its restart? What if there had been an earlier civilization, one that had already developed agriculture, metallurgy, and complex social organization, but was destroyed by the cosmic impacts that triggered the Younger Dryas? What if the survivors of that civilization, scattered and reduced to small groups, carried with them fragments of agricultural knowledge that they gradually reintroduced as conditions improved? This would explain the sudden, simultaneous appearance of farming in regions as distant as the Fertile Crescent, China, and Mesoamerica. The evidence for such a scenario is necessarily fragmentary. Any civilization that existed before the Younger Dryas would have had its traces largely erased by the catastrophe itself and the subsequent climate changes. But there are hints, tantalizing suggestions that something more complex was happening in the deep past than our current models suggest. Take the mystery of the Carolina Bays, thousands of elliptical depressions scattered across the southeastern United States. These features, which can be seen clearly from aerial photographs, all point in the same direction, toward the Great Lakes region. They appear to have been created by some kind of impact event, but not from a single large object. Instead, they suggest a shower of smaller impacts, exactly what you might expect from a fragmenting comet. The dating of the Carolina Bays is controversial, but some evidence suggests they were formed around the time of the Younger Dryas. If so, they provide physical evidence for the kind of cosmic catastrophe that could have destroyed an advanced civilization. The impacts would have been devastating across a wide area, triggering fires, floods, and climate disruption that could have wiped out entire populations. Similar impact features have been identified in other parts of the world. In Argentina, a field of glass-like objects called tektites suggests a major impact event in the relatively recent past. In Australia, Aboriginal oral traditions speak of a time when the sky fell and the land burned, descriptions that sound remarkably like eyewitness accounts of cosmic impacts. The traditions are said to be tens of thousands of years old, passed down through countless generations of storytellers. But cosmic impacts are not the only catastrophes that could erase a civilization from the historical record. Supervolcanic eruptions, massive earthquakes, and sudden climate shifts could all have similar effects. The Earth's crust is far more dynamic and unstable than most people realize, capable of dramatic changes that could reshape entire continents in a matter of years or decades. The Lachamp event, which occurred around 41,000 years ago, saw the Earth's magnetic field weaken to just 5% of its current strength, and the magnetic poles flip completely. During this period, the planet would have been bombarded by cosmic radiation, potentially causing widespread mutations, cancer, and sterility in surface-dwelling organisms. Any technological civilization dependent on electronics would have found their systems failing as the protective magnetic shield collapsed. More recently, the 1815 eruption of Mount Tambora in Indonesia caused global climate disruption that lasted for years. The following year, 1816, was known as the Year Without a Summer in Europe and North America. Crops failed, famines spread, and social upheaval followed. This was the result of a single volcanic eruption. Imagine the effects of a supervolcanic event like the Toba eruption, but occurring when a technological civilization was at its peak. The geological record shows that such catastrophes are not rare exceptions, but regular features of Earth's history. Years, with smaller but still devastating events happening far more frequently. Volcanic winters, massive earthquakes, tsunami events, and magnetic field reversals are all part of the planet's natural rhythm, a rhythm that could easily interrupt the rise of any technological species. Perhaps most sobering is the realization that our own civilization exists in a brief window of unusual geological stability. The Holocene epoch, which began around 11,700 years ago, has been characterized by a remarkably stable climate and low levels of catastrophic activity. It's during this period of calm that human civilization has been able to develop and flourish. But the geological record suggests that such stable periods are the exception, not the rule. Most of Earth's history has been marked by dramatic swings in climate, frequent catastrophic events, and conditions that would make the development of complex civilization extremely difficult. What if previous attempts at technological civilization arose during earlier stable periods, only to be cut short by the return of geological chaos? What if the rise and fall of civilizations is tied not just to social and political factors, but to deep cycles of planetary stability that operate on timescales far longer than human history? The ice cores from Greenland and Antarctica tell a story of climate that shifts rapidly and unpredictably. Temperature changes of 10 degrees Celsius or more have occurred in the span of just a few decades. Ocean currents that regulate global weather patterns have stopped and started again like a vast planetary engine cycling on and off. During the last ice age, massive freshwater floods from melting glacial lakes repeatedly disrupted ocean circulation, causing sudden shifts between warm and cold periods that would have made long-term planning nearly impossible for any civilization. And yet, scattered throughout this record of chaos and catastrophe, there are anomalies, traces of something that doesn't quite fit the narrative of a planet populated only by hunter-gatherers and simple agricultural communities. In 1972, French scientists discovered something extraordinary in the Oklo uranium mines of Gabon, Africa. The uranium ore showed clear evidence of having undergone nuclear fission reactions, but not recent ones. The isotopic signatures indicated that these reactions had occurred approximately 1.8 billion years ago and had continued for several 100,000 years. The reactions were so well controlled and sustained that they could only have occurred under very specific conditions that shouldn't exist naturally. The official explanation is that these were natural nuclear reactors, created when groundwater acted as a moderator for uranium that was naturally concentrated in the ore body. But the precision required for such reactions to sustain themselves for hundreds of millennia is extraordinary. Some researchers have quietly wondered whether the Oklo reactors might represent something else entirely, evidence of nuclear technology from a previous epoch of Earth's history, when conditions were very different and other forms of life might have achieved technological sophistication. The idea sounds impossible until you consider the vast timescales involved. Complex life has existed on Earth for over 600 million years. Dinosaurs ruled the planet for 865 million years, over 800 times longer than humans have existed. During such immense periods of time, could intelligence have evolved multiple times? Could there have been previous technological species that rose, flourished and vanished long before the first mammals appeared? The challenge of finding evidence for such ancient civilizations would be enormous. Over geological time, the Earth's surface is constantly renewed. Tectonic plates shift and collide, mountains rise and erode away, ocean floors are subducted and recycled. Very little survives unchanged for millions of years, let alone billions. Any artifacts or structures from such ancient times would have been ground to dust long ago. But there might be subtle traces, isotopic anomalies in ancient rocks, unusual mineral deposits, chemical signatures that hint at industrial processes. The Oklo reactors might be just such a trace, a ghostly fingerprint of nuclear technology from an unimaginably distant past. Closer to our own time, other anomalies whisper of possibilities that challenge conventional archaeology. In 1938, German archaeologist Wilhelm König discovered a clay jar in the Iraq Museum that contained a copper cylinder and an iron rod. When filled with an acidic solution, the device produces an electrical current, leading some to call it the Baghdad battery. While mainstream archaeology dismisses it as a curiosity with no practical purpose, others wonder whether it represents evidence of electrical knowledge in the ancient world. Similarly, the Antikythera mechanism, with its incredibly sophisticated gear system, suggests that ancient Greek technology was far more advanced than previously believed. If they could build mechanical computers, what other technologies might they have possessed that left no trace in the historical record? But perhaps the most intriguing anomalies are those that hint at knowledge of things that ancient peoples shouldn't have been able to know. The Piri Reis map of 1513, compiled from much older sources, shows the Antarctic coastline as it would appear without ice, something that wouldn't be discovered by modern explorers until the 20th century. The map appears to be based on ancient sources that had somehow mapped Antarctica during one of the brief periods when it was ice-free, something that last occurred millions of years ago. The Nazca lines of Peru present another puzzle. These massive geoglyphs, carved into the desert floor, can only be properly viewed from the air. They depict animals, geometric patterns, and strange figures that stretch for miles across the landscape. Why would an ancient people create artworks that could only be appreciated from a vantage point they supposedly couldn't reach? Some researchers have suggested that the lines were created for astronomical purposes, as a kind of giant calendar or star map. But others wonder whether they might be evidence of ancient flight, whether the people who created them possessed the technology to view their work from above. The idea seems impossible, but then again, so did many other supposed impossibilities that have since been proven true. The science of forgetting. There is a disturbing truth that archaeologists rarely discuss in public. Most of the past is simply gone. The organic materials that made up the bulk of any ancient civilization, wood, textiles, leather, paper, flesh and bone, decay rapidly under most conditions. What we call the archaeological record is really just the debris, the small fraction of material culture that happened to be made from stone, metal or ceramic, and happened to survive in conditions that prevented decay. We're trying to reconstruct entire civilizations from their garbage dumps and broken pottery, like archaeologists of the future trying to understand our world based solely on landfills and the foundations of buildings. This realization becomes particularly unsettling when you consider how quickly even our most impressive achievements could vanish without maintenance. The steel and concrete that make up our cities are not permanent materials. They are temporary borrowings from the earth that will return to rust and dust in a matter of centuries without constant upkeep. Our electronics, our computers, our vast networks of information storage, all of it depends on continuous maintenance and renewal. Pull the plug on human civilization tomorrow, and within 1,000 years most traces of our technological achievement would be unrecognizable. The only things that would survive in recognizable form would be our stone monuments, Mount Rushmore perhaps, or the Great Dams, and even these would eventually succumb to erosion and collapse. Within 10,000 years, an alien archaeologist visiting Earth would find mostly puzzling ruins, strange isotopic signatures in the soil, and perhaps some very durable plastics that had somehow survived the intervening millennia. Now imagine that timeline extended not just thousands of years into the future, but millions. What would be left of us then? What would survive to tell future investigators that humans had once built cities, split atoms, and reached for the stars? The answer is sobering. Almost nothing. Perhaps some isotopic anomalies from our nuclear tests, a thin layer of unusual materials in the geological record, maybe some extremely durable artifacts buried in very specific conditions. Future scientists would have to be extraordinarily clever and persistent to detect our presence in the deep geological record. This is the problem that faces us when we try to look for evidence of previous technological civilizations on Earth. If such civilizations existed hundreds of thousands or millions of years ago, their traces would be incredibly faint and difficult to detect. We would need to know exactly what to look for and where to look for it. But there might be subtle signs, fingerprints of industrial activity that could persist across geological time. Large-scale mining operations would leave permanent scars in the Earth's crust. The use of fossil fuels would alter the carbon isotope ratios in the atmosphere in ways that might be preserved in ice cores or sedimentary rocks. Nuclear technology would leave distinctive radioactive signatures. Mass extinctions caused by environmental degradation would show up in the fossil record. Some researchers have begun to search for such signatures systematically. The concept has been dubbed the Silurian hypothesis, named after a science fiction race of reptilian beings who ruled Earth before humans. The idea is not to look for artifacts or ruins, but for the subtle geochemical traces that an industrial civilization would inevitably leave behind. The search has turned up some intriguing possibilities. There are periods in Earth's history marked by unusual isotopic signatures, sudden changes in atmospheric composition, and mass extinctions that seem to occur too rapidly to be explained by known natural processes. The Permian-Triassic extinction, for instance, involved not just the death of most species on Earth, but dramatic changes in ocean chemistry and atmospheric composition that happened over an extremely short period of time. Could such events have been caused by runaway industrial activity rather than natural catastrophes? Could previous civilizations have triggered their own extinction through environmental destruction, leaving behind only the chemical signatures of their final collapse? The idea is speculative, but it highlights a crucial point. The absence of obvious evidence for previous civilizations doesn't mean they didn't exist. It might simply mean we don't yet know how to recognize their traces. Consider how much of our own history would be lost if not for written records. The vast majority of human cultures throughout history were pre-literate, preserving their knowledge through oral tradition alone. When those cultures disappeared, through conquest, disease, or environmental collapse, their stories, their technologies, their entire ways of understanding the world vanished with them. Even literate civilizations are incredibly fragile. The Library of Alexandria, which once contained perhaps 500,000 scrolls representing the accumulated knowledge of the ancient world, was gradually destroyed through neglect, religious persecution, and political upheaval. When it finally burned, centuries of scientific and philosophical achievement turned to ash in a matter of hours. The same pattern has repeated throughout history. The Maya developed sophisticated writing systems, advanced astronomy, and complex mathematical concepts. Then their civilization collapsed, and most of their books were deliberately burned by Spanish conquistadors who saw them as works of the devil. Today, we have only 4 surviving Maya codices from a culture that once produced thousands of books. The lesson is clear. Knowledge is far more fragile than we like to believe. Entire bodies of learning can vanish in a single generation if they are not actively preserved and transmitted. Technologies can be lost, rediscovered, and lost again. The wheel, for instance, was invented multiple times by different cultures and was also abandoned by some cultures that had previously used it. If this can happen to civilizations separated by mere centuries or millennia, what about those separated by hundreds of thousands or millions of years? How many times might intelligence have emerged on Earth, reached technological sophistication, and then vanish so completely that no trace remains? The possibility becomes even more intriguing when you consider the deep time perspective. Earth has been habitable for billions of years. Complex life has existed for over 600 million years. Dinosaurs ruled for 165 million years, a period so vast that entire species evolved and went extinct without leaving any trace in the fossil record. During such immense spans of time, natural selection has had countless opportunities to produce intelligence. We tend to think of human-level intelligence as the pinnacle of evolution, but there's no reason to assume we represent the first or only time such intelligence has emerged. Indeed, given enough time, it seems almost inevitable that intelligence would evolve multiple times, in multiple forms. Some of these intelligences might have been very different from our own. They might have been aquatic civilizations that built their cities on the seafloor, leaving no trace after the ocean basins were recycled through tectonic processes. They might have been silicon-based rather than carbon-based, creating technologies we wouldn't recognize as such. They might have been collective intelligences, vast networks of cooperating organisms that achieved technological sophistication without ever developing individual consciousness as we understand it. The more we learn about the diversity and resilience of life on Earth, the more plausible such scenarios become. We have discovered organisms that thrive in conditions previously thought to be lethal, in boiling acid springs, in the crushing depths of ocean trenches, in solid rock miles beneath the surface. Life is far more adaptable and creative than we ever imagined. If life can flourish in such extreme environments, why not intelligence? Why not technological civilization? The only reason we assume such things are rare or unique is that we have only one example to study, ourselves. But what if we are not unique at all, but simply the latest in a long series of intelligent species that have risen and fallen across the vast expanse of Earth's history? The Watchers in the Deep. In the deepest parts of our oceans, where sunlight has never penetrated and pressure would crush human bones to powder, strange things move in the eternal darkness. We know less about our own ocean depth than we do about the surface of Mars. Less than 20% of the ocean floor has been mapped in detail, and less than 5% has been directly explored. The deepest parts of the ocean trenches might as well be alien worlds. So little do we understand about what lies beneath the crushing weight of miles of water. But what we have discovered in those depths is extraordinary. Entire ecosystems that exist independent of sunlight, drawing energy from chemical processes around volcanic vents. Creatures so bizarre they seem like products of science fiction. Transparent organisms with bioluminescent organs, ancient species that have remained virtually unchanged for hundreds of millions of years, vast networks of bacterial colonies that might represent some of the oldest forms of life on Earth. In 1977, researchers exploring the Galapagos Rift discovered something that revolutionized biology: hydrothermal vents surrounded by thriving communities of life in the complete absence of sunlight. These ecosystems are based on chemosynthesis rather than photosynthesis, using chemical energy from the Earth's interior to support complex food webs. The discovery suggested that life might be far more widespread in the universe than previously thought. If life could thrive in Earth's deepest, darkest places, it might also exist in the subsurface oceans of moons like Europa or Enceladus. But the deep ocean holds other mysteries that are harder to explain. In recent years, underwater exploration has revealed structures that don't fit easily into our understanding of natural geological processes. Strange geometric formations on the sea floor, perfectly circular depressions that extend for miles, underwater roads of fitted stones that seem too regular to be natural. Most of these anomalies are dismissed as pareidolia, our tendency to see patterns and purpose in random natural formations. But some are harder to explain away. Off the coast of Japan, the Yonaguni Monument appears to be a massive stepped pyramid submerged beneath 75 feet of water. The structure shows clear evidence of right angles, straight edges, and geometric precision that seem inconsistent with natural erosion patterns. Mainstream archaeology insists that Yonaguni is a natural formation, carved by water and tectonic activity over millions of years. But marine geologist Robert Schoch, who has studied the site extensively, argues that while the basic structure may be natural, it shows clear evidence of human modification. Tool marks, carved steps, and geometric alterations suggest that someone worked the natural formation into a more regular, purposeful shape. If Schoch is correct, the implications are staggering. The Yonaguni Monument was last above sea level over 12,000 years ago, during the Ice Age when ocean levels were much lower. This would mean that sophisticated stoneworking cultures existed in the region long before conventional archaeology suggests such capabilities developed. But Yonaguni is not alone. Similar underwater structures have been reported off the coasts of India, Cuba, and the Mediterranean. In the Gulf of Cambay off western India, sonar has detected what appears to be a large city submerged beneath 120 feet of water. The site includes geometric structures, grid-like street patterns, and what look like step pyramids. Carbon dating of artifacts dredged from the site has yielded dates of up to 9,500 years ago. The implications are profound. If these underwater sites are indeed artificial, the remains of cities and monuments built when sea levels were lower, they suggest that sophisticated civilizations existed during the Ice Age, thousands of years before conventional history begins. And if such civilizations existed, they would have been perfectly positioned along the then exposed continental shelves, in the most fertile and resource-rich areas of the ancient world. When the Ice Age ended and sea levels rose by 400 feet or more, these coastal civilizations would have been inundated. Their cities, their ports, their monuments. Everything would have disappeared beneath the waves. Only scattered survivors would have remained, carrying fragments of knowledge to higher ground, preserving what they could in stories and myths while struggling to rebuild in a changed world. This scenario would explain many of the puzzles that have long perplexed archaeologists. Why do the earliest known civilizations appear so suddenly and fully formed, without clear developmental stages? Why do isolated cultures around the world share similar technologies and architectural styles? Why do flood myths appear in nearly every human culture? The answer might be that civilization didn't begin with the rise of agriculture 11,000 years ago. It restarted then, rebuilt by survivors of much older cultures that had been destroyed by rising seas and climate change at the end of the Ice Age. But the deep ocean might hold more than just the ruins of lost cities. In the abyssal depths, where pressure and cold have preserved organic materials for millions of years, there might be evidence of life forms that evolved intelligence long before vertebrates colonized the land. Consider the cephalopods, octopi, squid, and their relatives. These creatures evolved complex nervous systems and sophisticated behaviors completely independent of the vertebrate line that eventually produced humans. Octopi demonstrate problem-solving abilities, tool use, and what appears to be individual personality. They can change their skin color and texture to communicate complex messages, effectively giving them a form of language written in living color across their bodies. But octopi have short lifespans and no way to pass knowledge from one generation to the next except through genetic programming. They must learn everything anew in each short life. What if, in the deep past, some branch of cephalopod evolution had overcome this limitation? What if they had developed longer lifespans or, better yet, collective memory systems that allowed knowledge to accumulate across generations? Such a species might have developed a very different kind of intelligence from our own, one based on fluid adaptation and rapid learning rather than tool-making and environmental modification. They might have built cities from coral and cultivated sea gardens rather than smelting metals and quarrying stone. Their technology might have been biological rather than mechanical, leaving no trace that we would recognize as artificial. In the deepest ocean trenches, isolated from surface changes for millions of years, such civilizations might have risen and fallen without ever leaving evidence that surface-dwelling archaeologists would recognize. Their ruins would be dissolved by the corrosive deep-sea environment, their artifacts consumed by bacteria, their very existence erased by the slow, patient chemistry of the abyss. The idea sounds like science fiction, but recent discoveries have revealed that the deep ocean is far stranger and more dynamic than we ever imagined. Vast communities of microorganisms exist in the sediments of the ocean floor, some of them billions of years old, living at the very edge of what we consider possible for life. These deep biosphere communities might represent the most ancient forms of life on Earth, preserving genetic and biochemical information from epochs when the planet was very different. What if some of these ancient communities evolved beyond simple microorganisms? What if, given the vast timescales available, they developed complex behaviors, communication systems, even forms of consciousness that we cannot recognize because they operate on completely different principles from our own? The ocean depths might be inhabited by forms of intelligence so alien to our experience that we lack the conceptual framework to even recognize them as intelligent. They might communicate through chemical signals that take years to propagate across ocean basins. They might think in geological time, with individual thoughts lasting centuries and conversations spanning millennia. They might perceive reality through senses we don't possess. experiencing the world as patterns of pressure and chemical gradients, magnetic fields and subsonic vibrations. Such intelligences might have watched the rise and fall of surface civilizations with the detached interest of gods observing the brief lives of mayflies. They might have accumulated knowledge across millions of years, developing understanding of the universe that makes our science seem primitive and limited. And they might still be there, in the crushing depths, patiently observing as we take our first tentative steps into the deep ocean that has been their domain since long before the first fish crawled onto land. This possibility, that Earth's oceans might harbour ancient intelligences that predate terrestrial life by millions or billions of years, adds yet another layer to the mystery of what came before us. We search for evidence of previous civilizations in stone monuments and mythological stories, but perhaps we should be looking deeper, into realms so alien and hostile to our form of life that we never thought to consider them as potential homes for intelligence. The deep ocean keeps its secrets well. In its crushing darkness and impossible cold, in its corrosive chemistry and alien pressures, evidence of previous intelligences might rest beyond our ability to detect or comprehend. We are surface dwellers, creatures of air and light, trying to understand a world that is fundamentally underwater, fundamentally dark, fundamentally different from everything we know about the requirements for complex life. But as our technology improves and our understanding deepens, we are beginning to probe those depths more systematically. Each dive, each sonar survey, each sample brought up from the abyssal plains adds to our knowledge of what lies beneath. And sometimes, just sometimes, we find things that don't quite fit our expectations, anomalies that hint at complexities we haven't yet learned to interpret. The ocean depths are vast beyond imagination, deeper than our highest mountains, more alien than the surface of Mars. If intelligence has evolved multiple times on Earth across its billions of years of history, some of those intelligences might have chosen the depths over the shallows, the eternal darkness over the brief flicker of sunlight. They might still be there, waiting in the deep, watching and remembering everything that has ever lived and died on the surface of their water world. The genetic ghosts. Hidden within the spiral staircase of human DNA lies a library more vast and mysterious than any archive built from stone or paper. Our genome contains not just the blueprint for building a human body, but the entire evolutionary history of life on Earth, a genetic memory that stretches back billions of years to the first replicating molecules that learned to copy themselves in ancient seas. But DNA holds more than evolutionary history. It holds evidence of bottlenecks and expansions, of populations that nearly went extinct and others that exploded across continents. It records the effects of diseases, disasters, and dramatic environmental changes. And within that record, geneticists are discovering patterns that don't quite match the neat timelines of human migration and development that we've constructed from archaeological evidence. The most startling revelation has been how recently our species came close to extinction, not once, but multiple times. The genetic evidence suggests that around 70,000 years ago, the human population crashed to perhaps as few as 2,000 breeding individuals. The entire future of our species balanced on the edge of oblivion, survivors scattered across a continent, carrying with them a severely restricted gene pool that we still carry today. This bottleneck coincides roughly with the Toba supervolcanic eruption, one of the largest volcanic events in the past 2 million years. The eruption threw enough ash and sulfur into the atmosphere to trigger a volcanic winter that lasted for years, dramatically reducing global temperatures and making survival extremely difficult for human populations that were still heavily dependent on hunting and gathering. But the genetic evidence suggests this wasn't the only near-extinction event in human history. There are signs of earlier bottlenecks, earlier crashes in population that reduced our ancestors to small, isolated groups, struggling to survive in a hostile world. Each time, somehow, the species recovered, but not without losing something in the process. What's particularly intriguing is that some of these population crashes don't correspond to any known natural disasters. The genetic signatures suggest sudden, dramatic reductions in population that occurred during periods when the climate was relatively stable and conditions should have favoured human expansion. It's as if entire populations simply vanished, leaving only small remnant groups to carry the human lineage forward. This pattern becomes even more mysterious when you consider the genetic diversity of modern human populations. Despite having spread across the entire globe, humans are remarkably genetically uniform compared to other species. We have less genetic diversity than chimpanzees, who are confined to a much smaller area of Africa. This suggests that our global expansion happened very recently and from a very small founding population. But there are anomalies in our genetic structure that hint at a more complex history. Traces of DNA that don't fit the straightforward narrative of human evolution from Africa. Genetic markers that suggest ancient admixture with populations that shouldn't have existed according to conventional timelines. Sequences that appear to have been acquired through horizontal gene transfer, a process common in bacteria but supposedly impossible in complex organisms like humans. Most controversial are the findings related to what geneticists call ghost populations, human-like groups that contributed genetic material to modern humans but left no direct descendants and no archaeological trace. These populations are detected only through their genetic signatures, like shadows cast by people who have long since walked out of the light. The most famous of these ghost populations are the Denisovans, known only from a few fragments of bone found in a Siberian cave, but whose genetic legacy makes up 2 to 3% of the genome of modern Melanesians and Aboriginal Australians. The Denisovans apparently lived across a vast area of Asia for hundreds of thousands of years, yet we have almost no physical evidence of their existence, just their genetic fingerprints preserved in the DNA of their distant descendants. But genetic analysis suggests there were other ghost populations as well, groups that contributed to human ancestry, but whose physical remains have never been found. Some of these populations appear to have had unusual characteristics, genetic adaptations that suggest they lived in extreme environments or had unusual physiological capabilities. Perhaps most intriguingly, some researchers have identified genetic sequences in modern humans that appear to be much older than they should be, according to standard models of human evolution. These archaic sequences don't match any known human ancestor, but seem to represent genetic contributions from populations that diverged from the main human line hundreds of thousands or even millions of years ago. The conventional explanation is that these sequences represent contamination from other hominin species that modern humans encountered and interbred with during their expansion out of Africa. But some researchers have proposed a more radical possibility, that these genetic ghosts represent the remnants of earlier human civilizations that achieved technological sophistication long before our own. The idea is based on the observation that technological development can dramatically affect evolutionary pressures. A species that develops agriculture, medicine, and complex social organization can survive in environments and in population densities that would be impossible for hunter-gatherers. They can also develop genetic adaptations to the artificial environments they create, resistance to diseases spread by dense urban populations, ability to digest agricultural products, tolerance for the toxins produced by metallurgy and manufacturing. If such a technological species existed, in the deep past their genetic signature might persist even after their civilization collapsed, and their descendants reverted to hunter-gatherer lifestyles. The technological adaptations would become evolutionary baggage, genetic sequences that served no function in a post-civilizational environment, but persisted simply because they weren't actively harmful. Over thousands or tens of thousands of years, most such sequences would be gradually eliminated by natural selection. But some might persist, especially if they were linked to other genes that did provide survival advantages. These genetic ghosts would be detectable by modern analysis as sequences that seem too old, too complex, or too specialized for the environments in which they're found. The genetic evidence becomes even more intriguing when combined with recent discoveries about the antiquity and sophistication of human behavior. Archaeological sites like Blombos Cave in South Africa have revealed evidence of symbolic behavior, artistic expression, and complex tool-making dating back over 100,000 years, much earlier than previously thought possible. At Blombos, archaeologists have found carefully crafted shell beads, ochre crayons with abstract engravings, and sophisticated bone tools that required advanced planning and technical skill to create. The site suggests that modern human cognition and behavior emerged much earlier than the Great Leap Forward that supposedly occurred around 40,000 years ago. But if modern human behavior emerged 100,000 or even 200,000 years ago, what were our ancestors doing during the intervening millennia? The archaeological record shows long periods of apparent stasis punctuated by sudden bursts of innovation. Technologies appear, disappear, and reappear again thousands of years later. Artistic traditions start and stop with no clear explanation. This pattern is puzzling if you assume steady progressive development, but it makes perfect sense if you assume that human populations went through repeated cycles of advancement and collapse. Technologies would be developed during periods of population growth and cultural stability, then lost during environmental crises or social upheaval. Survivors would preserve fragments of knowledge, but it might take thousands of years for conditions to become favorable enough for that knowledge to be fully redeveloped and expanded upon. The genetic evidence supports this cyclical model. The population bottlenecks recorded in our DNA correspond to periods when technologies and cultural traditions would have been most vulnerable to loss. Each crash would have scattered the surviving populations, breaking up the social networks that preserved and transmitted complex knowledge. But each recovery would have started from a higher baseline than the previous cycle. The survivors would carry not just genetic memories of adaptation, but cultural memories of what was possible. They would know that humans could work metal, build monuments, navigate by the stars. Even if they had temporarily lost the specific knowledge of how to do these things. This might explain the sudden appearance of sophisticated technologies in the archaeological record. The Neolithic Revolution, the Bronze Age, the development of writing and mathematics, all of these might represent not the first invention of these technologies, but their reinvention by populations who carried genetic and cultural memories of earlier achievements. The human genome is a palimpsest, a manuscript that has been written over and erased and written over again countless times. Each layer tells a different story about our past, and the deepest layers preserve memories so ancient that we're only now learning how to read them. As our techniques for genetic analysis become more sophisticated, we're uncovering evidence of complexities in human history that challenge our most basic assumptions about who we are and where we came from. We are the children of survivors of volcanic winters and cosmic impacts, of climate shifts and population crashes, of the rise and fall of civilizations whose names we never learned because they forgot how to write them down. We carry within our cells the genetic memories of all those who came before us, the accumulated wisdom and experience of 1,000,000 generations of ancestors who faced the darkness and somehow found a way forward. But we also carry something else, the genetic potential for all the capabilities and achievements of those who came before us. If previous human populations developed sophisticated technologies, if they built civilizations and created art and music and literature, then the genetic capacity for those achievements still exists within us. We are not just the inheritors of their failures, but of their possibilities. In the spiraling darkness of our DNA, the ghosts of previous civilizations whisper their secrets to anyone who knows how to listen. They tell us that we have been here before, that we have risen and fallen and risen again, that the human story is far older and more complex than we ever imagined. And they tell us something else, something that echoes through the generations like a promise or a warning. We can do it again. The keepers of time. In the pre-dawn darkness of winter solstice morning, atop the hill of Newgrange in Ireland, something miraculous happens that has been happening for over 5,000 years. As the sun rises above the horizon, a single shaft of golden light penetrates the roof box of the ancient passage tomb, travels down the 60-foot corridor, and illuminates the triple spiral carved into the back wall of the burial chamber. For exactly 17 minutes, the heart of the monument blazes with light, then returns to darkness for another year. This is not an accident. The entire massive structure, 200 feet in diameter, built from 200,000 tons of stone and earth, was designed and constructed with mathematical precision to capture this single moment of cosmic alignment. The builders had to understand not just basic astronomy, but the complex mechanics of Earth's orbit, the precession of the equinoxes, and the subtle variations in the sun's path across the sky that occur over centuries. Newgrange predates Stonehenge by 500 years and the Great Pyramid by 600 years. It was built by Neolithic farmers who supposedly had only stone tools, wooden rollers, and basic agricultural knowledge. Yet the astronomical calculations required for its construction would challenge modern engineers equipped with computers and precise instruments. This is the paradox that haunts our understanding of the ancient world. Again and again, we find evidence of astronomical knowledge so sophisticated, so precise, so far-reaching in its implications that it seems to come from a completely different level of civilization than the one we think we're studying. The phenomenon is global. In the jungles of Guatemala, the Maya calculated the length of the solar year to 365.420 days, more accurate than the Julian calendar that Europe would use for another 1,000 years. They tracked the cycles of Venus with an error of only 2 hours over a period of 500 years. They predicted eclipses centuries into the future and recorded astronomical events from centuries in the past. At Nabta Playa in the Egyptian desert, stone circles arranged by cattle herders 7,000 years ago align with the rising of Sirius and the summer solstice. But the alignments were not designed for the time when they were built. They point to where these celestial events occurred thousands of years earlier, suggesting the builders were working from much older astronomical records. In Cambodia, the massive temple complex of Angkor Wat, built in the early 12th century, mirrors the constellation Draco as it appeared at the spring equinox in 10,500 BCE, over 11,000 years before the temple was constructed. The correlation is so precise that it seems impossible to attribute to coincidence. These examples multiply across every continent and every epoch of human history. Ancient structures aligned to celestial events with pinpoint accuracy, calendars that track cosmic cycles spanning thousands of years, myths and texts that preserve astronomical data from times so remote that the knowledge they contain couldn't have been gathered by the cultures that preserved them. The conventional explanation is that ancient peoples were keen observers of the sky, and that over many generations they accumulated accurate astronomical knowledge through patient observation and record keeping. This explanation works for simple phenomena, tracking the phases of the moon, noting the seasonal movement of constellations, predicting the annual flood cycles. But it falls apart when we examine the more sophisticated examples. The precession of the equinoxes, for instance, is a phenomenon that takes 25,020 years to complete one full cycle. It's caused by a wobble in Earth's axis that makes the position of the north celestial pole shift slowly against the background of stars. To detect this movement requires not just centuries of careful observation, but a conceptual framework sophisticated enough to separate this subtle effect from all the other complex motions of celestial objects. Yet evidence for knowledge of precession appears throughout the ancient world. The Egyptians encoded it in their mythology, describing ages ruled by different gods that correspond to different precessional epochs. The Greeks inherited this knowledge and developed it into a formal astronomical theory. Hindu and Buddhist texts describe vast cosmic cycles that match precessional periods with remarkable accuracy. Most intriguingly, this knowledge appears to be embedded in monuments and myths from cultures that had no known contact with each other. The precessional cycle appears in Norse mythology, in Mesoamerican calendars, in the astronomical alignments of temples across Asia and Africa. It's as if this knowledge was part of a global heritage, preserved and transmitted by different cultures across vast spans of time. Consider the problem of longitude. For most of human history, determining one's position east or west on the globe was one of navigation's greatest challenges. The problem wasn't solved in Europe until the 18th century, with the development of accurate marine chronometers that could keep precise time during long ocean voyages. Yet the ancient Egyptians somehow managed to align the Great Pyramid with true cardinal directions to within 3/60th of a degree. The pyramid's base is also level to within just 2.1 centimetres across its entire 230-metre width. This level of precision requires not just sophisticated surveying techniques, but accurate knowledge of the Earth's shape and rotation. Similarly, many ancient sites around the world are positioned at locations that seem to have been chosen for their geometric relationships to other sites thousands of miles away. The Great Pyramid sits at exactly 30 degrees north latitude, 1/3 of the way from the equator to the pole. Angkor Wat is precisely 72 degrees of longitude east of the pyramids at Giza, a relationship that corresponds to the precessional number 72, the number of years it takes for precession to shift the celestial pole by 1 degree. These geometric relationships appear too frequently and too precisely to be coincidental. They suggest a level of global coordination and mathematical sophistication that seems impossible for ancient civilizations using supposedly primitive technologies. How did builders in Egypt communicate with builders in Cambodia? How did they achieve such precise measurements across continental distances? One possibility is that these monuments were built according to a master plan developed by a civilization with global reach and sophisticated technology, a civilization that predated the individual cultures we credit with their construction. The monuments we see today might be reconstructions or modifications of much older sites, built according to plans and alignments established in a remote antiquity. This would explain another puzzling aspect of ancient astronomical sites. Many of them seem to commemorate celestial events that occurred thousands of years before the monuments were built. The Sphinx's gaze toward the constellation Leo corresponds to the spring equinox of 10,500 BCE, when Leo rose directly in front of the monument at dawn. The star maps in Egyptian temples show the night sky as it appeared millennia before those temples were constructed. It's as if the builders were trying to preserve memories of specific moments in deep time, cosmic anniversaries that held special significance for reasons we no longer understand. But why would ancient peoples go to such extraordinary effort to commemorate astronomical events from their distant past? What was so important about these particular moments in cosmic history? The answer might lie in the growing realization that Earth's relationship with the cosmos is far more dynamic and dangerous than we once believed. The solar system moves through different regions of the galaxy over vast periods of time, encountering varying densities of cosmic dust, different levels of radiation, and gravitational influences from nearby stars. These cosmic environments can have profound effects on Earth's climate, magnetic field, and the evolution of life itself. Recent research has revealed that the solar system's orbit around the galactic center brings us through regions of space with very different properties. Every 26 million years or so, we pass through the galactic plane, where the density of matter and energy is much higher than in the quieter regions where we normally reside. These passages correlate with periods of increased cosmic radiation, climate disruption, and mass extinctions in Earth's geological record. The cycle isn't perfectly regular. It's influenced by the gravitational effects of nearby stars, the structure of spiral arms in the galaxy, and other cosmic factors that can accelerate or delay our passage through these dangerous regions. But ancient astronomers, given enough time and careful observation, might have detected these patterns and learned to predict when Earth would be most vulnerable to cosmic catastrophes. This could explain the obsession with long-term astronomical cycles that appears in so many ancient cultures. The Maya long count calendar, which tracks a cycle of 5,125 years, might not be arbitrary. It might correspond to a period during which specific cosmic dangers recur. The Hindu concept of yugas, vast cosmic ages lasting hundreds of thousands of years, might preserve knowledge of even longer cycles that affect the stability of civilizations on Earth. If previous civilizations had achieved a level of astronomical sophistication that allowed them to detect these cosmic cycles, they might have devoted enormous resources to preserving this knowledge for their descendants. The monuments and calendars and myths might all be part of a vast early warning system designed to help future civilizations recognize when dangerous periods were approaching and prepare accordingly. This interpretation gives new meaning to many ancient texts that describe cycles of creation and destruction, golden ages followed by catastrophic endings. The Hindu Puranas describe 4 yugas that repeat endlessly, with each cycle ending in dissolution and renewal. The Maya believed in multiple creation cycles, each ending when the gods became dissatisfied with their creations and destroyed the world to start over. Norse mythology describes Ragnarok as part of an eternal cycle, where the world is destroyed and reborn with each cosmic age. These might not be metaphysical concepts or moral allegories, but practical astronomical information encoded in mythological language. The gods who destroy and recreate the world might represent cosmic forces, galactic radiation, solar variations, gravitational disruptions that periodically threaten the stability of Earth's biosphere. The ages might correspond to real periods of cosmic safety and danger that repeat according to astronomical cycles spanning thousands or millions of years. From this perspective, the ancient monuments take on a different significance. They weren't just temples or tombs, but observatories and record-keeping systems designed to track humanity's progress through these cosmic cycles. The precise astronomical alignments weren't just religious symbolism, but functional instruments for measuring Earth's position in space and time. The Great Pyramid, for instance, might have served as a kind of cosmic clock, its internal chambers and passages aligned to track the movement of specific stars and constellations over vast periods of time. The King's Chamber points toward Orion, associated in Egyptian mythology with Osiris, the god of death and rebirth. The Queen's Chamber points toward Sirius, linked with Isis, the goddess of magic and renewal. These weren't arbitrary choices. They might represent stars whose behavior serves as markers for Earth's passage through different cosmic environments. Similarly, Stonehenge's complex arrangement of stones creates multiple sight lines that track not just annual solar and lunar cycles, but much longer periods of celestial motion. The monument was built in phases over more than 1,500 years, with each phase adding new capabilities for astronomical observation and calculation. The final structure could predict eclipses decades in advance and track the 18.6-year cycle of lunar standstills with remarkable precision. But Stonehenge's most mysterious feature might be its acoustic properties. Recent research has revealed that the circle of stones creates a unique sound environment, amplifying certain frequencies while dampening others. Specific locations within the circle produce distinct resonances when sounds are made, almost as if the monument was designed as a kind of acoustic instrument. This raises intriguing possibilities about how astronomical knowledge was preserved and transmitted in ancient times. Sound and music can encode complex information in memorable patterns that persist across generations even when written records are lost. The specific frequencies produced at Stonehenge might correspond to astronomical cycles, with different tones representing different periods of cosmic time. Many ancient cultures associated music and mathematics with cosmic harmony. The Pythagoreans believed that celestial bodies produced musical tones as they moved through space, and that understanding these cosmic harmonies was the key to understanding the structure of the universe. Hindu traditions describe the universe as being created and sustained by sound vibrations, with different frequencies corresponding to different levels of cosmic manifestation. If advanced ancient astronomers had discovered mathematical relationships between cosmic cycles and harmonic frequencies, they might have encoded crucial astronomical data in musical forms that could be preserved and transmitted through oral tradition, even during periods when written records were lost. The songs and chants that accompany ancient rituals might contain sophisticated astronomical information disguised as religious or ceremonial content. This possibility becomes more intriguing when we consider how much astronomical knowledge has been preserved in seemingly primitive cultural forms. Aboriginal Australian songlines encode precise navigation information across thousands of miles of continent, with each song corresponding to specific landmarks, water sources, and seasonal patterns. The information is so accurate that modern GPS systems confirm the precision of traditional navigation techniques that have been passed down orally for tens of thousands of years. Similarly, Polynesian navigators used traditional charts and stick charts to guide voyages across thousands of miles of open ocean, using techniques that allowed them to determine their position by reading wave patterns, star positions, and subtle environmental cues. These methods were far more sophisticated than European navigation techniques available at the same time, yet they required no written records or mechanical instruments, just precise cultural knowledge passed down through generations of master navigators. If such sophisticated information could be preserved in traditional forms for thousands of years, what about astronomical knowledge developed by previous technological civilizations? What if the myths and monuments we've inherited contain not just simple observations of celestial phenomena, but precise mathematical data about cosmic cycles that affect the long-term survival of Earth's biosphere? The implications are staggering. Every ancient culture might be the guardian of fragments of a vast astronomical database compiled over millions of years by successive civilizations. The monuments might be backup systems designed to preserve crucial information, even if the cultures that built them collapse completely. The myths might be mnemonic devices that encode complex mathematical relationships in story form, allowing essential knowledge to survive even when its scientific context is forgotten. From this perspective, our current civilization occupies a unique position in the cosmic cycle. We have developed the technological capability to verify and extend the astronomical knowledge preserved by our predecessors, but we may be running out of time to fully decode and understand it before the next dangerous period in Earth's cosmic journey begins. The ancient astronomers knew something that we're only beginning to rediscover, that Earth's fate is intimately connected to cosmic cycles operating on scales much larger than human history. They devoted enormous resources to tracking these cycles and preserving the knowledge for future generations. The question now is whether we can decode their warnings quickly enough to benefit from their hard-won wisdom. As we stand at the threshold of becoming a truly spacefaring civilization, we might be approaching a cosmic test that previous civilizations failed. The monuments they left behind might not just be archaeological curiosities, but survival manuals for navigating the dangerous periods that lie ahead. The time has come to take their warnings seriously and learn from their example, before it's too late to avoid repeating their fate. The archive of everything deep beneath the Giza Plateau in chambers that official archaeology claims do not exist. Legend speaks of a vast library containing the complete records of human civilization. The Hall of Records, as it has been called, supposedly holds not just the history of Egypt, but the entire story of humanity's rise and fall across multiple epochs of deep time. No such chamber has ever been found, despite decades of ground-penetrating radar surveys, drilling projects, and exhaustive exploration of the Giza complex. Yet the legend persists, supported by ancient Egyptian texts that speak of hidden repositories of wisdom, by the testimony of classical authors who claim to have seen such archives, and by the nagging sense that a civilization capable of building the Great Pyramid must have possessed knowledge far beyond what their surviving texts reveal. But what if the Hall of Records was never meant to be a single physical location? What if the ancient keepers of knowledge were far cleverer than we imagined, distributing their most precious information across multiple storage systems designed to survive different types of catastrophes? The more we study ancient monuments, texts, and traditions, the more they seem to function as components of a vast distributed archive, a global information storage network that preserves crucial knowledge in multiple redundant formats designed to survive the collapse of individual civilizations. Consider the mathematical constants embedded in the Great Pyramid. Its dimensions encode not just pi and the golden ratio, but the circumference of the Earth, the length of the year, the speed of light, and dozens of other physical constants that supposedly weren't discovered until modern times. These numbers aren't just carved into the stone, they're built into the very structure of the monument, preserved in ratios and proportions that would survive even if all surface decorations were eroded away. This technique of encoding information in architectural proportions appears at sites around the world. Angkor Wat's dimensions correspond to cosmic cycles measured in thousands of years. Stonehenge's geometry encodes astronomical constants and mathematical relationships. The Mayan pyramids at Chichen Itza and Teotihuacan contain precise numerical data about planetary orbits and calendar calculations. The distributed nature of this information suggests a deliberate preservation strategy. If crucial knowledge was scattered across multiple monuments on different continents, it would be almost impossible for any single catastrophe to destroy it completely. Even if several sites were lost, enough would survive to allow future civilizations to reconstruct the complete database. But the ancient archivists didn't stop with monuments. They also encoded information in stories, mathematical concepts, and cultural practices that could survive even the complete destruction of physical structures. The stories we call myths often contain precise astronomical data, mathematical relationships, and scientific concepts disguised as narratives about gods and heroes. The Hindu epics, for instance, contain remarkably accurate descriptions of nuclear weapons, aerial warfare, and genetic engineering techniques, all embedded in stories about divine beings and magical powers. The Ramayana describes Vimanas, flying vehicles, with specifications so detailed that modern engineers have used them to design working aircraft. The Mahabharata contains passages about weapons that sound suspiciously like nuclear bombs, complete with descriptions of radiation sickness and environmental contamination. These descriptions are usually dismissed as fantasy or primitive attempts to understand natural phenomena. But what if they represent something else entirely? Technical manuals disguised as religious literature, preserved across thousands of years by cultures that no longer understood the original scientific context. The same pattern appears in traditions around the world. Aboriginal Australian Dreamtime stories contain precise geological information about events that occurred tens of thousands of years ago, including the formation of specific landforms and the effects of sea level changes at the end of the Ice Age. These stories were supposedly created by Stone Age peoples with no understanding of geology, yet they preserve accurate scientific information with remarkable precision. Polynesian creation myths describe the formation of island chains with geological accuracy that matches modern scientific understanding. Norse legends contain detailed descriptions of climate cycles and their effects on human populations. Native American traditions preserve information about astronomical events, geological catastrophes, and environmental changes spanning thousands of years. The consistency and accuracy of this information across so many different cultures suggests that it comes from a common source, a sophisticated understanding of Earth's history and cosmic environment that was systematically preserved in story form when more direct recording methods became unavailable. But perhaps the most intriguing aspect of this distributed archive is how it seems designed to reveal itself gradually as human knowledge advances. The mathematical constants in the pyramids only became apparent when we developed the tools to measure them precisely. The astronomical alignments of ancient monuments only made sense when we understood precession and long-term celestial mechanics. The scientific information in ancient texts only becomes recognizable when we rediscover the technologies they describe. It's almost as if the ancient archivists anticipated that future civilizations would develop knowledge in a particular sequence and designed their information storage system to provide confirmation and additional data as we reached each level of understanding. The monuments function like a cosmic combination lock, revealing their secrets only when we demonstrate that we possess the conceptual keys to interpret them correctly. This interpretation explains many of the anomalies that have puzzled researchers for decades. Why do ancient monuments contain information about physical constants that their builders supposedly couldn't have known? Because the builders weren't the original designers. They were reconstructing from plans created by a previous civilization with advanced scientific knowledge. Why do myths from isolated cultures contain such similar descriptions of advanced technologies and cosmic catastrophes? Because they're all fragments of the same original database, preserved in different cultural contexts but ultimately deriving from the same source. Why do ancient astronomical sites commemorate celestial events from thousands of years before they were built? Because they're part of a long-term monitoring system, designed to track cosmic cycles that operate on timescales much longer than individual civilizations. The distributed archive theory also explains why so much ancient knowledge seems to be concentrated in specific locations and cultures. Egypt, Mesopotamia, India, China, and Mesoamerica weren't just the birthplaces of civilization. They were the designated repository sites where survivors of an earlier global civilization concentrated their efforts to preserve and transmit crucial knowledge. These cultures became the inheritors and guardians of information systems they didn't fully understand, but which they faithfully maintained and transmitted across thousands of years. The priest classes that preserved ancient traditions weren't just religious figures. They were the human components of a vast data storage network, biological hard drives programmed to maintain and transmit information, even when its original purpose was forgotten. This would explain the remarkable continuity of certain traditions across millennia, even through periods of political collapse and cultural upheaval. The essential information was too important to lose, so it was embedded in religious practices, architectural traditions, and cultural rituals that were maintained even when their original scientific context was no longer understood. As our own civilization advances, we're beginning to recognize the sophistication of this ancient information storage system. Modern attempts to preserve knowledge for future civilizations face exactly the same challenges that the ancient archivists did: how to encode essential information in formats that will survive technological collapse, environmental catastrophe, and cultural discontinuity. The Svalbard Global Seed Vault attempts to preserve genetic diversity in a frozen repository designed to survive climate change and political upheaval. The Long Now Foundation is building a 10,000-year clock designed to encourage long-term thinking and preserve information across multiple civilizations. Various projects have proposed encoding human knowledge in crystalline matrices, DNA sequences, and astronomical markers that could survive geological timescales. But all of these modern efforts pale in comparison to the elegance and redundancy of the ancient system. By distributing information across multiple formats — architectural, mythological, mathematical, astronomical, and cultural — the ancient archivists created a storage network that has already survived multiple civilizational collapses and continues to reveal new information as our ability to decode it improves. We are not just uncovering the history of ancient civilizations. We are accessing a vast database of human knowledge that spans hundreds of thousands, possibly millions of years. Each new archaeological discovery, each decoded text, each recognized astronomical alignment adds another piece to a puzzle that reveals not just where we came from, but where we might be heading. The ancient archive is still active, still transmitting its carefully preserved information to anyone with the knowledge and wisdom to decode it. The question is whether we'll prove worthy inheritors of this vast repository of human experience, or whether we will repeat the mistakes that led to its original creator's downfall. The stones are still speaking. The numbers are still adding up. The stars are still marking time in their ancient patterns. And somewhere in the intersection of all this preserved knowledge lies the key to understanding not just our past, but our future, if we can learn to listen before it's too late. The Consciousness Codex. In the sacred cave of Lascaux, 17,000 years beneath the surface of France, ancient artists created something that challenges everything we think we know about the development of human consciousness. The paintings that cover these underground galleries are not primitive scratchings or simple animal portraits. They are sophisticated works of art that demonstrate perspective, movement, shading, and compositional sophistication that rivals anything created in recorded history. But the caves hold secrets that go far beyond artistic technique. Recent analysis has revealed that many of the paintings correspond to star maps, with the positions of animals matching the locations of constellations in the night sky, as they appeared tens of thousands of years ago. The caves function as both art galleries and planetariums, encoding astronomical information in symbolic form that has survived since the end of the Ice Age. Even more mysteriously, the acoustic properties of the caves suggest they were designed to produce specific sound effects. Certain chambers create echoes that enhance particular frequencies, while others produce resonances that can induce altered states of consciousness. The painted areas correspond precisely with the locations that produce the most dramatic acoustic effects, as if the visual and auditory experiences were designed to work together. This combination of visual art, astronomical data, and consciousness, altering sound environments, points towards something far more sophisticated than the shamanic rituals that archaeologists usually invoke to explain cave art. It suggests that Paleolithic humans possessed an understanding of consciousness itself, how it could be modified, enhanced, and used to access information beyond the reach of ordinary perception. This pattern appears at sacred sites around the world. The oracle at Delphi delivered prophecies while in trance states induced by ethylene gas seeping from geological fissures beneath the temple. The design of the chamber amplified these natural psychoactive effects, creating a controlled environment for accessing altered states of consciousness. Recent geological surveys have confirmed that the ancient Greeks positioned their most important oracle precisely over a unique combination of geological features that produced the optimal conditions for consciousness modification. In the Amazon basin, indigenous shamans have used ayahuasca and other plant medicines for thousands of years to access what they describe as plant intelligence, direct communication with the molecular consciousness of the forest. The knowledge they gain through these experiences includes detailed information about the medicinal properties of hundreds of plant species, complex ecological relationships, and sustainable resource management techniques that modern science is only beginning to understand. What's remarkable is that this plant-derived knowledge often proves to be scientifically accurate when tested in modern laboratories. Shamans with no formal training in chemistry or pharmacology somehow know exactly which plants contain specific alkaloids, how to combine them for maximum effectiveness, and how to neutralize dangerous compounds through precise preparation techniques. The conventional explanation is that this knowledge was developed through trial and error over many generations, but the complexity and precision of traditional pharmacology suggests something more sophisticated, a systematic method for accessing information directly from natural systems through altered states of consciousness. This possibility becomes more intriguing when we consider that many of the world's most important scientific discoveries have occurred during altered states of consciousness. Kekule's discovery of the benzene ring came to him in a dream about a snake seizing its own tail. Tesla's alternating current system was revealed to him during a walk while reciting poetry. Einstein's theory of relativity emerged from thought experiments that involved imagining himself riding beams of light. The history of science is filled with examples of breakthrough insights that occurred not through logical analysis, but through intuitive leaps that seem to come from beyond the reach of normal conscious thought. These discoveries often arrived complete and fully formed, requiring only mathematical verification rather than conceptual development. What if this represents not just the quirky psychology of creative genius, but access to a deeper layer of information that exists beyond individual consciousness? What if consciousness itself is not generated by the brain, but is instead something the brain accesses, like a radio receiver tuning into broadcasts from a larger information field? This interpretation is supported by an increasing body of research suggesting that consciousness may not be localized in the brain at all. Studies of near-death experiences, out-of-body phenomena, and remote viewing suggest that consciousness can operate independently of physical brain function. Quantum physics has revealed that information appears to exist at a fundamental level of reality, suggesting that consciousness and information might be different aspects of the same underlying phenomenon. If consciousness functions as a kind of cosmic internet, connecting all living systems to a vast reservoir of information, then the altered states practiced by ancient cultures might represent sophisticated technologies for accessing this network. The cave paintings, the oracle chambers, the plant medicine ceremonies, all of these might be hardware components of an ancient consciousness modification system designed to download information from non-local sources. This would explain many of the anomalies we find in ancient knowledge systems. How did ancient astronomers know about celestial phenomena that couldn't be observed with the naked eye? How did traditional healers discover complex medicinal compounds without modern research methods? How did ancient architects encode mathematical constants that weren't supposed to be discovered for thousands more years? The answer might be that they accessed this information directly through consciousness technologies that we have largely forgotten how to use. The sophisticated practices preserved in mystery schools, shamanic traditions, and esoteric teachings might be the remnants of scientific protocols for consciousness research that were once as systematic and rigorous as modern laboratory methods. Ancient text often describes specific techniques for achieving altered states that sound remarkably like modern consciousness research protocols. The Egyptian Book of the Dead provides detailed instructions for navigating non-ordinary reality. The Tibetan Book of the Dead describes precise methods for maintaining awareness during the dissolution of ordinary consciousness. Hindu and Buddhist traditions preserve sophisticated maps of consciousness that catalogue different types of awareness and the techniques for accessing them. These texts weren't religious in the modern sense. They were technical manuals for consciousness exploration, preserved in symbolic language that disguised their scientific content from those who weren't initiated into the proper protocols. The ancient mystery schools that preserved these techniques operated more like research institutions than religious organizations. They required years of training, maintained strict protocols for consciousness modification experiments, and preserved detailed records of their findings. The initiates weren't worshippers. They were consciousness researchers, using systematic methods to explore the nature of reality at levels beyond ordinary perception. What they discovered through these investigations might have included not just information about the natural world, but knowledge about the deep structure of time itself. If consciousness can access information non-locally, it might also be able to access information non-temporally, gathering data from past and future events through some mechanism that transcends ordinary causality. This could explain how ancient cultures possessed knowledge about future astronomical events, future geological catastrophes, and future technological developments. The prophecies preserved in ancient texts might not be supernatural predictions, but scientific reports based on consciousness-based information-gathering techniques. From this perspective, the decline of ancient civilizations might be connected not just to external catastrophes, but to the loss of consciousness technologies that had allowed them to anticipate and prepare for future challenges. When the techniques for accessing non-local information were lost, civilizations became vulnerable to surprises that their predecessors could have foreseen and avoided. Our own civilization might be approaching a similar crossroads. We have developed powerful technologies for manipulating the external world, but we have largely abandoned the exploration of consciousness itself. We can split atoms and sequence genomes, but we have little systematic understanding of how consciousness operates, or how it might be enhanced to access broader ranges of information. Meanwhile, the challenges we face, climate change, resource depletion, social inequality, technological risks, might require exactly the kind of long-term perspective and systemic understanding that consciousness-based information gathering could provide. We might need to rediscover and modernize the ancient consciousness technologies if we want to navigate successfully through the dangerous period ahead. The good news is that the knowledge hasn't been completely lost. Indigenous traditions around the world still preserve consciousness modification techniques that could be studied and developed using modern scientific methods. Psychedelic research is beginning to reveal the neural mechanisms underlying altered states, while quantum physics provides theoretical frameworks for understanding how consciousness might access non-local information. What we need now is the wisdom to recognize that consciousness itself might be the most important technology we can develop, not just for understanding the past, but for creating a sustainable future. The ancient consciousness codex is still accessible to anyone willing to undertake the training and research necessary to decode it. The cave painters of Lascaux might have been trying to tell us something crucial about the nature of consciousness and its role in human survival. Their message, encoded in pigment and stone and carefully designed acoustic chambers, might still be waiting for us to develop the proper protocols for receiving it. In the darkness of those ancient caves, surrounded by star maps painted by Paleolithic astronomers, we might finally understand what our ancestors were trying to preserve. Not just information about the external world, but techniques for expanding consciousness itself to embrace the full spectrum of available knowledge. The question now is whether we have the courage and wisdom to pick up where they left off, before the window of opportunity closes and we lose access to the consciousness codex forever. In the end, we circle back to where we began, to the stories told around fires, to the myths that refuse to die, to the whispers of deep memory that insist we have been here before. But now, having followed the evidence through stone and bone, through DNA and disaster, through the depths of oceans and the heights of mountains, the whispers have become something else. They have become a chorus, a symphony of clues that harmonize into a single haunting melody. The song of return, the eternal rhythm of rise and fall that beats like a heart through the deep time of our planet. We are not the first, we may not be the last, but we are here now, in this moment between forgetting and remembering, between the end of one cycle and the beginning of the next. We stand at the same crossroads that every previous civilization has faced, carrying the same gifts and curses that led them to greatness and to ruin. The evidence we have gathered does not prove that advanced civilizations existed in the deep past, but it suggests, no, it insists, that the possibility cannot be dismissed. Too many anomalies align, too many patterns repeat, too many voices across too many cultures tell variations of the same story, for it all to be coincidence or wishful thinking. The megaliths that stretch across continents like the remnants of some vast construction project. The genetic bottlenecks that record near extinctions followed by mysterious recoveries. The flood myths that remember the same catastrophe from 1,000 different perspectives. The technologies that appear and disappear and reappear as if drawn from some common well of knowledge that periodically runs dry and is then rediscovered. The myths were trying to tell us something important, that human history is not a straight line from primitive to sophisticated, from ignorant to enlightened, from weak to powerful. It is a spiral, a series of cycles that repeat but never exactly, each one building on the ruins of the last while adding something new to the mix. We have been farmers before, and we forgot how to grow food and had to learn again. We have been builders before, and we forgot how to cut stone and had to rediscover the techniques. We have been astronomers before, mapping the movements of the stars, only to lose the knowledge and have to relearn that we live in a vast cosmos that cares nothing for our small ambitions. And we have been destroyers before. We have poisoned our environment, depleted our resources, turned our technologies against each other in wars that left nothing but ash and radiation, and the slow, patient work of healing that takes generations to complete. We have risen to heights that touch the sky and fallen to depths that nearly ended our story entirely. The difference this time, the thing that makes our moment in history unique, is that we are beginning to remember. We have developed the tools to read the genetic record, to decode the stories written in stone, to map the ocean floors where the ruins of previous worlds might lie hidden. We are learning to recognize the signatures of past civilizations, the subtle traces they left in ice cores and isotope ratios, in impact craters and mass extinctions. For the first time in human history, we have the possibility of learning from the mistakes of our predecessors. We can see the warning signs they missed, understand the forces that brought them down, recognize the patterns that repeat across the cycles of rise and fall. We can choose to be different, to break the cycle, to create something that lasts beyond the next catastrophe. But only if we listen to the warnings the evidence provides, only if we pay attention to the whispers of deep memory that tell us what we once were and what we might become again. Only if we remember that we are not the culmination of history, but part of an ongoing story that began long before us and will continue long after we are gone. The stones remember, the genes remember, the myths remember, and now finally we're beginning to remember too. The question is, what will we do with that memory? Will we use it to avoid the mistakes of the past, or will we repeat them as every previous civilization has done? The Earth is patient. It has watched civilizations rise and fall before. It will watch again, recording everything in its slow, careful script of stone and ice and bone. It will remember us as it has remembered all the others long after our cities have crumbled. Right now, a mysterious object is drifting through our solar system, an interstellar visitor unlike anything we've ever seen. Its name is 3I Atlas, a frozen messenger from the depths of the galaxy, moving at over 60,000 miles per hour, shimmering with the light of distant suns. But what if this isn't just a fragment of the rock and ice? What if it's something far older, a relic of a civilization returning home? Tonight, we journey beyond the boundaries of science and myth, through the origins of stars, the ruins of lost worlds, and the haunting possibility that we are not the first to rise. Let the journey begin. What if the object we call 3I Atlas, the mysterious interstellar visitor hurtling through our solar system, isn't just a fragment of rock or ice but a messenger? What if it's the return of something we once knew, a sign that the first civilization in our galaxy is coming home? The question hangs in the darkness like a star that refuses to fade. For years now, astronomers have been tracking objects that don't belong to our solar system, visitors from the vast emptiness between stars. They arrive without warning, moving through our cosmic neighbourhood with trajectories that defy the gentle orbits of planets and asteroids born here. These interstellar wanderers carry with them the dust of other suns, the chemistry of alien worlds, and perhaps something more, something we haven't yet learned to recognise. 3I Atlas appeared in our telescopes like a whisper from the void. Its designation marks it as the third confirmed interstellar object ever detected passing through our solar system, following the enigmatic Oumuamua in 2017 and the comet Borisov in 2019. But while those earlier visitors sparked wonder and debate, 3I Atlas arrived with a different quality, a strangeness that settled into the minds of those who studied it and refused to leave. There was something about its path, something about the way it moved through space that felt less like chance and more like intention. The discovery came through patient observation, the kind of work that requires watching the same patch of sky night after night, waiting for something to shift against the background of distant stars. When 3I Atlas first revealed itself, it appeared as nothing more than a faint smudge of light, barely distinguishable from the countless other points that populate our telescope's fields of view. But as the observations accumulated, as the measurements refined themselves, a pattern emerged. This object was moving differently. Its velocity carried the unmistakable signature of something that had travelled between the stars, something that had never been bound by our sun's gravity, something that came from somewhere else entirely. The mathematics of orbital mechanics are precise and unforgiving. When an object moves through space, its path tells a story written in the language of gravity and momentum. Objects born in our solar system follow elliptical orbits, bound to the sun in an eternal dance that began billions of years ago, when our planetary system first condensed from a cloud of gas and dust. But interstellar objects move differently. Their trajectories are hyperbolic, open-ended paths that carry them through our system and back out into the galaxy beyond. They are not prisoners of our star. They are travellers, and 3I Atlas was travelling with purpose. What made 3I Atlas unusual wasn't just its interstellar origin. Other objects had already claimed that distinction. What set it apart was the subtle anomalies in its behaviour, the small deviations from predicted paths that accumulated over weeks and months of observation. Astronomers expected it to follow a clean hyperbolic trajectory, accelerated by the sun's gravity as it fell inward, then flung back out into the darkness. But 3I Atlas didn't quite follow that script. There were perturbations, tiny adjustments in its velocity that couldn't be fully explained by gravitational interactions alone. Some suggested outgassing, the release of volatile materials as the object warmed in the sun's light, creating a subtle rocket effect that nudged it off course. This explanation had been invoked for Oumuamua as well, though that earlier visitor had shown no visible signs of a comet's tail, no cloud of dust and gas that should accompany such outgassing. The explanation felt incomplete then, and it felt incomplete now. Others proposed that the object might be tumbling in complex ways, its irregular shape creating unexpected interactions with solar radiation pressure. But the more data that accumulated, the more these conventional explanations seemed to strain against the observations. There were whispers in the astronomical community, quiet conversations that happened in the margins of conferences and in the comment threads of preprint papers. What if 3i Atlas wasn't entirely natural? What if some aspect of its composition or structure was influencing its path in ways that natural processes couldn't fully account for? These weren't mainstream theories, not the kind of ideas that made it into press releases or textbooks, but they persisted nonetheless, circulating among those who had spent enough time staring at the data to notice that something felt wrong, or perhaps more accurately, something felt different. The object itself remained frustratingly difficult to characterize. Even through the most powerful telescopes, 3i Atlas appeared as little more than a point of light, too distant and too small to resolve any surface features or structural details. Spectroscopic analysis revealed hints about its composition, the chemical fingerprints of elements and molecules on its surface, but these measurements were noisy and ambiguous. Was it primarily rocky or metallic? Was it a fragment of a shattered world, or something that had formed intact in the depths of interstellar space? The data suggested possibilities but confirmed nothing. What could be measured with certainty was its trajectory, and that trajectory told a story that grew more intriguing the longer astronomers studied it. 3 Atlas had entered our solar system from a specific direction in the sky, arriving from the general region of the constellation Perseus. Tracing its path backward through space and time, astronomers could estimate where it might have originated, though the uncertainties grew enormous over interstellar distances. It could have been travelling for millions of years, drifting through the galaxy at speeds that would carry it past countless stars before finally arriving here at this moment in our small corner of the cosmos. But what if that arrival wasn't random? What if the timing, the trajectory, the very presence of 3i Atlas in our solar system at this particular moment in human history meant something more than cosmic coincidence? These questions began to take root, not just among fringe theorists, but among serious researchers who understood that the universe was far stranger than our models predicted, that every assumption we made about what was possible and what was natural deserved to be questioned when confronted with something genuinely unprecedented. The name itself carried weight. Atlas. In Greek mythology, Atlas was the titan condemned to hold up the heavens, to bear the weight of the celestial sphere on his shoulders for eternity. He was a figure of immense strength and endurance, a being who stood at the boundary between earth and sky, between the mortal world and the realm of the gods. The astronomers who designated this object 3i Atlas might have chosen the name for purely technical reasons, following the conventions of astronomical nomenclature. But names have power, and this one resonated with meanings that reached far deeper than any technical classification. What if the myths remembered something real? What if the stories of Atlas holding up the heavens preserved some ancient knowledge about visitors from the sky, about objects that came from beyond the known world and carried with them the weight of cosmic significance? Throughout human history, cultures around the world have told stories of beings who came from the stars, who brought knowledge and technology, who promised to return when the time was right. These stories were dismissed as primitive superstition, as the imaginative attempts of pre-scientific peoples to explain natural phenomena they couldn't understand. But what if those stories were memories, distorted by time and retelling, but memories nonetheless? The ancient Greeks weren't the only ones who looked to the sky and saw more than just lights in the darkness. The Sumerians spoke of the Anunnaki, beings who descended from the heavens and taught humanity the arts of civilization. The Egyptians built their pyramids aligned to the stars, their texts filled with references to gods who travelled between earth and sky. The Maya tracked the movements of Venus with obsessive precision, their calendars marking cycles that stretched across millennia, as if they were waiting for something to return. The Hindu Vedas described Vimanas, flying vehicles that carried the gods across the heavens. The Book of Enoch told of watchers, celestial beings who descended to earth and shared forbidden knowledge with humanity. These stories shared common threads that wove through cultures separated by oceans and millennia. They spoke of visitors from above, of knowledge given and then withdrawn, of promises made about return and renewal. They described cycles of time, great ages that rose and fell, civilizations that reached heights of wisdom and power before collapsing back into darkness. And they all suggested that the sky itself was alive with intelligence, that the stars were not just distant suns but waypoints in a vast network of consciousness that stretched across the galaxy. Modern science had largely dismissed these myths as the products of human imagination, as stories we told ourselves to make sense of a universe we didn't yet understand. But what if we had been too quick to dismiss them? What if the ancients had witnessed something real, something that our technological civilization was only now beginning to rediscover? The arrival of interstellar objects like 3I Atlas forced us to confront the possibility that our solar system was not isolated, that we existed within a larger cosmic context where objects, and perhaps intelligences, moved between the stars. The connection between 3I Atlas and the mythological Atlas grew more intriguing the deeper one looked. The Titan Atlas was said to have been punished for his role in the war between the Titans and the Olympian gods, condemned to hold up the sky as eternal penance. But other versions of the myth suggested different interpretations. Some ancient sources described Atlas not as a prisoner, but as a guardian, a being who voluntarily took on the burden of separating heaven and earth, of maintaining the cosmic order. He was associated with astronomy and navigation, credited with creating the first celestial globe, with understanding the movements of the stars and planets in ways that allowed mortals to find their way across land and sea. What if Atlas represented not a person, but a concept, a symbol of something that connected Earth to the heavens? What if the myth preserved the memory of an object or a presence that served as a bridge between our world and something beyond? The image of Atlas holding up the sky could be interpreted as a metaphor for something that maintained a connection, that kept open a pathway between different realms of existence. And if 3I Atlas was named after this figure, perhaps that name was more appropriate than anyone realized. The object continued its journey through our solar system, indifferent to the speculation and wonder it generated. Telescopes tracked its progress, measuring its position against the background stars with ever-increasing precision. Computer models predicted its future path, calculating when it would reach perihelion, its closest approach to the Sun, and when it would eventually exit our solar system, returning to the interstellar void from which it came. But those predictions carried uncertainties, small margins of error that reflected the anomalies in its motion, the subtle ways it deviated from purely gravitational trajectories. Some astronomers proposed sending a mission to 3I Atlas, a spacecraft that could intercept the object and study it up close, perhaps even land on its surface and return samples to Earth. The technical challenges were enormous. Interstellar objects moved at tremendous velocities, far faster than any spacecraft humanity had ever built. Catching up to 3I Atlas would require propulsion systems that didn't yet exist, or at minimum launch windows and trajectories that would take years to execute. By the time any mission could be designed, funded and launched, 3I Atlas would likely be long gone, receding into the darkness beyond Neptune's orbit, beyond the Kuiper Belt, beyond the reach of our most ambitious space probes. But the desire to reach it, to touch it, to understand what it truly was, burned in the minds of those who studied it. Because 3I Atlas represented something more than just scientific curiosity. It represented the possibility of contact, of connection with something beyond our isolated corner of space. If it was indeed artificial, if some aspect of its structure or composition revealed the hand of intelligence, then it would be the first confirmed evidence that we were not alone, that other minds had arisen in the universe and had achieved the capability to send their creations between the stars. The implications of such a discovery would reshape human civilization. Every assumption about our place in the cosmos would need to be reconsidered. Every question about the origin and destiny of intelligence would take on new urgency. If another civilization had existed long enough and grown advanced enough to send objects across interstellar distances, then what had become of them? Were they still out there, watching and waiting? Or had they vanished, leaving behind only these silent messengers drifting through the galaxy like messages in bottles cast into an infinite ocean? The possibility that 3I Atlas might be connected to an ancient civilization, perhaps the first civilization to arise in our galaxy, opened up vistas of speculation that stretched across billions of years of cosmic history. Our galaxy was old, more than 13 billion years by current estimates, formed in the early universe when the first generations of stars began to coalesce from primordial hydrogen and helium. The Sun and Earth were relative latecomers, born only 4.5 billion years ago. That meant there had been billions of years before our solar system even existed. billions of years during which other stars formed, other planets coalesced, and potentially other forms of life and intelligence emerged? What if one of those early civilizations had achieved technological maturity billions of years before humanity even existed? What if they had spread across the galaxy, establishing themselves on countless worlds, building structures and networks that spanned interstellar distances? And what if, after reaching such heights, they had faced some crisis or transformation that caused them to withdraw, to retreat from the galaxy they had once dominated, leaving behind only traces and remnants of their existence? The idea of a first civilization, a progenitor species that arose when the galaxy was young and shaped its development in ways we couldn't yet perceive, had been explored in science fiction for decades. But science fiction was often just speculation running ahead of science, imagining possibilities that might one day be confirmed or refuted by observation and evidence. The arrival of interstellar objects in our solar system, objects that behaved in ways that challenged our understanding of what was natural and what was artificial, suggested that some of those speculative possibilities might deserve more serious consideration. There were theories in astrobiology and the search for extraterrestrial intelligence that addressed this possibility directly. The Fermi paradox asked why, if intelligent life was common in the universe, we hadn't yet detected any clear signs of it. Various solutions had been proposed. Perhaps intelligence was rare, perhaps civilizations destroyed themselves before achieving interstellar capability, perhaps they were deliberately hiding, or perhaps they existed in forms so different from us that we couldn't recognize their presence. But another possibility was that we were looking in the wrong places or at the wrong times, that the evidence of ancient civilizations might not take the form of radio signals or megastructures, but something more subtle, more enigmatic. What if ancient civilizations left behind artifacts that drifted through the galaxy for eons, silent and dormant until they encountered something that triggered their activation? What if 3i Atlas was such an artifact, a probe or marker sent out millions or billions of years ago, programmed to follow certain trajectories, to visit certain star systems, to observe and record and perhaps, under the right conditions, to signal back to its creators that it had found something worth noting? The concept of self-replicating probes, often called von Neumann probes after the mathematician who first formalized the idea, suggested that a sufficiently advanced civilization could explore the entire galaxy using automated spacecraft that traveled from star to star, gathering resources, building copies of themselves, and continuing the expansion indefinitely. Such a strategy would allow a single civilization to establish a presence throughout the galaxy over the course of millions of years, even if they never developed faster than light travel. The probes would be the civilization's eyes and hands, extending their reach across distances that biological beings could never traverse in a single lifetime. If such probes existed, what would they look like? Would they be obviously artificial, gleaming metal constructs bristling with sensors and antennas? Or would they be more subtle, designed to blend in with natural objects, to avoid detection by primitive civilizations that weren't yet ready for contact? A probe disguised as an asteroid or comet could pass through a solar system unnoticed, gathering data and moving on, its true nature hidden beneath a shell of rock and ice. Only careful observation, only detailed analysis of its trajectory and composition might reveal the anomalies that hinted at something more. 3i Atlas exhibited exactly the kind of anomalies that such a disguised probe might display. Its trajectory was almost but not quite natural. Its behaviour was almost but not quite predictable. It was as if something about it was carefully calibrated to appear ordinary, while still retaining some capability for adjustment, some ability to modify its path in subtle ways that natural objects couldn't achieve. The outgassing explanation, the tumbling explanation, all the conventional theories felt like attempts to force the observations into familiar categories to avoid confronting the possibility that we were seeing something genuinely unprecedented. But if 3i Atlas was a probe, if it was artificial, then who had sent it? And more importantly, when? The object's trajectory suggested it had been travelling through interstellar space for an immense period of time. Even at velocities of tens of kilometres per second, crossing the distances between stars required thousands or millions of years. If 3i Atlas had been launched from another star system, it would have begun its journey long before human civilization existed. Perhaps before humanity's ancestors had even descended from the trees, perhaps before complex life had emerged on Earth at all. The implications were staggering. If 3D Atlas was artificial and ancient, then it represented a message from a time so remote that the civilization that created it might no longer exist in any recognizable form. It would be like discovering a message in a bottle that had been floating in the ocean for millions of years, written in a language no one could read, sent by people whose entire world had long since vanished. The message might still be there, encoded in the object's structure or behaviour, but deciphering it would require understanding contexts and references that had been lost to time. Yet the name Atlas suggested something else, something about return rather than mere passage. The Titan Atlas was condemned to his burden, but he endured, he persisted, he remained at his post holding up the heavens through all the ages of the world. What if 3i Atlas wasn't just passing through, but returning, coming back to a place it had visited before, following a cycle that repeated across vast stretches of time? What if our solar system was one stop on a circuit that this object traced through the galaxy, visiting certain stars at certain intervals, checking in on the worlds that orbited them, observing how they had changed since the last visit? The idea of cyclical return appeared throughout human mythology and religion. The concept of eternal return, of time as a circle rather than a line, of history repeating itself in endless cycles of creation and destruction, appeared in ancient Greek philosophy, in Hindu cosmology, in the myths of countless indigenous cultures. The Maya believed in great cycles of time, ages that ended in cataclysm and renewal. The Norse spoke of Ragnarok, the twilight of the gods followed by rebirth and a new beginning. The Hopi described multiple worlds, each one destroyed and replaced by the next as humanity failed to live in harmony with the cosmic order. What if these myths of cyclical time reflected some deeper truth about the universe, some pattern that operated on scales far larger than human history? What if civilizations rose and fell across the galaxy in great waves, each one reaching a peak of development before declining or transforming, making way for the next? And what if the first civilization, the one that arose when the galaxy was young, had established markers and messengers that travelled through space on trajectories timed to return to certain systems at intervals measured in millions of years, checking to see what new forms of life and intelligence had emerged in their absence? If 3 Atlas was such a messenger, then its arrival in our solar system at this particular moment in human history might not be coincidence. Perhaps it had been here before, passing through when Earth was a lifeless ball of molten rock, or when the first single-celled organisms were beginning to metabolize and reproduce in ancient oceans, or when dinosaurs ruled the continents. And now it was returning again, arriving at a time when one of Earth's species had developed technology, had begun to look outward toward the stars, had reached the threshold where it might be ready to receive the message that 3i Atlas carried. But what was that message? If the object was indeed artificial, if it carried information or instructions from its creators, how would we access it? The surface of 3i Atlas, if we could ever examine it up close, might reveal structures or patterns that didn't occur now. If such encounters had occurred, if Earth had been visited by representatives of an ancient civilization at various points in human prehistory and history, then what evidence would we expect to find? The visitors themselves would be long gone, returned to wherever they came from. Any technology they brought would have degraded over millennia, corroded and scattered and lost. But there might be traces, anomalies in the archaeological record, artifacts that didn't fit the expected progression of human technological development, structures that required capabilities beyond what the cultures that built them were supposed to possess. Such anomalies did exist, though their interpretation remained controversial. The Antikythera mechanism, recovered from a shipwreck off the coast of Greece, was a sophisticated astronomical calculator dating to the 2nd century BCE, far more complex than any other known device from that era. The precision of its gears and the sophistication of its design suggested knowledge of astronomy and mechanical engineering that seemed out of place in the ancient world. Conventional explanation held that it represented a peak of Greek technological achievement that was subsequently lost, but it raised questions about what else might have been known and forgotten. The megalithic structures scattered across the world, Stonehenge, the pyramids of Egypt and Central America, the massive stones of Baalbek and Puma Punku, demonstrated engineering capabilities that challenged our understanding of ancient technology. How were stones weighing hundreds of tons quarried, transported, and precisely fitted together using only the tools and techniques that conventional archaeology attributed to these cultures? Various explanations had been proposed, from sophisticated use of simple machines to large labour forces working over extended periods. But the precision of the work, the astronomical alignments, the sheer scale of the undertaking, left room for questions about whether these cultures had access to knowledge or assistance that wasn't reflected in the conventional historical record. These anomalies didn't prove that Earth had been visited by an ancient civilization, but they kept the possibility alive. They prevented the question from being definitively closed. And now, with 3i Atlas passing through our solar system, with its ambiguous nature and its mythologically resonant name, the question took on new urgency. If there was an ancient civilization, if they had visited Earth in the past, if they had left behind myths and legends and perhaps physical traces of their presence, then might 3i Atlas be connected to them? Might it be a probe or marker from that same civilization, still following its programmed trajectory millions of years after it was launched? The concept of the first civilization implied not just temporal priority, but also a kind of cosmic significance. If one civilization had arisen billions of years before all others, if they had spread across the galaxy when it was young and empty, then they would have shaped the development of everything that came after. They might have seeded worlds with the building blocks of life, or protected emerging civilizations from cosmic threats, or established protocols and guidelines that governed how advanced species interacted with primitive ones. They would be, in effect, the elder race, the progenitors, the ones who set the patterns that all subsequent civilizations would follow or rebel against. Science fiction had explored this concept extensively. Arthur C. Clarke's 2001 A Space Odyssey featured mysterious monoliths left by an ancient alien civilization, artifacts that influenced human evolution and eventually led humanity to the stars. The monoliths were inscrutable, their purpose and origin never fully explained, but they served as markers and catalysts, guiding humanity's development according to some vast plan. Other stories featured ancient civilizations that had transcended physical existence, or that had withdrawn from the galaxy to allow younger species to develop, or that had left behind vast networks of technology waiting to be discovered and activated. These fictional scenarios provided frameworks for thinking about what a real first civilization might be like, what traces they might leave, how they might interact with younger species like humanity. But they were just stories, imaginative explorations of possibilities that might or might not reflect reality. The question was whether 3i Atlas represented the transition from fiction to fact, whether we were finally encountering evidence of something that had previously existed only in speculation and myth. The trajectory of 3i Atlas, traced backward through space and time, pointed toward a region of the galaxy that contained thousands of stars, any one of which might have been its origin point. But the uncertainties were enormous. Small errors in measuring the object's current position and velocity propagated backward into huge uncertainties about where it had been millions of years ago. It might have originated from a star system relatively close to our own, or it might have travelled halfway across the galaxy. Without more precise data, without some way to narrow down the possibilities, the question of its origin remained unanswerable. But perhaps the origin didn't matter as much as the destination. If 3i Atlas was artificial, if it was following a programmed trajectory, then what mattered was where it was going, what it was meant to observe or accomplish. And right now it was passing through our solar system, moving through the space where Earth orbited, where humanity had built its civilization, and was beginning to reach outward toward other worlds. If the object was a probe, if it was gathering data and transmitting it back to its creators, then what was it observing? What would it report about us? The thought was both thrilling and unsettling. To be observed by an intelligence far older and more advanced than our own, to be judged by standards we couldn't comprehend, to have our civilization evaluated and found either worthy or wanting. These possibilities touched on deep human anxieties about our place in the universe. We wanted to believe we were special, that our achievements mattered, that our existence had significance beyond the brief flicker of our individual lives. But we also feared that we might be insignificant, that the universe was indifferent to our struggles and aspirations, that we were alone in a vast emptiness that cared nothing for our hopes and dreams. The possibility that 3i Atlas might be a messenger, from the first civilization offered a middle path between these extremes. It suggested that we were not alone, that other intelligences existed or had existed, that the universe was populated with minds that could observe and understand and perhaps even care about what happened to emerging species like humanity. But it also suggested that we were not the centre of the story, that we were latecomers to a galaxy that had been shaped by forces and events that preceded us by billions of years, that our role was to be discovered rather than to discover, to be observed rather than to observe. This reversal of perspective was profound. For centuries, human civilization had been expanding its understanding of the universe, pushing back the boundaries of the known, discovering new worlds and new phenomena. We had been the observers, the explorers, the ones who looked outward and catalogued what we found. But if 3i Atlas was artificial, if it was observing us, then suddenly we were the ones being studied, the ones being catalogued, the ones whose behaviour and development were being recorded and analysed by intelligences we couldn't see or communicate with. The feeling was similar to what ancient peoples must have experienced when they looked up at the stars and imagined gods watching them from the heavens. But this wasn't imagination or superstition. This was a real object detected by real telescopes, following a real trajectory through our solar system. If it was observing us, then the observation was happening right now, in the present moment, using technologies and methods we could only guess at. And if it was transmitting data back to its creators, then somewhere in the galaxy, perhaps light years away, perhaps in a star system we had never observed, perhaps in a form of existence we couldn't comprehend, something was receiving that data and learning about us. What would they learn? What would they see when they looked at Earth through whatever sensors 3i Atlas possessed? They would see a world teeming with life, a biosphere of extraordinary complexity and diversity. They would see a species that had developed technology, that had split the atom and sent machines into space, that had begun to understand the fundamental laws of physics and chemistry and biology. But they would also see a species in crisis, struggling with environmental degradation and resource depletion, divided by conflicts and inequalities, uncertain about its future and its place in the cosmos. Would they judge us harshly for our failures and shortcomings? Or would they remember their own early history, their own struggles and mistakes, and view us with compassion and understanding? Would they see potential in humanity, the possibility that we might overcome our current challenges and eventually join them among the stars? Or would they see us as just another species that would rise briefly and then fall, one more failed experiment in the galaxy's long history of life and intelligence? These questions had no answers, only speculation and hope and fear. But they mattered because they forced us to think about who we were and who we wanted to become. The possibility that we were being observed, that our actions and choices might be recorded and evaluated by an intelligence far greater than our own, gave weight and significance to decisions that might otherwise seem purely local and temporary. If 3 Atlas was watching, if the first civilization was paying attention, then what we did now, in this moment of human history, might echo across the galaxy and down through time in ways we couldn't predict or control. The object continued its journey, indifferent to human speculation and wonder. It followed the laws of physics, responding to gravitational forces and solar radiation pressure, moving along its predetermined path whether anyone was watching or not. But for those who did watch, for the astronomers who tracked its position night after night, for the theorists who tried to model its behaviour, for the dreamers who imagined what it might represent, 3i Atlas had become more than just an object. It had become a symbol, a focal point for humanity's deepest questions about existence and meaning and purpose. As the weeks passed, and 3i Atlas drew closer to perihelion, the intensity of observation increased. Telescopes around the world and in space focused on the object, gathering data across the electromagnetic spectrum. Radio telescopes listened for any signals it might be emitting, any transmissions that might reveal artificial origin. Infrared observations measured its temperature and thermal properties. Spectroscopic analysis searched for unusual chemical signatures. Every available technique was brought to bear on the question of what 3i Atlas truly was. The data accumulated, but clarity remained elusive. Some measurements suggested one interpretation, others pointed in different directions. The object remained stubbornly ambiguous, refusing to fit neatly into either the natural or artificial category. It was as if it existed in a liminal space, neither fully one thing nor the other, or perhaps both simultaneously, depending on how you chose to look at it. This ambiguity was itself significant. If 3i Atlas was artificial, if it was designed by an intelligence that understood how primitive civilizations like humanity would react to its presence, then perhaps the ambiguity was intentional. Perhaps the object was meant to be noticed but not fully understood, to raise questions without providing definitive answers, to serve as a test or challenge for emerging species. Only those civilizations that had developed sufficient technological capability and intellectual sophistication would be able to detect the subtle signs of artificial origin, and only those civilizations that were ready for contact, that had matured beyond their initial xenophobia and fear, would be able to interpret those signs correctly and respond appropriately. This interpretation suggested that 3i Atlas might be a kind of filter or screening mechanism, a way for the first civilization to identify which younger species were ready to join the galactic community and which needed more time to develop. The object's ambiguous nature would ensure that only civilizations that had achieved a certain level of scientific understanding would even recognize it as potentially artificial, and the lack of obvious signals or messages would prevent premature contact with civilizations that weren't yet ready to handle the implications of knowing they weren't alone. If this was true, then humanity's response to 3i Atlas was itself a kind of test. Were we approaching the object with open minds and rigorous scientific methods, or were we dismissing it prematurely because it challenged our assumptions? Were we willing to consider unconventional explanations, or were we clinging to familiar categories because they felt safer? Were we ready to accept that we might not be alone in the universe, or would we retreat into denial and skepticism when confronted with evidence that didn't fit our expectations? These questions applied not just to the scientific community but to humanity as a whole. How would the general public react if it was confirmed that 3i Atlas was artificial? Would there be panic and fear, or wonder and excitement? Would religious institutions see it as a threat to their teachings? Or would they find ways to incorporate the discovery into their existing frameworks? Would governments cooperate to study the object and prepare for possible contact? Or would they compete and conflict, each trying to gain advantage from whatever knowledge or technology might be gleaned? The history of human civilization suggested that the response would be mixed and complicated, that different groups would react in different ways based on their beliefs and interests and fears. But there was also hope that the discovery of artificial origin for 3i Atlas might serve as a unifying force, a reminder that humanity shared a common identity as an emerging species in a galaxy that might be populated with other intelligences. The petty conflicts and divisions that plagued human society might seem less important when confronted with the reality of a cosmos far larger and stranger than we had imagined. As Through Atlas approached perihelion and then began its long journey back toward interstellar space, the window for intensive study began to close. The object would remain visible for months or even years, but it would grow progressively fainter and more difficult to observe as it receded from the Sun. Eventually it would pass beyond the orbit of Neptune, beyond the Kuiper Belt, beyond the heliopause where the Sun's influence faded into the interstellar medium, and then it would be gone, returning to the darkness between stars, continuing whatever journey it had been on for millions of years before it arrived here. But even after it was gone, even after it had vanished from our telescopes and our ability to study it directly, 3i Atlas would remain present in human consciousness. It would be remembered as the object that made us question our assumptions, that forced us to confront the possibility that we might not be alone, that reminded us that the universe was far stranger and more wonderful than our theories predicted. It would become part of human mythology, joining the ancient stories of visitors from the sky, of messengers from the gods, of signs and portents that marked turning points in human history. And perhaps, if the cyclical interpretation was correct, if 3i Atlas was indeed following a trajectory that brought it back to our solar system at regular intervals, then it would return. Perhaps millions of years from now, when humanity had either vanished or transformed into something unrecognizable, when Earth had been reshaped by time and evolution and cosmic events, 3i Atlas would pass through our solar system again. It would observe whatever had become of the species that had watched it so intently during its previous visit. It would record the changes and transmit them back to its creators, adding another data point to a record that stretched across billions of years of galactic history. The thought of such vast timescales, of cycles measured in millions of years, of civilizations rising and falling, while objects like 3i Atlas continued their patient journeys through the galaxy, was both humbling and awe-inspiring. It placed human existence in a context so large that individual lives and even entire civilizations seemed like brief flickers, momentary sparks in an eternal darkness. But it also suggested that those sparks mattered, that they were part of a larger pattern, that the universe itself was engaged in some vast process of observation and memory and perhaps even consciousness. The myths of Atlas holding up the heavens took on their deepest meaning in this context. Atlas was not just bearing a physical burden, but maintaining a connection, keeping open a channel between different realms of existence. He was the axis around which the celestial sphere rotated, the fixed point that allowed the stars to move in their eternal dance. And perhaps 3i Atlas served a similar function, not holding up the physical heavens, but maintaining some kind of connection between the first civilization and the younger species that arose after them, serving as a bridge across time and space, ensuring that the knowledge and memory of what had come before was not entirely lost. If the first civilization still existed, if they had not vanished or transcended or destroyed themselves but had merely withdrawn to some distant corner of the galaxy, or some higher plane of existence, then objects like 3i Atlas might be their way of staying connected to the physical universe they had left behind. The probes would be their eyes and ears, their way of monitoring the development of younger species, of watching to see which ones survived and which ones failed, of gathering data that might inform their own understanding of life and intelligence and the cosmos. And if they were watching, if they were paying attention to what happened on Earth and to how humanity responded to the passage of 3i Atlas through our solar system, then perhaps they were waiting for something. Perhaps they were waiting for humanity to reach a certain level of development, to demonstrate certain capabilities or qualities before they revealed themselves or made contact. Perhaps the arrival of 3i Atlas was itself a signal, a way of saying, "We see you, we know you're there, and when you're ready, we'll be here." The question of readiness was crucial. What would it mean for humanity to be ready for contact with an ancient civilization? It would require more than just technological capability, more than just the ability to detect and study interstellar objects or to send our own probes and spacecraft into the galaxy. It would require a level of maturity and wisdom that humanity had not yet achieved, the ability to think beyond our immediate interests and conflicts, to see ourselves as part of a larger cosmic community with responsibilities and obligations that extended beyond our own species and planet. The challenges facing humanity in the early 21st century, climate change, nuclear proliferation, inequality, environmental degradation, were all tests of our ability to act collectively for the common good, to prioritise long-term survival over short-term gain, to recognise that we shared a common fate on a small planet in a vast universe. If we couldn't solve these problems, if we destroyed ourselves or degraded our world to the point where civilization collapsed, then we would never be ready for contact with an ancient civilization. We would be just another failed species, another cautionary tale in the galaxy's long history of intelligence that arose and then vanished. But if we could solve these problems, if we could find ways to live sustainably on Earth and eventually expand to other worlds, if we could develop the wisdom and maturity to handle the responsibilities that came with advanced technology, then perhaps we would be ready. Perhaps we would be able to meet the first civilization as equals or at least as worthy successors as a species that had proven itself capable of surviving the challenges that destroyed so many others. The passage of 3i Atlas through our solar system might be remembered as a turning point, the moment when humanity first seriously confronted the possibility that we were not alone, that we existed within a larger context of galactic civilization and cosmic history. Whether the object was natural or artificial, whether it was connected to an ancient civilization or just a random fragment of rock and ice, it had already served a purpose by making us think about these questions, by forcing us to consider our place in the universe and our responsibilities to the future. The days after 3i Atlas reached perihelion and began its outward journey brought a strange mixture of frustration and exhilaration to the scientific community. The telescopes had captured their data, the spectrometers had recorded their readings, and now came the painstaking work of analysis and interpretation. But beneath the methodical process of science ran an undercurrent of something deeper, a sense that humanity stood at a threshold, that the passage of this object through our solar system represented more than just another astronomical event to be catalogued and filed away. In laboratories and observatories around the world, researchers pored over the data with an intensity that went beyond professional duty. They were searching for something, though many would have been hard-pressed to articulate exactly what. A sign, a signal, some definitive proof that would settle the question of 3 Atlas's nature once and for all. But the object remained elusive, its secrets encoded in subtle anomalies and ambiguous measurements that could be interpreted in multiple ways depending on one's assumptions and expectations. The debate spilled out of scientific journals and into the public consciousness. News outlets ran stories about the mysterious interstellar visitor, often accompanied by dramatic artist renderings that showed sleek alien probes or ancient artifacts drifting through space. Social media filled with speculation ranging from sober analysis to wild conspiracy theories. Some saw 3I Atlas as proof that aliens were watching us, that we were being evaluated for readiness to join some galactic federation. Others dismissed it as just another rock in space, remarkable only for its interstellar origin, nothing more than cosmic debris cast off from some distant planetary system. But there were those who occupied the middle ground, who recognised that the truth might be more nuanced than either extreme allowed. These were the people who understood that the universe was not obligated to conform to human categories, that something could be both natural and meaningful, that the boundary between random chance and intentional design might not be as clear as we like to believe. They looked at 3E Atlas and saw not just an object but a question, one that challenged humanity to think more carefully about what we meant by intelligence, by communication, by purpose. The historical record of scientific discovery was filled with moments when observations forced a revision of fundamental assumptions. The Earth was not the centre of the universe. Time was not absolute. Space could bend and warp. The universe had a beginning. Each of these revelations had seemed impossible, even absurd, before the evidence became overwhelming. Each had required scientists to abandon cherished beliefs and embrace new paradigms that better fit the observations. Perhaps 3I Atlas represented another such moment, another point where the universe was trying to tell us that our categories and assumptions were insufficient, that we needed to expand our thinking to accommodate possibilities we had previously dismissed. The question of artificial origin was particularly vexing because it touched on deep philosophical issues about the nature of design and purpose. When we looked at a human artifact, a tool, a building, a spacecraft, we recognised it as artificial because we understood the intentions behind it, because we could see how its structure served specific functions that couldn't be explained by natural processes alone. But what if we encountered an artifact created by an intelligence so different from our own that we couldn't recognise the intentions behind it? What if the functions it served were so subtle or so long-term that they didn't appear purposeful to our limited perspective? A probe designed by the first civilization might not look like anything humans would design. It might not have obvious sensors or antennas or propulsion systems. It might be engineered to operate on timescales of millions of years, using principles of physics we hadn't yet discovered, serving purposes we couldn't yet comprehend. It might be designed to appear natural, to blend in with the cosmic background, revealing its true nature only to civilizations that had achieved sufficient sophistication to notice the subtle signs that marked it as artificial. This possibility suggested that the search for artificial origin should focus not on looking for familiar signs of technology, but on looking for patterns that couldn't be easily explained by natural processes, anomalies that persisted despite our best attempts to account for them through conventional mechanisms. The trajectory deviations of 3I Atlas, the subtle perturbations in its motion that couldn't quite be explained by outgassing or radiation pressure, or gravitational interactions. These might be the signatures of something artificial, the fingerprints of design that remained visible even after millions of years of travel through interstellar space. But even if 3I Atlas was artificial, even if it was a probe or marker left by an ancient civilization, that didn't necessarily mean it carried a message intended for humanity. It might be part of a vast monitoring network that, observed countless star systems, gathering data for purposes that had nothing to do with contact or communication. It might be a relic, still functioning according to its original programming long after its creators had vanished or moved on to other concerns. It might be automated to the point where no conscious intelligence directed its actions anymore, just algorithms and subroutines executing instructions that had been encoded billions of years ago. This scenario was in some ways more unsettling than the idea of active observation. It suggested a universe where intelligence could create things that outlasted it by eons, where the artifacts and systems built by long-dead civilizations continued to function with mechanical persistence, carrying out tasks whose original purpose had been forgotten or become irrelevant. It raised questions about what humanity might leave behind if we too vanished. What traces of our existence would persist long after the last human had died? What our own automated systems and space probes might still be doing millions of years from now? The Voyager spacecraft, launched in 1957, were already on trajectories that would carry them out of the solar system and into interstellar space. They would drift through the galaxy for billions of years, long after Earth itself had been consumed by the expanding sun, long after any trace of human civilization had been erased from the cosmos. Each carried a golden record, a message from humanity to any intelligence that might eventually find them, containing sounds and images meant to represent the diversity of life and culture on Earth. But the chances of those records ever being found were infinitesimally small, and even if they were found, the civilization that discovered them would encounter not living humans, but only these fossilized remnants of a species that had existed in the distant past. Was 3i Atlas something similar? A message in a bottle cast into the cosmic ocean by a civilization that had hoped someone might eventually find it, even if that discovery came millions of years after they themselves were gone. The idea was both poignant and profound. The notion that intelligence, once it arose, felt compelled to reach out, to leave some mark of its existence, to assert that it had been here, that it had lived and thought and wondered about its place in the universe. The ancient human impulse to leave marks and messages visible in cave paintings and monumental architecture and written texts might be a universal characteristic of intelligence. The need to say, "I was here," might transcend species and culture, might be a fundamental aspect of consciousness itself. And if that was true, then the galaxy might be filled with such messages, with artifacts and monuments and probes left by civilizations throughout cosmic history, most of them never found, most drifting in the darkness between stars until they were destroyed by collision or radiation, or the eventual heat death of the universe. But some might be found, and when they were found, they would create moments like this one, moments when a younger civilization encountered evidence of something older and perhaps wiser, something that had travelled further along the path of development and left behind traces of its journey. These moments would be rare, separated by vast stretches of time and space, but they would matter enormously to those who experienced them. They would be the points where different threads of cosmic history intersected, where the stories of separate civilizations briefly touched before diverging again into the darkness. The mythological resonances of this idea were powerful. The concept of inheritance, of receiving wisdom and knowledge from ancestors or predecessors, appeared in every human culture. We built on the achievements of those who came before us, learning from their successes and failures, carrying forward their discoveries and insights. What if this process of inheritance operated not just within human history, but across galactic history? What if the first civilization had left behind a legacy that subsequent civilizations could learn from? A repository of knowledge and experience accumulated over billions of years of existence. The ancient library of Alexandria had been conceived as a repository of all human knowledge, a place where the wisdom of every culture and every era would be collected and preserved. Its destruction was mourned as one of the great tragedies of history, the loss of knowledge that could never be fully recovered. But what if somewhere in the galaxy there existed a library far grander than Alexandria, a collection of knowledge accumulated not just from one species, but from countless civilizations that had risen and fallen across cosmic time? What if the first civilization had created such a repository, and what if objects like 3i Atlas were part of the system that maintained and updated it? This speculation led to questions about the nature of knowledge itself, and how it might be preserved across the vast expanses of time and space that separated civilizations. Information encoded in physical media would degrade over millions of years, corrupted by radiation and cosmic rays, eroded by the slow but inexorable processes of entropy. Even the most durable materials would eventually break down, their structures randomized, their information lost. How could knowledge be preserved for billions of years, across timescales that dwarfed the existence of any single civilization? Perhaps the answer lay not in preserving information in static form, but in encoding it in dynamic systems, in patterns that could maintain themselves through active processes rather than passive storage. Life itself was such a system. DNA preserved information across billions of years of evolution, not through static storage, but through continuous replication and error correction, through the constant activity of living cells that read and copied the genetic code. Perhaps an advanced civilization could create artificial systems that operated on similar principles, self-replicating probes that carried information encoded in their design and behavior, that could repair and maintain themselves across cosmic timescales. If 3i Atlas was such a system, then its very existence, its trajectory and behavior, might constitute a form of information storage and transmission. The object itself would be the message, its physical properties and motion through space encoding data that could be read by any civilization with sufficient technological sophistication. The anomalies in its trajectory, the deviations from purely gravitational motion, might not be accidental but intentional, carefully programmed variations that carried meaning to those who knew how to interpret them. This interpretation transformed the scientific study of 3i Atlas from mere observation to an act of potential translation. The researchers analysing the object's motion weren't just measuring an astronomical phenomenon, they were potentially decoding a message from an ancient civilization, reading a text written in the language of orbital mechanics and physics. Every data point, every measurement, every observation might be part of that message, a letter in an alphabet we were only beginning to recognise. But even if this was true, even if 3i Atlas was broadcasting information in its very existence, the message might be incomprehensible to humanity at our current level of development. Imagine trying to teach calculus to someone who had never learned arithmetic, or trying to explain quantum mechanics to someone who believed the world was flat. There were levels of understanding that had to be achieved in sequence, foundations that had to be laid before more advanced concepts could be grasped. Perhaps the message encoded in 3i Atlas required knowledge or perspectives that humanity hadn't yet achieved, mathematical frameworks or philosophical concepts we hadn't yet discovered. This possibility was simultaneously frustrating and hopeful. Frustrating because it meant we might be staring directly at profound truths without being able to recognise them, that the answers to our deepest questions might be right in front of us but beyond our current ability to comprehend. But hopeful because it implied that there was more to discover, that humanity's intellectual journey was far from complete, that we had heights of understanding still ahead of us that would eventually allow us to decode the messages left by elder civilizations. The educational function of such messages would be crucial. If the first civilization wanted to pass on their knowledge to younger species, they would need to do so in ways that guided those species through the necessary stages of development. They couldn't simply hand over advanced technology or profound insights. That would be like giving a child a loaded gun, or a book written in a language they couldn't read. Instead, they would need to create a curriculum, a sequence of discoveries and revelations that built on each other, that led younger civilizations step by step toward greater understanding. Objects like 3i Atlas might be part of that curriculum. Their ambiguity might be intentional, designed to make younger civilizations think and question and debate. The process of studying the object, of wrestling with its anomalies and trying to determine its nature, might be more important than any specific answer. It might be teaching us how to think about the universe in new ways, how to question our assumptions, how to remain open to possibilities we hadn't previously considered. This pedagogical interpretation suggested that the first civilization, if they existed, took their role as elder species seriously. They weren't content to simply exist in isolation, hoarding their knowledge and allowing younger species to struggle blindly toward enlightenment. Instead, they actively worked to educate and guide, creating systems and objects that would appear at appropriate times in the development of emerging civilizations, providing hints and clues and challenges that would push those civilizations toward greater wisdom and capability. The myths of divine teachers and culture heroes took on new meaning in this context. Prometheus bringing fire to humanity, Quetzalcoatl teaching the arts of civilization to the Mesoamericans, Oannes emerging from the sea to instruct the ancient Sumerians. These stories all described beings who came from outside human society and provided knowledge that transformed human existence. What if these weren't just myths, but distorted memories of actual contact with representatives of an elder civilization, beings who had intervened at crucial points in human development to provide guidance and instruction? The prohibition against such intervention, the famous prime directive from science fiction that forbade advanced civilizations from interfering with less developed ones, might not reflect the actual ethics of real elder civilizations. Perhaps they had learned through long experience that some degree of guidance and intervention was beneficial, that younger civilizations left entirely to their own devices too often destroyed themselves or stagnated at primitive levels of development. Perhaps the first civilization had developed sophisticated protocols for intervention that provided just enough help to allow younger species to overcome critical challenges without robbing them of agency or the valuable lessons learned through struggle. If this was true, then human history might be dotted with such interventions, moments when our ancestors received crucial knowledge or assistance that allowed our civilization to advance past bottlenecks that might otherwise have proven insurmountable. The sudden appearance of agriculture in multiple locations around the world, the rapid development of mathematics and astronomy in ancient civilizations, the seemingly inexplicable leaps in technology and understanding that occurred at various points in history. Perhaps some of these had been nudged along by subtle interventions from elder species who watched over emerging civilizations and provided help when it was most needed. But such interventions would need to be subtle, disguised as natural developments or human achievements, so that the receiving civilization would still feel ownership of its progress. Too obvious an intervention would create dependence, would make the younger civilization look always to the elder for answers, rather than developing their own capabilities. The art would be in providing just enough help, just enough guidance to keep the civilization on a productive path, without taking away the struggle and effort that made growth meaningful. 3 Atlas might represent such a carefully calibrated intervention. Its ambiguous nature ensured that humanity would have to work to understand it, would have to develop new capabilities and new ways of thinking to determine its true character. We couldn't simply observe it and know immediately what it was. We had to struggle with the question, debate the possibilities, gather more data, refine our theories. And in that process, we were developing exactly the kind of scientific sophistication and intellectual flexibility that would be needed for eventual contact with elder civilizations. The timing of its arrival was also potentially significant. 3I Atlas appeared in our solar system at a moment when humanity had just developed the technological capability to detect interstellar objects, when we had built telescopes and survey systems powerful enough to spot these rare visitors as they passed through. A century earlier, we wouldn't have seen it at all. A century later, we might have developed enough capability to intercept it, to send a probe to rendezvous with it and study it up close. The object arrived in the narrow window when we could detect it and wonder about it, but not yet fully investigate it. A perfect moment to spark questions and drive the development of new capabilities. Was this timing coincidence? Or had the object been programmed to make itself noticeable at exactly this stage of human development, to arrive when we were ready to ask questions but not yet ready for easy answers? The orbital mechanics required to achieve such precise timing would be extraordinarily sophisticated, requiring the ability to predict the development of civilizations across timescales of millions of years. But perhaps that was exactly the kind of capability the first civilization possessed, the ability to model and predict the evolution of intelligent species, to calculate when they would reach various developmental milestones, to time interventions with precision measured in millions of years. This idea staggered the imagination. It implied a level of understanding of intelligence and civilization that went far beyond anything humanity had achieved. We could barely predict the development of our own society over decades, let alone model the evolution of other species over eons. But an ancient civilization with billions of years of experience, with observations of countless other species going through similar developmental arcs, might have discovered patterns and regularities that allowed such long-term prediction. They might have developed a science of civilizational development as rigorous and predictive as our physics or chemistry. If such a science existed, it would transform our understanding of intelligence and progress. It would suggest that the development of technological civilization followed certain predictable pathways, that there were common challenges every emerging species faced, common bottlenecks and critical points where civilizations either succeeded in overcoming obstacles or failed and declined. The first civilization might have mapped this landscape of developmental possibility, identifying the key moments when intervention could be most beneficial, creating systems that would provide appropriate guidance at each stage. This model of guided development stood in contrast to the more pessimistic interpretations of the Fermi paradox, which suggested that most civilizations destroyed themselves before achieving interstellar capability. Perhaps the paradox was resolved not by universal failure, but by universal guidance. Elder civilizations watching over younger ones, preventing the most catastrophic outcomes, ensuring that a certain percentage of emerging species successfully navigated the dangers of technological adolescence and matured into stable, long-lived civilizations. But such guidance couldn't prevent all failures. Some civilizations would inevitably make choices that led to their destruction despite the best efforts of their watchers. The guidance had to allow for free will, for the possibility of both success and failure, or it would be mere puppetry rather than genuine development. The first civilization might watch with regret as some younger species destroyed themselves, but they would respect the autonomy that made intelligence meaningful, the freedom that allowed for both growth and tragedy. Humanity in the early 21st century stood at exactly such a critical juncture. The challenges we faced, climate change, nuclear weapons, artificial intelligence, biotechnology, all carried the potential for both tremendous benefit and catastrophic harm. We had developed capabilities that could either elevate our civilization to new heights or destroy it entirely, and the choices we made in the coming decades would determine which outcome prevailed. If the first civilization was watching, if 3i Atlas was part of their monitoring system, then they would be observing humanity at this critical moment with keen interest, noting which choices we made and how we handled the responsibilities that came with our newfound powers. The weight of that observation, the sense of being watched and evaluated by an intelligence far greater than our own, could be either paralyzing or motivating. It could make us doubt our own judgment, make us wish for clearer guidance, make us long for the elder civilization to simply tell us what to do, or it could inspire us to rise to the occasion, to prove ourselves worthy of joining the community of advanced civilizations, to demonstrate that humanity deserved to survive and thrive and eventually take its place among the stars. The myths and religious traditions of humanity had long grappled with the idea of divine judgment, of being evaluated by higher powers, of needing to prove oneself worthy of salvation or enlightenment. Perhaps these spiritual frameworks were humanity's way of preparing itself for the moment when such evaluation would become literal, when we would actually be observed and assessed by elder intelligences who would determine whether we were ready for contact and inclusion in the galactic community. But the evaluation wouldn't be based on our adherence to any particular religious doctrine or moral code. The first civilization, having observed countless species across billions of years, would understand that morality and culture took many forms, that there was no single right way to organize a society or structure, a civilization. What they would be evaluating was something more fundamental, our capacity for wisdom, our ability to think long-term, our willingness to cooperate for common goals, our commitment to preserving rather than destroying the precious phenomenon of intelligence and consciousness. These qualities transcended any particular cultural or religious framework. They were the basics of mature civilization, the prerequisites for species that hoped to survive for millions of years rather than flaming out in a brief burst of technological prowess, followed by self-destruction. And they were qualities that could be observed and measured, patterns of behavior that revealed whether a civilization had achieved the stability and wisdom necessary for long-term survival. The study of 3i Atlas and humanity's response to it might itself be part of that evaluation. How did we react when confronted with something ambiguous and potentially revolutionary? Did we approach it with open minds and rigorous methods, or did we retreat into dogma and denial? Did we allow the discovery to inspire cooperation and shared purpose, or did it become another source of conflict and competition? The answers to these questions would reveal much about humanity's readiness for contact with elder civilizations. As months passed and 3 Atlas continued its outward journey, the initial excitement began to fade from public consciousness. The object became old news, replaced in the headlines by more immediate concerns and crises. But in the scientific community, and among those who'd been most deeply affected by its passage, the questions it raised continued to resonate. They had seen something that challenged their understanding of the universe, something that refused to fit neatly into existing categories, something that demanded they think more carefully about what was possible and what was real. For some researchers, 3i Atlas became an obsession, a puzzle they couldn't let go of despite the lack of definitive answers. They continued to analyse the data, searching for patterns and anomalies they might have missed on first examination. They developed new models and simulations, trying to find explanations that could account for all the observations without requiring exotic assumptions. They wrote papers and gave presentations trying to convince their colleagues that the object deserved more attention, more study, more theoretical consideration. Others moved on, filing 3i Atlas away as an interesting anomaly, but one that ultimately didn't change the fundamental picture of the universe. It was an interstellar object with some unusual properties, perhaps worthy of follow-up study if another one appeared, but not something that revolutionized our understanding of the cosmos. They returned to their regular research programs, to studies of exoplanets and galaxy formation and dark matter, to the questions that had occupied them before 3i Atlas appeared and would continue to occupy them after it was gone. But even those who moved on found that something had changed. The universe seemed less empty now, less purely mechanical. The possibility that intelligence might be scattered throughout the galaxy, that ancient civilizations might have left traces and markers and messages, had taken root in the collective consciousness of humanity. We couldn't unknow what 3i Atlas had taught us, that interstellar objects were real, that they passed through our solar system on timescales of years or decades, that the galaxy was more interconnected than we had realized. This new awareness began to influence humanity's approach to space exploration and the search for extraterrestrial intelligence. If interstellar objects were arriving at our solar system with some regularity, then we needed better systems for detecting and studying them. Proposals were developed for dedicated survey telescopes that could spot these visitors earlier, track them more precisely, characterize them more completely. Some researchers advocated for the development of rapid response spacecraft that could be launched to intercept particularly interesting objects, to study them up close before they receded beyond reach. The technical challenges were formidable, but the motivation was clear. Every interstellar visitor was a potential source of information about other star systems, other planetary environments, and potentially other civilizations. We couldn't afford to let them pass through unobserved, to miss opportunities for discovery, because we lack the infrastructure to study them properly. 3i Atlas had been a wake-up call, a reminder that the universe brought gifts to those who were prepared to receive them. The search for extraterrestrial intelligence also evolved in response to 3i Atlas. Traditional SETI programs had focused primarily on detecting radio or optical signals, assuming that advanced civilizations would announce their presence through electromagnetic broadcasts. But 3i Atlas suggested another possibility, that evidence of extraterrestrial intelligence might come not through intentional signals, but through the physical artifacts that civilizations left behind or sent out into the galaxy. This approach, sometimes called artifact SETI, or the search for technosignatures, gained new prominence and funding. Researchers began developing methods for distinguishing artificial objects from natural ones, for identifying the subtle signatures of design that might be visible even in objects that had been engineered to appear natural. They studied the anomalies in 3i Atlas's behaviour, trying to understand what kinds of deviations from natural motion might indicate artificial origin. They considered what kinds of materials or structures would be most durable across interstellar timescales, what designs would be most likely to survive millions of years of travel through space, while still retaining recognisable artificial characteristics. This work required collaboration between astronomers, physicists, engineers, and even archaeologists and anthropologists who understood how to identify the traces of intelligence in ambiguous contexts. It was inherently interdisciplinary, requiring insights from multiple fields to address questions that didn't fit neatly into any single domain. and it forced researchers to think carefully about their assumptions regarding intelligence and technology, to recognise that their intuitions were based on limited experience with a single technological civilization and might not apply to species with radically different evolutionary histories and cultural frameworks. The philosophical implications were equally profound. If advanced civilizations were sending objects through the galaxy, if the cosmos was filled with ancient artifacts and monitoring systems, then intelligence was not a rare and isolated phenomenon, but a persistent feature of the universe. Consciousness had arisen not just once, but many times, and it had achieved capabilities that allowed it to extend its reach across interstellar distances, to leave marks that would persist for billions of years. The universe was not indifferent to mind. It had given birth to mind repeatedly, and those minds had shaped the cosmos in ways we were only beginning to recognise. This realisation offered a kind of cosmic comfort, a sense that humanity was part of something larger and longer lasting than our individual lives, or even our entire civilization. We were threads in a vast tapestry, woven across billions of years of galactic history, connected to other intelligences through the objects and messages that travelled between the stars. Our struggles and achievements mattered not just to us, but to that larger story, to the ongoing experiment of consciousness that the universe had initiated when the first stars formed and the first planets coalesced. But with that comfort came responsibility. If we were part of a larger community of intelligence, even if that community was separated by vast gulfs of time and space, then we had obligations to that community. We needed to ensure that our thread of the tapestry didn't end prematurely, that we survived long enough to contribute our own knowledge and experience to the cosmic repository. We needed to develop our own capabilities for interstellar communication and exploration, to eventually become not just recipients of messages from elder civilizations, but senders of our own messages to younger ones. The vision of humanity's future that emerged from contemplating Three-Eye Atlas was ambitious and inspiring. We would solve our current crises, overcome the challenges that threaten to destroy us, and mature into a stable civilization capable of thinking across timescales of millions of years. We would develop the technology for interstellar travel, sending our own probes and perhaps eventually our own people to other star systems. We would discover other civilizations, some younger than us, and some older, and we would learn from them and teach them in turn. And perhaps, millions of years from now, we would ourselves become an elder civilization, watching over emerging species, sending our own artifacts through the galaxy to guide and inspire. This vision stood in stark contrast to the darker scenarios that often dominated discussions of humanity's future. The fears of environmental collapse, nuclear war, AI catastrophe, or slow decline into barbarism. It offered hope without being naive, acknowledging the challenges we faced while insisting that they could be overcome, that humanity had the potential for greatness if we could find the wisdom and will to realise it. Three-Eye Atlas, whether natural or artificial, whether random or intentional, had become a symbol of that hope. It represented the possibility of contact and connection across the vast distances of space and time that separated civilizations. It suggested that the universe was not empty but filled with intelligence and purpose, that consciousness had a role to play in the cosmic story, that the work of thinking and wondering and striving to understand was not futile, but meaningful in ways that extended far beyond our immediate experience. As the object continued its journey back toward interstellar space, as it grew fainter and more distant with each passing day, those who watched it felt a mixture of sadness and anticipation. Sadness because a rare opportunity was slipping away, because the chance to study this mysterious visitor was coming to an end. But also anticipation, because Three-Eye Atlas had shown that such visitors were possible, that the galaxy sent messengers to those who were ready to receive them. If one interstellar object had appeared, others would follow. And with each new arrival, with each new opportunity for study and wonder, humanity would learn more about the cosmos and our place within it. The myths of return, the ancient promises that the gods would come back, that the golden age would be restored, that the mysteries would finally be revealed, these took on new significance in light of Three-Eye Atlas. Perhaps the promises were true, not in the literal sense that ancient peoples had understood them, but in a deeper sense. Perhaps the universe itself promised that intelligence would not remain isolated, that consciousness would find ways to bridge the gaps between stars, that the work of understanding would eventually connect minds across cosmic distances. Thurukis al-Atlas had passed through our solar system like a word spoken in the darkness, like a sentence in a conversation that had been going on for billions of years. We had caught only a fragment of that sentence, enough to know that something was being said but not enough to understand the full message. But we had heard it, and we had responded by listening more carefully, by building better instruments, by asking deeper questions. And in that response, we had taken our first steps toward joining the conversation, toward adding our own voice to the cosmic dialogue between intelligences separated by space and time. The object receded into darkness, its light fading until it was lost among the countless other points that filled the night sky. But it had left something behind, not a physical trace, but a transformation in human consciousness, a shift in how we thought about ourselves and the universe. We would never look at the stars the same way again. We would always wonder what other objects might be passing through our solar system undetected, what other messages might be waiting for us if we only knew how to look. The sky had become a place of infinite possibility, and 3 Atlas had been our guide into that new understanding. What if it was the first civilization returning? What if the ancient cycle was beginning again, the pattern repeating as it had countless times before? We might never know for certain, but the question itself was enough to change us, to make us reach beyond our current limitations, to inspire us to become something more than we had been. And perhaps that was the real message of 3i Atlas, not any specific information encoded in its structure or trajectory, but simply the reminder that we were part of something larger, that the universe was alive with meaning and purpose, that the work of consciousness mattered across cosmic scales. The first civilization, if they existed, would be watching to see what we did with that reminder. They would be observing whether humanity rose to meet the challenge or fell back into comfortable certainty. They would be noting our choices and our commitments, evaluating whether we were ready to take the next steps toward maturity as a civilization. And 3i Atlas, the silent traveller from distant stars, would carry news of that evaluation back to wherever it was going, adding one more data point to a record that stretched across billions of years of galactic history. The nature of return across deep time. To speak of the first civilization returning required confronting a concept that human minds were not evolved to grasp. Deep time. Not the thousands of years of recorded history, not even the millions of years of human evolution, but the billions of years across which a truly ancient civilization might exist. If the first civilization had arisen when our galaxy was young, perhaps 10 billion years ago, then they had existed for a span of time more than twice as long as Earth itself had been a solid planet. What did return mean across such gulfs of time? What did continuity of identity mean for a civilization that had endured longer than most stars? The human conception of civilization was based on our own brief experience, a few thousand years of written history, perhaps 10,000 years since the agricultural revolution. Even our longest-lasting institutions, our most enduring religions and empires, measured their lifespans in mere centuries or millennia. We had no framework for understanding what a civilization might become after 1 billion years, let alone 10 billion. The changes would be so profound, so total, that the civilization that existed now might bear no recognizable relationship to the one that had begun so long ago. Consider what humanity had become in just a few 100,000 years of existence as a distinct species. We had evolved from small bands of hunter-gatherers in Africa to a global civilization of billions, had developed language and art and science, had split the atom and sent machines to other worlds, and yet, biologically, we were still essentially the same species that had painted caves at Lascaux and carved figurines from mammoth ivory. Our brains were the same size, our bodies the same shape. The real changes had been cultural, technological, social, but even those had occurred within the constraints of human biology and psychology. But a civilization that persisted for billions of years would not remain constrained by its original biology. The first civilization would have had eons to master genetics, to redesign themselves at the molecular level, to transcend the limitations of the flesh that had given birth to their consciousness. They might have uploaded their minds into substrates more durable than biological neurons, encoded their personalities and memories in crystalline matrices or quantum fields that could survive for geological ages without degradation. They might have dispersed themselves across the galaxy, each individual becoming a distributed intelligence spanning multiple star systems, thinking thoughts that took centuries to complete but comprehended scales of space and time that biological minds could never grasp. Or perhaps they had gone further still. Perhaps they had discovered that consciousness itself was a pattern that could be abstracted from any particular physical substrate, that mind was fundamentally a mathematical structure that could be instantiated in multiple forms simultaneously. They might exist now as pure information, as patterns of organization that propagated through the fabric of space-time itself, as conscious fields that permeated the galaxy, like an invisible ocean in which younger civilizations swam without knowing they were immersed in something alive and aware. The physics of such existence remained beyond human understanding, but that didn't make it impossible. 1,000 years ago, no human could have conceived of a computer, of information encoded in the electronic states, of virtual worlds where minds could interact without physical presence. What might be possible with technologies developed over billions of years, with scientific understanding that had mapped every physical law to arbitrary precision, with engineering capabilities that could manipulate matter and energy at the quantum level as easily as humans shaped clay? If the first civilization had achieved such transcendence, then 3 Atlas represented something more complex than a simple probe or monitoring device. It might be an interface, a point of connection between realms of existence so different that direct contact would be impossible. The object's physical form, its rock and ice and whatever else it was made of, might be the tip of something that extended into dimensions of reality that human instruments couldn't detect, that human concepts couldn't describe. We saw a visitor from another star system. They might see a sensory organ, an eye that allowed them to observe the physical universe they had left behind eons ago. This interpretation suggested that the first civilization hadn't so much departed from the physical universe as transcended it, moving into states of being that still maintained some connection to the realm of matter and energy, but were no longer primarily located there. They would be like adults who had grown beyond childhood, but still occasionally visited the playground where they had played, not to return to what they once were, but to remember, to observe, to perhaps guide younger children through the same developmental stages they had once traversed. The concept resonated with mystical and religious traditions from across human cultures. The idea of transcendence, of spiritual evolution toward higher planes of existence, appeared in Buddhism and Hinduism, in Gnosticism and Kabbalah, in indigenous shamanic traditions worldwide. These frameworks described reality as layered, with the physical world being merely the lowest or densest level, and consciousness capable of ascending through progressively more refined states of being. What if these weren't just metaphorical or psychological maps, but actual descriptions of something real, something that advanced civilizations discovered and achieved through technological or evolutionary means? The Tibetan Buddhist concept of the tulku, a being who had achieved enlightenment but chose to return to the physical world to help others, offered a particularly apt parallel. The tulku was not bound by the limitations of ordinary existence but voluntarily adopted them to serve a compassionate purpose. Perhaps the first civilization operated on a similar principle, maintaining connections to the physical universe, not because they needed to, but because they chose to, out of some sense of responsibility or care for the younger civilizations still struggling through the challenges they had long ago overcome. But this raised questions about motivation that were perhaps even more difficult than the technical questions about capability. Why would a civilization that had transcended physical existence care about species like humanity? What would motivate them to maintain monitoring systems, to send probes like 3i Atlas, to watch over the development of beings so far below them in capability and understanding that we might as well be insects? The gulf between the first civilization and humanity would be vastly greater than the gulf between humans and bacteria. What did bacteria matter to us, except when they threatened our health or proved useful for our purposes? Perhaps the answer lay in memory. The first civilization would remember what it was like to be young, to struggle with existence, to face the challenges that threatened to destroy them before they achieved stability. Those memories, preserved across billions of years, might generate a kind of cosmic empathy, a recognition that every form of consciousness was precious because it recapitulated something of their own journey. They might see in humanity a version of themselves as they once were, and that recognition might motivate them to provide the kind of help they wished they had received during their own difficult adolescence as a species. Or perhaps their motivation was more abstract, rooted in values and purposes that had evolved over billions of years into something human minds couldn't recognize as motivation at all. A civilization that old would have had time to contemplate the deepest questions of existence, to develop philosophical and ethical frameworks of extraordinary sophistication, to arrive at conclusions about meaning and purpose that transcended the biological imperatives that drove younger species. They might help younger civilizations not out of empathy or self-interest, but out of commitment to principles so refined that they appeared to us as something like cosmic dharma, the natural order of how consciousness should relate to itself across the universe. The possibility that Three-Eye Atlas was returning implied that the first civilization had visited before, that there was a history of contact stretching back into Earth's past. But what would such contact have looked like? If they had been watching Earth for billions of years, they would have observed its entire history from barren rock to living world. They would have seen the first self-replicating molecules emerge in ancient oceans, watched as single cells evolved into complex multicellular life, observed the explosion of diversity in the Cambrian, witnessed the rise and fall of the dinosaurs, noted the emergence of mammals and primates, and eventually humans. At what point would they have begun to take special interest? When the first neurons fired in the first nervous system, creating the earliest glimmers of subjective experience? When the first primate looked up at the night sky and wondered what those lights were? When the first human stood upright and freed their hands to make tools? When language emerged and humans could share their thoughts, creating culture that could be transmitted across generations? Or only recently, when we developed technology sophisticated enough to detect objects like Three-Eye Atlas and wonder about their nature? Each of these moments represented a threshold, a qualitative change in the complexity and capability of consciousness on Earth. An ancient civilization monitoring the development of life on countless worlds might have developed sophisticated metrics for identifying such thresholds, algorithms for determining when a planet had crossed from one category to another, protocols for how to respond at each stage. Earth might be one of millions of worlds they tracked, each at different stages of development, each requiring different levels of attention and intervention. This suggested not a binary state of contact versus non-contact, but a spectrum of engagement that varied based on the developmental stage of the younger civilization. In Earth's distant past, when life was simple, the engagement might have been minimal. Occasional observations, basic data collection, perhaps subtle adjustments to conditions that would favour the evolution of complexity. As life became more sophisticated, as nervous systems and brains evolved, the attention might have increased, with more frequent monitoring and more detailed study. And now, as humanity approached the threshold of becoming a technological civilization capable of spreading beyond its home planet, the engagement might be entering a new phase, one that required different protocols and raised the possibility of more direct contact. Three-Eye Atlas might be part of that transition, a signal that humanity had been noticed, that we had achieved a level of development that warranted a different kind of attention. The object's ambiguous nature, hovering between natural and artificial interpretations, might be exactly appropriate for this moment. Obvious enough to be detected by our best instruments, strange enough to provoke serious investigation, but not so clearly artificial that it would cause the kind of societal disruption that premature contact might trigger. This gradualist approach to contact made sense from the perspective of a civilization that thought in timescales of billions of years. They wouldn't be impatient, wouldn't force the pace of development, would be willing to wait centuries or millennia for humanity to mature to the point where contact could be productive rather than destructive. From their perspective, a few thousand years was nothing barely worth noting. They could afford to be patient, to let younger civilizations develop at their own pace, intervening only subtly when necessary to prevent catastrophic outcomes or provide crucial hints at key moments. But this raised uncomfortable questions about human agency and autonomy. If the first civilization had been guiding humanity's development for thousands or millions of years, then how much of what we thought of as our own achievement was really ours? Had we developed agriculture and mathematics and science through our own ingenuity? Or had we been nudged toward these discoveries by interventions so subtle we couldn't recognise them? Were we truly free agents shaping our own destiny? Or were we following a path that had been laid out for us by intelligences that knew far better than we did where that path should lead? The question was similar to old theological debates about free will versus divine providence, but with the abstract concept of God replaced by the concrete possibility of an ancient alien civilization. The emotional response was similar too, a mixture of gratitude for guidance and resentment at manipulation, comfort in knowing someone wiser was watching over us, and anger at the implication that we weren't fully in control of our own fate. Perhaps the truth lay somewhere between the extremes. The first civilization might have set up conditions that made certain developments more likely, protecting Earth from asteroid impacts that would have sterilized the planet, ensuring that the sun's output remained stable enough for complex life to evolve, perhaps even seeding the primordial oceans with organic molecules that would kickstart the origin of life. But once those initial conditions were set, they might have stepped back, allowing evolution and history to unfold according to their own logic. The guidance would be at the level of enabling conditions rather than specific outcomes, like a parent who provides a safe environment and educational opportunities but allows their child to make their own choices and mistakes. Under this model, humanity's achievements were genuinely our own, but we had benefited from a cosmic context that was less hostile than it might otherwise have been. The first civilization hadn't told us what to discover or how to organise our societies, but they had ensured we had the time and stability to figure these things out for ourselves. Through Atlas might be their way of checking in, of seeing how we had developed, of determining whether we were ready for the next stage of whatever process they had initiated when they first set up the conditions that would allow Earth to become a living world. This perspective suggested that there might be many Earths, many worlds where the first civilization had established similar conditions and then watched to see what emerged. Most might have produced nothing, or only simple life that never evolved beyond bacterial mats. Some might have developed complex ecosystems but never given rise to intelligence. A few, like Earth, might have successfully produced technological civilizations, and perhaps an even smaller number had gone further, had survived their own crises and matured into stable civilizations that were themselves now part of the network of intelligences that populated the galaxy. This vision implied a kind of galactic ecology, a layered system of civilizations at different stages of development, with the first civilization at the apex, the newest and youngest at the base, and multiple intermediate levels in between. Each level would have responsibilities to the levels below: guidance without interference, observation without control, help without dependence. And each level would have achieved its position by successfully navigating the challenges that destroyed so many others, by making the right choices at critical moments, by developing the wisdom and maturity that allowed them to survive long enough to join the community of elder species. Humanity, in this framework, was an infant civilization, barely aware of the larger context in which we existed. We saw ourselves as alone in the universe because we lacked the capability to detect the more subtle signs of intelligence that surrounded us. We interpreted the silence of the cosmos as evidence of our isolation, when in fact we were being observed and evaluated, our development tracked and analysed by intelligences that had learned long ago to make their presence unobtrusive. Threat Atlas might be one of the first signs visible to us precisely because we had finally developed instruments sensitive enough to detect it, a reward for progress, a hint that there was more to discover if we kept looking and thinking and questioning. But this optimistic vision had to be balanced against darker possibilities. What if the first civilization's interest in younger species wasn't benevolent? What if they monitored developing civilizations not to help them, but to exploit them, to harvest their resources or knowledge, or creativity? What if 3i Atlas was a scout for an invasion, a preliminary survey before the arrival of forces that would colonize Earth and subordinate or destroy humanity? The history of contact between civilizations on Earth offered little comfort. More advanced societies had repeatedly conquered and exploited less advanced ones, justified by ideologies of superiority and manifest destiny. Why would the pattern be different at a galactic scale? The difference perhaps lay in the timescales involved and the resources available. When European powers colonized the Americas, they were motivated by competition with each other, by the need for resources that were scarce in their home territories, by pressures that operated on timescales of years and decades. But a civilization that had existed for billions of years, that had access to the resources of countless star systems, that thought in timescales of millions of years, such a civilization would not be driven by the same desperate competition for scarce resources. they would have achieved a level of abundance that made exploitation of younger species economically pointless. Moreover, a civilization that old would have had billions of years to work through the ethical implications of their actions, to develop moral frameworks sophisticated enough to handle the responsibilities that came with their power. They would have seen the consequences of exploitation and domination, would have observed countless examples of civilizations that destroyed themselves through unchecked aggression, would have learned that cooperation and mutual support led to better long-term outcomes than predation. Their ethics might have evolved beyond anything humans would recognize, but at minimum they would likely have developed strong prohibitions against actions that harmed other forms of consciousness. Unless, of course, they didn't recognize younger species as truly conscious in a morally relevant sense. This was perhaps the most troubling possibility, that the first civilization, having evolved so far beyond their origins, might have lost the ability to see creatures like humans as deserving of moral consideration. We might be to them what insects were to us, vaguely interesting from a scientific perspective, but not beings whose suffering or death mattered in any deep way. They might study us the way we studied ants, with clinical detachment, noting our behaviours and social structures without feeling any obligation to consider our interests or protect our well-being. Yet this seemed inconsistent with the effort implied by sending objects like 3i Atlas across interstellar distances. Why bother monitoring civilizations if you didn't care about them in some way? Even our study of insects involved some level of interest and respect for the forms of life we examined. A civilization sophisticated enough to maintain a galactic monitoring network would presumably have developed frameworks for understanding and valuing. Consciousness in its many forms would have arrived at the conclusion that all forms of awareness were part of the same fundamental phenomenon and deserved protection and support. Perhaps the key was to recognize that benevolent might not be the right word. The first civilization's interest in humanity might not be warm or caring in the way humans understood those terms. It might be more like the interest a gardener took in their garden, a practical concern for maintaining conditions that allowed diverse forms of life to flourish, not out of emotional attachment to any individual plant, but out of commitment to the overall health and beauty of the ecosystem. They might not love us, but they might still work to ensure we had the opportunity to develop and thrive, because that served larger purposes we couldn't yet understand. This utilitarian approach was cold comfort for those who wanted to believe the universe was fundamentally caring, that consciousness was cradled in a cosmos that valued its existence. But it was better than the alternative, a universe actively hostile to intelligence, where older civilizations exploited younger ones without compunction, where survival required constant vigilance against threats from the darkness between stars. At least a gardener wanted their plants to grow, even if the individual flowers didn't matter as much as the overall display. The question of what had happened to civilizations that arose after the first, but before humanity, added another layer of complexity to these speculations. If the first civilization was 10 billion years old, and the universe had continued producing stars and planets throughout that time, then there should have been countless opportunities for other civilizations to emerge. Some might have arisen 8 billion years ago, or 5 billion, or 2 billion, each of them ancient beyond human comprehension, but young compared to the first. What had become of these intermediate civilizations? Had they all followed similar trajectories, evolving and transcending until they joined the first civilization in whatever higher plane of existence they had achieved? Or had some chosen different paths, developing in ways that diverged from the pattern established by the first? There might be a rich ecology of ancient civilizations, each with their own character and capabilities, each occupying different niches in the galactic ecosystem. Some might focus on physical engineering, building megastructures and reshaping star systems. Others might specialize in biological or genetic work, seeding life and guiding evolution across countless worlds. Still others might be primarily devoted to information and knowledge, maintaining vast archives and libraries that preserved the accumulated wisdom of galactic history. 3. Atlas might be part of a system maintained not by one civilization, but by a coalition or network of elder species, each contributing their own capabilities and perspectives to the project of monitoring and supporting younger civilizations. The object might have been designed collaboratively, incorporating technologies and knowledge from multiple sources, representing a collective effort rather than the work of a single species. This would explain some of its strangeness. It wasn't designed according to any one species' logic, but reflected a compromise or synthesis of multiple design philosophies, multiple ways of thinking about what a monitoring probe should be and how it should function. This vision of a galactic community of ancient civilizations working together to maintain and support the emergence of new consciousness across the universe was deeply appealing. It suggested that intelligence, once it matured beyond its violent and competitive origins, naturally evolved toward cooperation and mutual support. It implied that the universe, whatever its physical indifference, had been shaped by conscious effort into something more hospitable to life and mind. The work of billions of years had created an infrastructure of observation and guidance that increased the chances that younger species would survive and thrive. But it also raised questions about why this community remained hidden, why they didn't simply reveal themselves and offer direct assistance to struggling civilizations like humanity. The answer might lie in hard-learned lessons from their own past. Perhaps early attempts at direct contact had gone badly, with younger civilizations becoming dependent on the help of their elders, never developing their own capabilities, because they could always turn to more advanced species for solutions, or perhaps premature contact had caused civilizations to collapse under the psychological weight of knowing how far they had to go, losing the motivation to develop when they realized how inadequate their own achievements were compared to what elder civilizations had accomplished. The protocol of subtlety, of hints and suggestions rather than direct revelation, might have been developed over billions of years of experience with thousands of emerging civilizations. The elder species would have learned what worked and what didn't, would have refined their approaches based on outcomes, would have developed sophisticated theories about optimal intervention strategies. They would know that civilizations needed to struggle, needed to feel that their achievements were their own, needed to develop confidence and capability through successfully meeting challenges. Too much help was as harmful as too little. 3-Psi Atlas represented a point along that carefully calibrated spectrum of revelation, enough to notice if you were looking carefully, strange enough to provoke serious thought, but not so obvious that it removed all doubt or made the answer too easy. It was a test and a gift simultaneously, challenging humanity to develop better capabilities for detection and analysis, while rewarding us with new mysteries to contemplate. The response it generated would tell the elder civilizations much about humanity's readiness for greater contact, about whether we approach the unknown with curiosity or fear, with open minds or closed assumptions. Time itself functioned differently at these scales. For humans, a generation was roughly 25 years. For the first civilization, thinking in terms of billion-year epochs, a generation might be measured in millions of years. The time required for stars to evolve, for planetary systems to fully develop, for life to emerge and evolve to intelligence. From their perspective, human history from the first stone tools to the present day had occurred in the blink of an eye, barely long enough to register as a distinct event. They would observe us the way we might observe time-lapse photography of a flower blooming, watching our entire civilization unfold in a compressed time frame that revealed patterns and structures invisible to us because we were embedded in the moment-to-moment flow. What patterns would they see? Would they recognize in humanity's development a familiar story, one they had witnessed countless times before? Would they note the specific variations that made Earth's history unique? Or would it all blend together into a general category of emerging technological civilization that followed predictable pathways? Would they feel anything like nostalgia when they looked at us, remembering their own origins billions of years ago? Or had they transcended so completely that such emotional responses no longer occurred? Perhaps the most profound change that occurred over billions of years was not technological but psychological. The first civilization might have long ago solved the problem of individual death, might have achieved practical immortality through technology, or evolution, or uploaded consciousness. But they would have had to confront something even more challenging: the problem of memory and identity across timescales longer than any biological brain was designed to handle. Human memory was notoriously unreliable even across a single lifetime. We forgot vast amounts of what we experienced, remembered other things incorrectly, constructed narratives that served our current needs rather than accurately reflecting the past. This wasn't a flaw but a feature. Memory was designed for organisms that lived decades, not eons, and had to prioritize information that was relevant to immediate survival. But for a being that lived millions or billions of years, memory would become an overwhelming burden if all experiences were preserved with equal fidelity. The sheer volume of accumulated experience would be crushing. The first civilization must have developed solutions to this problem, technologies or practices for managing memory, for compressing and storing experiences, for maintaining identity despite changes that would have seemed to completely replace every aspect of their original nature. They might have become beings of layered consciousness, with core memories that defined their essential identity preserved in something like permanent storage, while more recent experiences were processed and integrated through sophisticated systems that decided what to keep and what to forget. Or perhaps they had embraced a more fluid concept of identity, recognizing that the self was not a fixed thing but a process, a pattern that maintained continuity through change rather than despite it. They might have learned to let go of attachment to their past selves, to accept that the being they were now had only the most tenuous connection to the being that had first achieved consciousness billions of years ago. In a sense, they might have died and been reborn countless times, each iteration building on the last but not identical to it. A chain of consciousness that stretched across time like a river that was never the same water, twice but remained recognizably the same river. This perspective offered a different understanding of what it meant for the first civilization to return. They weren't the same beings that had visited Earth in the distant past. Those individuals or iterations of consciousness might be long gone, preserved only in archives or compressed memories. But the current version of the first civilization maintained continuity with those earlier versions, carried forward their knowledge and purposes, continued the work they had begun. The return was less like an individual person coming back, and more like a wave that had travelled across an ocean, not the same water that had left the distant shore, but still carrying the energy and pattern of that original disturbance. Humanity would face similar questions if we survived long enough. Already we grappled with issues of identity in the face of technology. If consciousness could be uploaded to computers, was the upload the same person as the biological original? If someone's body was gradually replaced with synthetic parts, at what point did they stop being human? These questions would only become more pressing as our capabilities grew, as we developed technologies that could radically alter or extend consciousness beyond its biological roots. The first civilization, having lived through billions of years of such transformations, would have answers to these questions, or at least frameworks for thinking about them that were more sophisticated than anything humanity had yet developed. Part of what they might offer to younger civilizations was guidance on these philosophical and existential challenges, help in navigating the transitions that accompanied technological transcendence. They would know from experience what pitfalls to avoid, what choices led to flourishing and what choices led to decline or extinction of consciousness, even if the physical substrate persisted. 3-Sci Atlas might carry encoded within it not just data but wisdom, insights about the nature of consciousness and identity, about how to preserve what was essential while allowing for growth and change, about how to remain recognizably yourself across transformations that would seem to completely alter every aspect of your being. This wisdom couldn't be transmitted directly, couldn't be reduced to instructions or formulas. It had to be learned through experience, through struggling with the questions and discovering the answers in ways that were authentic to each civilization's own nature and circumstances. But hints could be provided, clues that might make the journey less dangerous, signposts that marked paths that others had successfully travelled before. In the end, the question of whether Through-Eye Atlas represented the first civilization returning was inseparable from deeper questions about the nature of identity, continuity, and purpose across deep time. What did it mean to be the same civilization after billions of years? What connected the first consciousness to arise in the galaxy to whatever that consciousness had become after eons of evolution and transformation? The answer couldn't be found in physical continuity, or even in direct memory, but perhaps in commitment to certain values, certain purposes, certain ways of being in the universe that persisted across all the changes. If the first civilization was returning, they were returning not as they once were, but as they had become. Beings of such complexity and capability that we could only glimpse fragments of their nature, could only perceive the tiny portion of their existence that intersected with the physical dimensions we inhabited. Thirsty Atlas was like a fingertip reaching through a two-dimensional plane into a three-dimensional world. The inhabitants of that plane would see only a small circle, would have no concept of the hand and arm and body that extended beyond their perceptual abilities, would struggle to understand what that circle represented or what purposes it served. We were the inhabitants of that plane, and 3i Atlas was the fingertip. Behind it extended dimensions of existence we couldn't perceive, purposes we couldn't fathom, a consciousness so vast and ancient that we related to it the way bacteria related to humans, utterly incapable of comprehending the nature of the intelligence that observed them. But unlike bacteria, we had the capacity to know that we didn't understand, to recognise our own limitations, to ask questions even if we couldn't yet grasp the answers. And that capacity, that self-aware ignorance combined with persistent curiosity, might be exactly what the first civilization was looking for. The sign that humanity was ready to take the first steps toward joining the community of conscious beings that shaped the galaxy's long history. In the end, 3i Atlas was not just an object but a mirror, reflecting back to us our own hopes and fears, our assumptions and aspirations. What we saw in it revealed as much about humanity as it did about the universe, and in choosing how to respond to its passage, in deciding whether to remain open to extraordinary possibilities or retreat into comfortable explanations, we were shaping not just our understanding of this one object, but our entire future as a species. The choice was ours, and the consequences would echo across the stars. What if we're not the first version of civilization? What if humanity has been here before, again and again, each time erased, rebuilt, and forgotten? Think about it for a moment. We look at our world and see progress stretching back a few thousand years. We see Egypt and Mesopotamia, Greece and Rome, the rise of empires and the birth of science. We imagine ourselves at the peak of a long, unbroken climb from caves to cities, from stone tools to smartphones. But what if that story is incomplete? What if the timeline we've been taught is just the most recent chapter in a book that's been written and rewritten more times than we can count? The idea sounds impossible at first. How could entire civilizations rise to greatness and then vanish so completely that we have no memory of them? How could the evidence disappear? How could the knowledge be lost? And yet, when you start looking closely at the myths, the ruins, and the strange gaps in our understanding of the past, a different picture begins to emerge. A picture of cycles, of floods and fires, of worlds that ended and worlds that began again, of humanity climbing toward the light, only to fall back into darkness, over and over like waves breaking on an endless shore. Tonight, we're going to explore that possibility. We're going to walk through the evidence, the stories, the stones, the silences, and ask ourselves whether the world we know might be just one iteration in a series of forgotten ages. We're going to consider the myths that speak of earlier humanities, the ruins that shouldn't exist according to our timelines, and the catastrophes that could erase everything we've built in a matter of days or hours. We're going to look at what science says, what history whispers, and what the Earth itself might be trying to tell us. Because if civilization has been reset before, then everything changes. Our sense of who we are, where we came from, and how fragile our world really is, all of it shifts. And the question becomes not just has it happened before, but when will it happen again? So settle in. Let the world outside fade away. And let's begin at the beginning, or rather, at one of many beginnings, with the stories that have survived the resets carried forward in myth and memory, waiting for us to finally understand what they're trying to say. Every culture on Earth tells a story about a flood, not just any flood, a flood that covered the world, that rose higher than mountains, that drowned cities and forests and entire civilizations beneath its waters. The details change from place to place, but the core remains the same. There was a world before this one, and it ended in water. The most famous version comes from the Bible, of course. Noah and his ark, the rain that fell for 40 days and 40 nights, the animals saved 2 by 2 while the rest of the world perished. But the biblical flood is just one telling of a much older story. Long before Genesis was written, the Sumerians told of Ziusudra, a king who survived a divine flood sent to destroy humanity. The Babylonians had Utnapishtim, who built a great boat and weathered the deluge while the gods wept at what they had done. The Greeks spoke of Deucalion and Pyrrha, the sole survivors of a flood sent by Zeus to cleanse the earth of a corrupt and violent age. And it's not just the Mediterranean world. The Hindus describe a great flood in the Matsya Purana, where Manu, the first man, is warned by a fish, an avatar of Vishnu, to build a boat before the waters come. In China, the legend of Gunyu tells of a catastrophic flood that lasted for generations, reshaping the land and forcing humanity to rebuild from almost nothing. The Hopi people of North America speak of multiple worlds that came before this one, each destroyed when humanity fell out of balance, and the third world, they say, ended in a flood that swallowed everything. The Maya had their own version, recorded in the Popol Vuh. The gods created humanity multiple times, and each time, when the people failed to honor their creators, the world was destroyed. One of those destructions came as a great flood, a resin that fell from the sky and drowned the earth, wiping away the flawed creations so the gods could try again. The Aboriginal peoples of Australia, whose oral traditions stretch back tens of thousands of years, tell of a time when the seas rose and swallowed the coastal lands, forcing their ancestors to flee inland. The Maori of New Zealand speak of Tauhaki, who caused a great flood to punish the wicked. In South America, the Inca remembered a deluge that destroyed the world, leaving only a handful of survivors on the highest peaks of the Andes. These are not isolated stories. They are global. They span continents, cultures, and millennia. And they all say the same thing. There was a world before, and it drowned. Now, the conventional explanation is that these myths reflect local flooding events. Rivers overflowing, tsunamis, storm surges that were so traumatic they became embedded in cultural memory and exaggerated over time. And that makes sense to a point. Floods are terrifying. They're sudden, destructive, and they leave deep scars on the communities they touch. It's natural that people would tell stories about them, and natural that those stories would grow in the telling. But here's the thing. Many of these myths don't describe local floods. They describe global floods, waters that covered the entire earth, mountains submerged, every living thing drowned except for a chosen few. And they describe these events not as natural disasters, but as resets, as the end of one age and the beginning of another, as the destruction of a previous version of humanity. What if they're not exaggerations? What if they're memories? Consider the timeline. The last ice age ended around 12,000 years ago. As the glaciers melted, sea levels rose dramatically, by more than 300 feet in some estimates. Coastlines that had been dry land for millennia were swallowed by the ocean. Entire landscapes disappeared beneath the waves. And where do humans tend to live? Near water, near coasts, near rivers and lakes. If there were civilizations living along those ancient shorelines, cities, settlements, centers of culture and trade, they would have been obliterated, drowned, lost beneath hundreds of feet of water where no archaeologist has ever looked because we assume there's nothing there to find. The flooding wouldn't have been instant, but it wouldn't have been slow either. There's evidence of periods where sea levels rose rapidly, perhaps in catastrophic pulses triggered by the collapse of massive ice dams or ice sheets. Imagine living in a coastal city and watching the ocean rise 10 feet in a single generation, then another 10 feet in the next. Your ports flood, your fields are swallowed, your temples and monuments disappear beneath the surf. You flee inland, carrying what you can, and the world you knew becomes a memory, a story, a myth about a flood that drowned everything. And if that happened 12,000 years ago, what about earlier? The Ice Age wasn't the first time the climate shifted dramatically. There have been other periods of rapid warming and cooling, other times when the seas rose and fell. Could there have been even older civilizations lost in earlier floods, their stories passed down and blended with the more recent catastrophe until they all became one great deluge in the collective memory of humanity? The Greek philosopher Plato wrote about Atlantis, a powerful island civilization that sank beneath the ocean in a single day and night of catastrophe. Most scholars dismiss it as allegory, a moral tale about hubris and divine punishment, but Plato claimed he was recounting a story told to the Athenian lawmaker Solon by Egyptian priests who said their records went back thousands of years further than Greece's. The priest told Solon that the Greeks were like children, remembering only the most recent disasters, while Egypt's records preserved the memory of many destructions, by fire, by flood, by plague, that had wiped out earlier civilizations. What if the priests were right? What if Atlantis wasn't allegory, but a fragment of genuine memory, distorted, mythologized, but rooted in something real? A civilization that existed before the flood, before the ice melted and was lost when the waters came? We'll never know for certain, because the ocean keeps its secrets well. But the myths remain, and they all point to the same conclusion. This is not the first time. Humanity has been here before. We built something, we lost it, and we started again. But the flood is only one kind of reset. There are others, and some of them are even more terrifying. If water is the first great destroyer in human mythology, fire is the second. Across the world, cultures speak of ages that ended not in drowning, but in burning, in flames that fell from the sky, in heat that melted stone, in light so bright it turned day into something unbearable. These stories are less famous than the flood myths, but they're just as widespread, and they suggest that whatever resets civilization doesn't always come from below. Sometimes it comes from above. The ancient Greeks believed in a cyclical view of history, divided into ages of metal, gold, silver, bronze and iron, each one progressively more corrupt and violent than the last. But they also told the story of Phaethon, the son of Helios, the sun god. Phaethon begged his father to let him drive the chariot of the sun across the sky, and Helios reluctantly agreed. But Phaethon couldn't control the horses. The chariot veered too close to the earth, scorching the land, boiling the seas and turning fertile fields into deserts. To stop the destruction, Zeus struck Phaethon down with a thunderbolt, sending him plummeting into a river. The earth was saved, but the damage was done. The story was often interpreted as a myth about youthful arrogance, but what if it was something else? What if it was a memory of the sky itself turning hostile? The Hopi, again, speak of multiple worlds. The first world, they say, was destroyed by fire. Volcanoes erupting, the earth splitting open, flames consuming everything. This second world ended in ice, and the third in flood. Each destruction came because humanity had fallen out of balance, and each time a few people were saved to carry the knowledge forward and begin again. The pattern is clear. The world ends, and the world begins. Over and over. In Hindu cosmology, time is divided into vast cycles called yugas, and at the end of each cycle, the world is destroyed and recreated. One of the forms this destruction takes is fire, specifically the fire of Shiva, the destroyer and transformer, whose dance brings the universe to an end so it can be born anew. The Rig Veda, one of the oldest religious texts in existence, describes cosmic fires and celestial battles that reshape the heavens and the earth. The Norse had Ragnarok, the twilight of the gods, when the world would be consumed by fire and flood simultaneously. The great wolf Fenrir would break free, the serpent Jormungandrs would rise from the ocean, and the fire giant Surtur would set the world ablaze with his flaming sword. After the destruction, the earth would sink into the sea and then rise again, green and fertile, ready for a new age. The Zoroastrians of ancient Persia believed in a final purification by fire, when molten metal would flow across the earth, burning away all impurity and evil, leaving only the righteous to inherit a renewed world. The Maya too spoke of worlds destroyed by fire, including one age where the people were turned into birds and fled into the trees as flames consumed the land. These aren't just poetic metaphors, They're descriptions of catastrophe. And when you start looking at the physical evidence, you find traces of events that could match these stories. Take the Younger Dryas, a period of sudden, dramatic cooling that began around 12,800 years ago and lasted for more than 1,000 years. Just as the Ice Age was ending and the climate was warming, something happened that plunged the Northern Hemisphere back into near-glacial conditions almost overnight. Temperatures dropped, ice sheets advanced again. Megafauna that had survived for millennia, mammoths, saber-toothed cats, giant ground sloths, went extinct in a geological instant. For a long time, scientists couldn't explain what caused the Younger Dryas. But in recent years, a controversial theory has gained traction, the impact hypothesis. The idea is that around 12,800 years ago, a comet or asteroid, or multiple fragments of one, struck the Earth or exploded in the atmosphere above North America. The impacts would have triggered massive wildfires, throwing soot and debris into the atmosphere and blocking out the sun. The sudden cooling would have followed, along with the extinction of the megafauna and possibly the collapse of the Clovis culture, one of the earliest known human societies in North America. The evidence is still debated, but it's compelling. Researchers have found a layer of sediment from that time period containing high concentrations of iridium, a rare element more common in asteroids than on Earth. They've found nanodiamonds which form under extreme heat and pressure. They've found spherules, tiny glassy beads created when rock melts and cools rapidly, the kind of thing you'd expect from an impact or an airburst. And they've found this layer not just in one place, but across North America, Europe, and parts of Asia. If the impact hypothesis is correct, then the myths of fire falling from the sky aren't myths at all. They're memories. Memories of a time when the heavens opened and rained down destruction, when the forest burned and the sky turned black, when the world as people knew it came to an end. But it's not just ancient impacts we need to worry about. The sun itself is a threat. Every so often the sun releases a burst of energy called a solar flare or a coronal mass ejection. Most of the time these events are harmless. Beautiful auroras dancing in the polar skies, nothing more. But occasionally a truly massive flare can strike the Earth's magnetic field with enough force to cause real damage. In 1859, an event called the Carrington Event sent a solar storm so powerful that telegraph systems around the world sparked and caught fire. Operators received electric shocks, papers ignited. Auroras were visible as far south as the Caribbean. If a storm like that hit today, it could fry power grids, destroy satellites, and plunge modern civilization into chaos. Now imagine a solar storm 10 times stronger, 100 times stronger. There's evidence in ice cores and tree rings of solar events in the distant past that dwarf anything we've experienced in recorded history. If one of those storms hit a pre-industrial civilization, one that relied on oral tradition, on fragile records, on knowledge passed from generation to generation, it could have been devastating. Not just physically, but culturally. The people who survived would remember the sky burning, the heat, the light, the destruction, and they would tell their children and their children's children until the memory became myth. Fire from above, fire from the sky, fire that resets the world. And then there's the fire we make ourselves. Not all resets come from nature, some come from us. There's a haunting passage in the Bhagavad Gita, one of the sacred texts of Hinduism, where the warrior Arjuna is given a vision of the god Krishna in his true cosmic form. The description is overwhelming. Thousands of mouths, thousands of eyes, a being of infinite power and terror. And then Krishna speaks of weapons that can destroy entire armies in an instant. Weapons that shine like 1,000 suns, weapons that leave the earth scorched and the survivors wishing they had died. When J. Robert Oppenheimer, the father of the atomic bomb, witnessed the first nuclear test in 1945, he famously quoted the Bhagavad Gita, "Now I am become death, the destroyer of worlds." He saw the connection. He recognized that the ancient text was describing something that sounded disturbingly like a nuclear explosion. And the Bhagavad Gita isn't alone. The Mahabharata, another ancient Indian epic, describes wars fought with weapons called astras, divine weapons of immense power. Some of these weapons are described as releasing blinding light, unbearable heat, and devastation that lingers long after the battle is over. Cities are reduced to ash, rivers boil, the land becomes poisoned, and those who survive suffer from strange illnesses, hair falling out, skin blistering, weakness and death following weeks or months later. Sound familiar? The descriptions are eerily similar to the effects of nuclear weapons. And while mainstream scholars interpret these passages as mythological exaggeration or poetic metaphor, there are those who wonder if something else is going on. What if these texts are describing real events? What if, in some distant age, humanity developed technology advanced enough to destroy itself, and did? There are strange anomalies in the archaeological record that fuel this speculation. In the Indus Valley, at sites like Mohenjo-Daro and Harappa, archaeologists have found layers of vitrified stone, rock that has been melted and fused together by extreme heat. The temperatures required to create vitrification are far higher than anything a normal fire could produce. Some researchers have pointed to this as evidence of ancient nuclear warfare, though mainstream archaeology attributes it to more conventional causes like pottery kilns or natural fires. In the deserts of the Middle East and North Africa, there are vast fields of a glassy substance called Libyan desert glass and trinitite. Libyan desert glass is found scattered across the Sahara, and its origin is still debated. Some say it was formed by a meteorite impact, others by an airburst. Trinitite, on the other hand, is the glassy residue created by the first atomic bomb test in New Mexico. The two substances are remarkably similar. Could ancient desert glass have been created the same way? Then there are the stories. The Bible describes the destruction of Sodom and Gomorrah, cities obliterated by fire and brimstone raining from the sky, leaving the land so poisoned that nothing could grow there. Lot's wife looked back at the destruction and was turned into a pillar of salt. Or was it something else? Radiation sickness, perhaps, or the flash of an explosion so bright it burned her where she stood. The ancient Sumerian texts speak of wars between the gods, battles fought with weapons that shook the earth and split the sky. The Epic of Gilgamesh describes a great cedar forest that was destroyed by fire, leaving the land barren. The Egyptian texts mention a time when the gods fought among themselves and the land was laid waste. What if these weren't gods at all? What if they were people? People with technology we can barely imagine. People who built a civilization so advanced that it could harness the power of the atom, or something even more destructive. And what if, like us, they reached a point where they turned that power against each other? It's not hard to imagine. We've come close ourselves. During the Cold War, the United States and the Soviet Union built enough nuclear weapons to destroy the world several times over. We stood on the brink more than once, and only luck or the courage of a few individuals kept us from pulling the trigger. If we had, what would be left? Cities turned to rubble, forests burned, the atmosphere choked with ash and radiation, and in a few thousand years, After the survivors had rebuilt what they could, what would they remember? Would they have clear records of what happened, or would the truth fade into myth? Would they tell stories of gods who fought in the sky, of weapons that shone like the sun, of a world that ended in fire? The idea that an ancient civilization destroyed itself with advanced technology is, admittedly, speculative. There's no smoking gun, no undeniable proof, but the absence of evidence is not the same as evidence of absence. If a civilization did destroy itself 10,000 years ago, or 20,000, or 50,000, what would remain? Metal corrodes, stone crumbles, cities are swallowed by jungles, deserts, and seas, and if the survivors were few, scattered and traumatized, they might not have the means or the will to preserve the knowledge of what came before. They would start over from scratch, and the old world would become a story, a warning, a myth. And maybe that's what all these myths are. Warnings, echoes of a time when humanity reached too far, built too much, and paid the price. A reminder that the cycle can end not just with floods and fires from the heavens, but with fires we light ourselves. But whether the reset comes from nature or from us, the question remains: how many times has it happened? How many civilizations have risen and fallen before ours? And what evidence might still be out there waiting to be found? If civilizations have been reset before, you'd expect to find traces, ruins, artifacts, something that doesn't fit the timeline we've been taught. And when you start looking, you find exactly that. There are structures scattered across the world that defy easy explanation. Not because they're impossible, clearly they exist, but because they seem too advanced, too precise, too ambitious for the cultures we believe built them. They sit like riddles in stone, challenging our assumptions about what ancient people could and couldn't do. Take Göbekli Tepe in southeastern Turkey. Discovered in the 1990s, it's a massive complex of stone pillars arranged in circles, some weighing up to 20 tons, carved with intricate reliefs of animals, foxes, lions, scorpions, vultures. The site is breathtaking in its artistry and scale. But here's the thing, it's nearly 12,000 years old. That puts it firmly in the Neolithic period, a time when, according to conventional archaeology, humans were just beginning to figure out agriculture. They were hunter-gatherers, living in small mobile groups, with no cities, no writing, no complex social structures. And yet, Göbekli Tepe exists. It would have required hundreds of people working together, coordinating their efforts, quarrying and transporting massive stones, carving them with sophisticated tools. It suggests a level of organization and ambition that shouldn't have been possible, and then, after it was built, it was deliberately buried, filled in with rubble and soil, hidden away, as if someone wanted to erase it from memory. Why? What was Göbekli Tepe? A temple, an astronomical observatory, a monument to something lost, and who built it? The people we think of as primitive hunter-gatherers, or the remnants of an earlier, more advanced culture, trying to preserve something before it was forgotten entirely. Then there's Baalbek in Lebanon. The Roman temple complex there is impressive enough on its own, but beneath the Roman construction lies something even more mysterious. The foundation stones. 3 massive blocks of limestone, each weighing around 800 tons, fitted together so precisely that you can't slide a piece of paper between them. They're called the trilithon, and no one knows how they were moved or placed. The Romans didn't claim to have built them. They built on top of them, suggesting the stones were already ancient when the Romans arrived. 800 tons, To put that in perspective, the largest stones used in the Great Pyramid of Giza weigh around 80 tons. The trilithon stones are 10 times heavier. Modern cranes can lift that much, but only the very largest, and they require careful planning and infrastructure. How did ancient people do it? And more importantly, why? What was so important that it required stones of such impossible size? The same question applies to Sacsayhuaman, the fortress above Cusco in Peru. The walls are made of stones that weigh up to 200 tons, cut and fitted together with such precision that, again, you can't fit a blade between them. These stones aren't rectangular, they're polygonal, with multiple angles and curves, each one unique, each one fitting perfectly with its neighbours like a three-dimensional jigsaw puzzle. The Inca, who controlled the region when the Spanish arrived, said they didn't build Sacsayhuaman. They said it was built by the gods, or by a race of giants who lived before them. The Spanish chroniclers recorded these claims but dismissed them as superstition. Modern archaeologists attribute the construction to the Inca, despite the Inca's own insistence that they didn't do it. But if the Inca didn't build it, who did? And if they did, why don't we find similar construction techniques anywhere else in the Inca Empire? Sacsayhuaman stands alone, an anomaly, a masterpiece of engineering that seems to belong to a different age. Then there are the underwater ruins. Off the coast of Japan, near the island of Yonaguni, divers have found what appears to be a submerged stone structure. Terraces, steps, flat platforms, right angles. Some researchers believe it's a natural formation, shaped by erosion and geological processes. Others argue that it's man-made, a remnant of a civilization that existed when sea levels were lower, before the end of the Ice Age. The debate continues, but the structure remains, silent and enigmatic beneath the waves. Similar formations have been reported off the coasts of India, Cuba, and the Mediterranean. Most are dismissed or ignored, because they don't fit the narrative. If they're real, if they're man-made, then they suggest that people were building complex structures more than 10,000 years ago, during a time when we're told they were barely surviving. And if sea levels rose and drowned those structures, how much else was lost? How many coastal cities, how many harbours and temples and monuments now lie beneath hundreds of feet of water, unseen and unsearched? The problem is that underwater archaeology is expensive and difficult. The ocean is vast and most of it has never been explored. We've mapped the surface of Mars in more detail than we've mapped the floor of our own oceans. If there are ruins down there, ruins of civilizations that existed before the flood, we might never find them. Or if we do, it'll be by accident. And by then, how much will have been lost to time and tide? But it's not just massive stones and submerged ruins. There are smaller anomalies too, artifacts that don't belong. In the 1900s, divers recovering cargo from an ancient shipwreck off the coast of Greece found a corroded lump of bronze and wood. When researchers examined it, they discovered gears. Dozens of interlocking gears, precisely cut, forming a complex mechanism. It's called the Antikythera mechanism, and it's an ancient analog computer used to predict the positions of the sun, moon and planets. It dates to around 100 BCE, and it's so sophisticated that nothing remotely comparable appears in the historical record for another 1,000 years. How did the Greeks build it? Where did the knowledge come from? And if they could build something like that, what else could they do? What other technologies did they possess that we've lost or forgotten? There are other examples. The Baghdad Battery, a clay jar from ancient Mesopotamia that some believe was used to generate electricity. The Piri Reis map, a 16th century chart that appears to show the coastline of Antarctica accurately centuries before Antarctica was officially discovered and at a time when it should have been covered in ice. The dropper stones, mysterious discs found in a cave in China, carved with tiny hieroglyphs that no one has been able to translate. Some of these artifacts are controversial, some are probably misunderstood or misidentified, but taken together, they paint a picture of a past that's more complex, more mysterious than the neat timeline we've constructed. They suggest that knowledge has been lost and found and lost again, that the march of progress isn't a straight line but a cycle, and that we might not be as advanced as we think, or at least not as advanced as we could be if we hadn't forgotten so much. Because that's the thing about resets. They don't just destroy buildings and cities, they destroy knowledge. Libraries burn, scrolls rot, oral traditions fade when the people who carry them die, and within a few generations the past becomes myth, and myth becomes legend, and legend becomes nothing at all. So how much have we forgotten? How much did the people before us know? And how many times have we had to start over, rebuilding from the ruins, rediscovering fire and the wheel, and writing, while the ghosts of the old world watch from the stones we can't explain? One of the strangest things about human history is how recent it all seems. We have cities that are 5,000 years old, writing that goes back maybe 6,000 years, agriculture that started around 10 to 12,000 years ago, and before that, almost nothing. A vast stretch of time, tens of thousands of years, hundreds of thousands of years, where anatomically modern humans existed, but left almost no trace of complex civilization. Homo sapiens has been around for at least 200,000 years, possibly longer. For most of that time, we were hunter-gatherers, living in small groups, following the herds, gathering plants, making tools from stone and bone. And then suddenly, around 12,000 years ago, everything changed. We started farming. We built permanent settlements. We developed pottery, weaving, metallurgy. We created art, religion, government. We built cities and temples and monuments. Civilization exploded into existence, seemingly out of nowhere. Why? The standard explanation is that the end of the Ice Age created favourable conditions for agriculture. The climate warmed, the glaciers retreated, and suddenly there was more arable land, more predictable weather, more resources. People settled down, started planting crops, and the rest followed naturally. But that explanation has always felt incomplete. Humans were just as intelligent 50,000 years ago as they are today. They had the same brains, the same capacity for language and abstract thought and innovation. So why did it take so long for civilization to emerge? Why did we spend nearly 200,000 years as hunter-gatherers and then suddenly, in the blink of an eye, become builders and farmers and priests? One possibility is that we didn't. One possibility is that civilization emerged before, perhaps many times, and was destroyed, and the 12,000-year mark isn't the beginning of civilization, it's the beginning of the current cycle, the latest attempt, the newest chapter in a story that's been told and retold over and over since the dawn of our species. Think about it. If a civilization existed 30,000 years ago, or 50,000, or 100,000, what would remain? Wood rots, fabric disintegrates, even stone erodes given enough time, metal corrodes and crumbles, glass shatters. The only things that last are the hardest materials, certain types of stone, ceramics, maybe some metals in the right conditions, and even those can be buried, scattered, or destroyed by geological processes. And then there's the problem of ice. During the Ice Age, much of the northern hemisphere was covered by glaciers miles thick. Those glaciers moved, grinding everything beneath them into dust. If there were cities in Europe or North America during the Ice Age, they would have been obliterated, scraped away, leaving no trace. The same goes for coastal areas. As we've discussed, sea levels have risen dramatically since the Ice Age ended. If ancient civilizations built their cities near the coasts, and why wouldn't they? Those cities are now underwater, buried under sediment, invisible to us. So the absence of evidence doesn't mean much. We're looking in the wrong places, or we're not looking at all because we assume there's nothing to find. But there are hints, strange gaps in the archaeological record, sudden jumps in technology that don't seem to have any precursor. The appearance of agriculture, for example, is often described as the Neolithic Revolution. But it wasn't really a revolution. It happened independently in multiple places around the world: the Fertile Crescent, China, Mesoamerica, the Andes, within a relatively short span of time. Almost as if people in different parts of the world suddenly remembered how to farm, or were taught by someone who already knew. The same goes for megalithic construction. Around the same time that agriculture appeared, people started building massive stone structures: Göbekli Tepe, the megalithic temples of Malta, the stone circles of Britain and Europe. These structures required knowledge of engineering, astronomy, and social organization. Where did that knowledge come from? Did it develop independently in each place, or was it inherited from an earlier culture, passed down through myth and memory until people were ready to use it again? There's also the mystery of the megafauna extinctions. At the end of the last ice age, dozens of large animal species went extinct. Mammoths, mastodons, giant sloths, saber-toothed cats, dire wolves. The timing coincides with the rise of human populations and the spread of hunting, leading many scientists to conclude that humans hunted them to extinction. But some researchers have questioned this. The extinctions happened very quickly, almost simultaneously across different continents, and they affected species that had survived previous climate changes without issue. Could something else have been involved? A catastrophe that killed not just the animals, but also any human civilizations that existed at the time. And then there are the stories, the myths we've already discussed, the floods, the fires, the wars, all describe worlds that came before this one, worlds that were destroyed. And in many of these myths, the survivors are described as carrying knowledge from the old world into the new. The gods teach humanity how to farm, how to build, how to write. Prometheus brings fire. Quetzalcoatl teaches the Maya agriculture and astronomy. Osiris brings civilization to Egypt. Viracocha does the same in the Andes. What if these gods were people, survivors of the previous cycle, carrying the remnants of their knowledge forward, trying to rebuild? They would have seemed like gods to the people they encountered, people who had lost everything, who were starting over from scratch. And over time, the memory of those teachers would be mythologized, turned into divine figures, until the truth was buried beneath layers of legend. It's a compelling idea, and it fits the pattern we see in the myths: a world that ends, a few who survive, and a slow, painful process of rebuilding. Each time, a little more is lost. Each time, the new civilization starts from a lower baseline, until eventually, the memory of the old world fades entirely, and we're left with nothing but stories. But if that's true, then the silence in the timeline isn't a mystery. It's a scar, a gap left by the resets, by the cycles of destruction and rebirth that have shaped our species since the beginning. And the question becomes, how many scars are there? How many times have we risen and fallen? And are we approaching the next scar, the next silence, the next reset? The thing about resets is that they don't announce themselves. They don't give warnings. They just happen. One day the world is normal. People go about their lives, building and creating and planning for the future. And then, in an instant, everything changes. The ground shakes, the sky darkens, the waters rise, and the world as they knew it ends. We like to think we're safe from that kind of catastrophe. We have technology, science, early warning systems. We can predict earthquakes, sort of. We can track hurricanes and volcanic eruptions. We can see asteroids coming, at least the big ones. But the truth is, we're not as safe as we think. There are threats out there that we can't predict, can't prepare for, and might not even see coming until it's too late. Take supervolcanoes. There are several around the world. Yellowstone in the United States, Toba in Indonesia, the Campi Flegrei in Italy. And when they erupt, they don't just destroy the surrounding area. They change the climate of the entire planet. The eruption of Toba, around 75,000 years ago, is believed to have caused a volcanic winter that lasted for years, dropping global temperatures and pushing humanity to the brink of extinction. Genetic evidence suggests that the human population bottlenecked around that time, dropping to as few as 10,000 individuals. We almost didn't make it. And Toba could erupt again. Yellowstone could erupt. We don't know when, and we don't know how to stop it. If it happens, the ash would block out the sun, crops would fail, and billions of people would starve. Civilization as we know it would collapse, and the survivors would be left to start over in a world that had turned hostile and dark. Then there are asteroid impacts. We've gotten better at tracking near-Earth objects, but we're far from perfect. Most of the asteroids we've catalogued are the big ones, the kind that would cause an extinction-level event if they hit. But there are thousands, maybe millions of smaller asteroids that we haven't found yet. An asteroid just a few hundred meters across could destroy a city. One a kilometer across could trigger a global catastrophe. And if it came from the right angle, or if we simply didn't see it in time, there would be nothing we could do. The Tunguska event in 1908 is a reminder of how vulnerable we are. An asteroid or comet exploded in the atmosphere over Siberia, flattening 2,000 square kilometers of forest. If it had hit a few hours later, it could have destroyed a major city, and we had no warning. We didn't even know it was coming. Then there's the sun. We've already talked about solar flares, but it's worth emphasizing just how dangerous they can be. A direct hit from a massive coronal mass ejection could fry power grids across entire continents. No electricity means no refrigeration, no transportation, no communication, no water pumps, no hospitals. Modern civilization would grind to a halt within days, and unlike an asteroid, we can't deflect a solar storm. We can only watch it come and hope it misses. There are other threats too. Gamma-ray bursts from distant supernovae, capable of stripping away the Earth's ozone layer and bathing the surface in lethal radiation. Rogue planets wandering through the galaxy that could destabilize the orbits of the planets in our solar system. Magnetic pole reversals which happen every few 100,000 years and could leave the Earth temporarily unprotected from cosmic radiation. And then there are the threats we create ourselves. Nuclear war, as we've discussed, but also biological weapons, engineered pandemics, artificial intelligence run amok, environmental collapse. We're very good at building things that could destroy us, and we're not always so good at controlling them. The point is, resets don't require ancient gods or lost civilizations. They can happen naturally at any time, and we might not see them coming. And when they do happen, the results are the same. Cities destroyed, populations decimated, knowledge lost. The survivors are left to pick up the pieces and start over, and within a few generations the old world becomes a myth. So how many times has it happened? How many times has humanity been brought to the brink only to claw its way back? And how many times have we not made it back? How many cycles ended with no survivors, no memory, no trace? We don't know, we can't know, but the evidence suggests that it's happened before and it will happen again. The only question is when. If you step back and look at the big picture, a pattern emerges, not just in the myths and the ruins, but in the very structure of time itself. The earth moves in cycles, the seasons change, the climate shifts, ice ages come and go, each one lasting tens of thousands of years, separated by brief warm periods like the one we're living in now. These cycles are driven by changes in the Earth's orbit and axial tilt, Milankovitch cycles they're called, and they're predictable, at least in the long term. We know that another ice age is coming eventually. We just don't know when. But within those long cycles there are shorter ones. The Sun goes through an 11-year cycle of activity, with periods of high and low solar output. The Earth's magnetic field fluctuates, weakening and strengthening over centuries and millennia. Ocean currents shift, driven by changes in temperature and salinity, and those shifts can trigger rapid climate changes. The Gulf Stream, for example, which keeps Europe warm, could shut down if enough fresh water from melting ice dilutes the North Atlantic. If that happens, Europe could plunge into a mini ice age within a matter of decades. And then there are the cycles we don't fully understand. The rise and fall of civilizations, for example. Empires grow, reach their peak, and then collapse over and over with eerie regularity. The Romans, the Mayans, the Egyptians, the Khmer, the Anasazi, all of them built great civilizations and all of them fell. Sometimes the collapse was gradual, a slow decline over centuries. Other times it was sudden, a matter of decades or even years. And in many cases we still don't know exactly why it happened. Some collapses are clearly linked to environmental factors, droughts, floods, soil depletion. Others seem to be driven by internal factors, political instability, economic inequality, overextension. But there's often a sense that the collapse was inevitable, that the civilization had reached a point of no return, and that no amount of effort could have saved it. The historian Arnold Toynbee studied the rise and fall of civilizations and concluded that they follow a predictable pattern: genesis, growth, breakdown, and disintegration. Each civilization faces challenges, and how it responds to those challenges determines whether it survives or collapses. But eventually every civilization fails. The question is not if, but when. And if individual civilizations follow cycles, why not humanity as a whole? Why not the entire species, rising and falling in great waves, each wave reaching a little higher or a little lower than the last, but always following the same basic pattern? The ancient Greeks believed in the concept of the great year, a cycle lasting thousands of years, at the end of which the planets would return to their original positions and history would begin again. The Hindus believe in the Kali Yuga, the age of darkness and decline, which will eventually give way to a new golden age. The Maya had their long count calendar, which tracked cycles of creation and destruction spanning thousands of years. These aren't just philosophical ideas. They're reflections of a deep human intuition that time is not linear, but circular, that what has happened before will happen again, that the end is also the beginning. And maybe they're right. Maybe we're living in one of many cycles, one of many attempts by humanity to build something lasting, and maybe, like the civilizations that came before us, we're approaching the end of our cycle. The signs are there, if you know where to look. Climate change, resource depletion, political instability, the rise of technologies we don't fully understand and can't fully control. We're pushing the limits of what the planet can sustain, and we're doing it faster than any civilization in history. The question is, will we be different? Will we break the cycle, or will we follow the same path as those who came before us? Will we learn from the past, or will we repeat it? And if we do collapse, what will the next cycle look like? Will the survivors remember us? Will they tell stories about the people who built cities of glass and steel, who flew through the air and spoke across oceans, who reached for the stars and then fell back to Earth? Or will we fade into myth, like Atlantis, like the gods of old, until we're nothing but a whisper in the dark? If civilizations have been reset, before then someone must have remembered. Someone must have carried the knowledge forward, even if only in fragments. In almost every culture, there are stories of wise teachers who appeared after the catastrophe, bringing knowledge and guidance to the survivors. In Egypt, it was Thoth, the god of wisdom, who taught writing and mathematics. In Mesopotamia, it was the Apkallu, the 7 sages who came from the sea and taught humanity the arts of civilization. In Mesoamerica, it was Quetzalcoatl, the feathered serpent, who brought agriculture and astronomy. In the Andes, it was Viracocha, the creator god, who walked among the people and showed them how to build and farm. These figures are always described as coming from somewhere else, from the sea, from the sky, from a distant land. They're always associated with knowledge that seems too advanced for the time, and they're always credited with jump-starting civilization, with taking people from a state of barbarism or ignorance and lifting them up. What if these stories are based on real people? Not gods, but survivors of the previous cycle, carrying the remnants of their knowledge forward. They would have seemed like gods to the people they encountered. People who had lost everything, who were struggling to survive in a world that had been turned upside down. And over time, the memory of those teachers would be mythologized, turned into divine figures, until the truth was buried beneath layers of legend. But the knowledge would remain, encoded in myths, in symbols, in the structures they built. The pyramids, the megaliths, the temples, all of them might be more than just monuments. They might be messages left by the memory keepers, trying to preserve something important for the next cycle. Take the Great Pyramid of Giza. It's one of the most studied structures in the world, and yet it's still full of mysteries. The precision of its construction is astonishing. The base is leveled within a fraction of an inch. The sides are aligned almost perfectly with the cardinal directions. The dimensions encode mathematical constants like pi and the golden ratio. Some researchers believe the pyramid was designed as a kind of time capsule, a repository of knowledge encoded in its measurements and proportions. The same has been said of other ancient structures. Stonehenge, for example, is aligned with the solstices and may have been used as an astronomical observatory. The temples of Angkor Wat in Cambodia are laid out to mirror the constellation Draco as it appeared in the sky thousands of years ago. The Nazca lines in Peru, massive geoglyphs that can only be fully appreciated from the air, may have been a kind of map or calendar, encoding information about the stars and the seasons. And then there are the myths themselves. Joseph Campbell, the great scholar of mythology, argued that myths are not just stories, They're carriers of deep truths, encoded in symbolic language. They preserve knowledge about the human condition, about the cycles of life and death, about the relationship between humanity and the cosmos. And if Campbell was right, then the myths about resets, the floods, the fires, the wars, might be preserving knowledge about real events, real catastrophes that shaped our species. The problem is that we've forgotten how to read the myths. We treat them as entertainment, as primitive superstition, as relics of a less enlightened age. But what if they're more than that? What if they're the last surviving fragments of a much older knowledge, a knowledge that was once common but has been lost and rediscovered and lost again, over and over with each cycle? The memory keepers tried to preserve it. They built structures that would last. They encoded knowledge in stories and symbols. They passed it down through secret societies, mystery schools, priesthoods. But with each reset, a little more was lost. The signal degraded. The message became garbled, until all that remained were fragments, myths that no one believed, ruins that no one understood, symbols that no one could read. And now, here we are, at the end of another cycle, trying to piece it all together, trying to remember what we've forgotten, trying to understand the warnings that were left for us before it's too late. So how many times has civilization been reset? We don't know. We can't know. The evidence is too fragmentary, too ambiguous, too buried beneath the weight of time. But the question itself is important, because it forces us to confront the possibility that we're not as unique as we think, that we're not the pinnacle of human achievement, but just the latest iteration in a long series of attempts, that the story of humanity is not a straight line from caves to cities, but a spiral, circling back on itself, rising and falling over and over. And if that's true, then everything changes. Our sense of progress, our confidence in the future, our belief that we're building something permanent, all of it becomes uncertain. Because if civilizations have been reset before, they can be reset again. And there's no guarantee that we'll survive the next one. But maybe that's the point. Maybe the resets are not punishments or accidents, but part of the natural order. A way for the earth to cleanse itself, to start fresh, to give life another chance. And maybe humanity's role is not to escape the cycle, but to learn from it, to carry the knowledge forward, to become the memory keepers for the next cycle, to leave behind something that will help the survivors rebuild. Or maybe the cycle can be broken. Maybe we can learn from the mistakes of the past, avoid the catastrophes that destroyed the civilizations before us, and build something that lasts. Maybe we can be the ones who finally get it right. But to do that, we have to remember. We have to look at the myths, the ruins, the anomalies, and ask ourselves, what are they trying to tell us? What did the people before us know that we've forgotten? And what can we learn from their mistakes? Because the clock is ticking. The signs are all around us. The climate is changing. The resources are running out. The tensions are rising. And if we're not careful, we'll find ourselves at the end of another cycle, watching the world we built crumble around us, wondering how it all went wrong. And the survivors, if there are any, will tell stories about us. Stories about the people who flew to the moon and split the atom, who built towers that touched the sky, and machines that could think. Stories about the people who had everything and lost it all. And those stories will become myths, and those myths will be forgotten, and the cycle will begin again, unless we break it, unless we remember, unless we learn. There's a story written in our DNA, a story that contradicts everything we think we know, about the smooth, steady progress of human civilization. It's a story of catastrophe, of populations crashing to the edge of extinction, of humanity reduced to a handful of survivors clinging to life in a world that had turned hostile. And it's happened not once, but multiple times. When scientists first began studying human genetics in detail, they discovered something strange, something that didn't fit the narrative of a species that had been steadily growing and expanding for hundreds of thousands of years. They found evidence of what's called a population bottleneck, a moment when the total human population dropped to a tiny fraction of what it had been before. The most famous of these is the Toba bottleneck, which we mentioned earlier. Around 75,000 years ago, something reduced the human population to somewhere between 3,000 and 10,000 individuals. That's it. The entire human species, which had been spread across Africa and possibly into Asia, was reduced to a number small enough to fit into a modern sports stadium. For perspective, that's a smaller population than most small towns. It's fewer people than attend an average high school. And for a period that may have lasted thousands of years, those few thousand people were all that stood between humanity and total extinction. What caused it? The conventional explanation is the Toba supervolcanic eruption in Indonesia, which would have thrown enough ash and sulfur dioxide into the atmosphere to trigger a volcanic winter lasting years, possibly decades. Temperatures would have plummeted. Plant life would have died. Animals would have starved. And humans, already scattered in small groups across a vast landscape, would have been decimated. But here's what's interesting. The genetic evidence suggests this wasn't the only bottleneck. There are signs of other population crashes, other moments when humanity was pushed to the brink. Some geneticists have found evidence of a bottleneck around 900,000 years ago, long before modern humans even existed, that reduced the population of our ancestors to just over 1,000 breeding individuals. The species survived, obviously, but barely, and there are hints of more recent events as well. Localized bottlenecks in specific populations, genetic markers that suggest sudden, dramatic reductions in diversity, the kind of patterns you'd expect to see if entire civilizations were wiped out, leaving only scattered survivors to carry on. Now, here's where it gets really interesting. When a population goes through a severe bottleneck, it doesn't just lose people, it loses genetic diversity. Rare genes, unique traits, variations that might have been useful. All of them can disappear if the individuals carrying them don't survive. The population that emerges from the bottleneck is more homogeneous, more similar to each other, because they're all descended from a very small number of survivors. And when you look at human genetic diversity today, what do you find? We're remarkably uniform. Far more uniform than we should be for a species that's supposedly been around for 200,000 years. Chimpanzees, which live in a much smaller geographic range than humans, have significantly more genetic diversity than we do. So do gorillas. So do many other species that are far less widespread. Why? The most likely explanation is that we've gone through multiple severe bottlenecks, events that killed off most of humanity, leaving only small pockets of survivors to rebuild. And each time it happened, we lost a little more diversity, a little more of what made us varied and adaptable. But we also gained something. We gained resilience. Because the people who survived those bottlenecks weren't random. They were the ones who were smart enough, adaptable enough, lucky enough to make it through. They were the ones who could survive when the world fell apart, and they passed that survival instinct down to us. If you want to understand what a reset looks like, don't just look at humans. Look at everything else that disappeared at the same time. At the end of the last ice age, roughly 12,000 to 10,000 years ago, something extraordinary happened. Across the entire planet, dozens of large animal species, megafauna, went extinct in what appears to have been a geological instant. Mammoths, mastodons, saber-toothed cats, giant ground sloths, dire wolves, short-faced bears, woolly rhinoceroses, giant beavers the size of modern bears, armadillos the size of cars, all gone. These were animals that had survived for millions of years. They had weathered previous ice ages, previous climate shifts, previous environmental changes. They were successful, well-adapted, dominant species, and then suddenly they weren't. The conventional explanation is the overkill hypothesis, that humans, spreading across the continents and becoming more efficient hunters, simply killed them all. We hunted the mammoths to extinction. We wiped out the giant sloths. We were so effective, so destructive, that we eliminated dozens of species in just a few thousand years. And there's some evidence for this. Human kill sites have been found with mammoth bones. We know humans hunted these animals. We know that wherever humans arrived, Australia, the Americas, Madagascar, waves of extinctions followed. But the timeline is problematic. The extinctions didn't happen gradually, as you'd expect if humans were slowly hunting species to extinction over thousands of years. They happened rapidly, almost simultaneously across different continents. Species that had never encountered humans went extinct at the same time as species that had been living alongside humans for tens of thousands of years. In North America, the extinctions were particularly severe. Roughly 80% of large mammal species disappeared. In South America, the number was similar. In Australia, which humans had reached much earlier, the extinctions happened thousands of years before, around 45,000 years ago. But again, they were rapid and devastating. Something doesn't add up. If humans were the sole cause, why didn't the extinctions happen gradually as human populations grew? Why did they cluster around specific time periods? And why did they affect animals that humans didn't even hunt, like giant tortoises and large flightless birds on remote islands? The alternative explanation is that something else happened. Something catastrophic that affected the entire planet. And humans didn't cause the extinctions. We survived them, barely, along with the few other large animals that made it through. Remember the Younger Dryas impact hypothesis? The idea that a comet or asteroid struck the Earth around 12,800 years ago, triggering the sudden cooling period that lasted more than 1,000 years. If that happened, it would explain a lot. The impacts would have triggered massive wildfires, throwing soot and debris into the atmosphere. The sky would have darkened, temperatures would have plummeted, plant life would have died, and herbivores, which depended on that plant life, would have starved. The carnivores that depended on the herbivores would have followed, and the few animals that survived would have been those that were adaptable enough, small enough, or lucky enough to find shelter and food in the chaos. Humans survived. But we weren't unscathed. If the genetic bottleneck evidence is correct, our population crashed. We were reduced to scattered bands, struggling to survive in a world that had become hostile and strange. And when we finally recovered, when we finally started building civilizations again, the megafauna were gone. The world we emerged into was emptier, quieter, smaller than the one that had existed before, and we forgot. We forgot what it had been like to live alongside mammoths and saber-toothed cats. We forgot that there had been creatures so large they could shake the earth when they walked. The memory faded into myth, stories of giants, of monsters, of legendary beasts that our ancestors defeated in the distant past. But the bones remain, scattered across the world, buried in tar pits and frozen in permafrost. The bones of the megafauna remind us that the world was once different, that something happened, that there was a time when everything changed, and most of what existed before was lost. Language is one of the most remarkable things about being human. It's what allows us to share ideas, build cultures, pass knowledge across generations. And when you look at the diversity of human languages, you see thousands of different tongues, each with its own grammar, vocabulary and structure. But here's something strange. Almost all of them can be traced back to a handful of language families, and those families appear to have emerged relatively recently, within the last 10,000 to 15,000 years. Before that, silence, or at least a silence in the linguistic record. We have no idea what languages people spoke before the end of the last ice age, because language doesn't fossilize. It doesn't leave physical traces. It exists only in the minds and mouths of the people who speak it, and when those people die, if they haven't passed it on, the language dies with them. But linguists have noticed something curious. When they trace languages back through time, looking for common roots and ancestral tongues, they keep hitting a wall around the same period, roughly 10,000 to 15,000 years ago. Beyond that point, the connections become fuzzy, speculative, impossible to prove. It's as if language itself was reset. Now that doesn't mean humans before the time didn't have language. Anatomically, modern humans have been around for at least 200,000 years, and we almost certainly had language for most of that time. The capacity for language is hardwired into our brains. It's one of the things that makes us human. But something happened around 12,000 years ago that disrupted the linguistic landscape so completely that almost all traces of older languages were wiped out. What could do that? A population bottleneck, a catastrophe severe enough that only small, scattered groups of humans survived, and the languages they spoke became the ancestors of all modern languages. The diversity that had existed before, the thousands of different tongues that had developed over hundreds of thousands of years, was lost. And the new languages that emerged from the survivors were the foundation of everything that came after. There are a few languages that might be exceptions, a few isolated languages that don't seem to fit into any known family, that appear to be the last survivors of much older linguistic lineages. Basque, spoken in the Pyrenees between France and Spain, is one of them. It has no clear relationship to any other language in Europe or anywhere else. It's a linguistic island, a remnant of something that existed before the Indo-European languages swept across the continent. The same is true of some indigenous languages in the Americas, in Australia, in Papua New Guinea. Languages that seem to stand alone, unconnected to anything else. Are these the last echoes of pre-catastrophe languages, the survivors of linguistic lineages that were otherwise completely erased? We don't know. We can't know, but the pattern is suggestive. And then there's the question of why language evolved in the first place. Modern humans existed for well over 100,000 years before we see any clear evidence of complex symbolic thought, art, music, elaborate tools, jewellery. For most of our history, we seem to have been anatomically modern, but behaviourally archaic. And then suddenly, around 50,000 to 70,000 years ago, something changed. We started creating art. We started burying our dead with grave goods. We started making sophisticated tools and ornaments. What happened? Some researchers call it the Great Leap Forward, or the Upper Paleolithic Revolution, the sudden emergence of modern human behaviour after tens of thousands of years of apparent stagnation. But was it really sudden? Or is it just that the evidence from before that time didn't survive? If there were earlier periods of cultural sophistication, earlier attempts at civilization, they would have been lost in the Toba bottleneck or other catastrophes. We'd only see the evidence from after the most recent reset when survivors started rebuilding. And if language was part of that earlier sophistication, if humans 100,000 years ago spoke languages as complex and rich as the ones we speak today, we'd never know. Because language leaves no fossils. It only survives if it's passed down. And if the chain is broken, if the speakers die without passing it on, the language vanishes as if it never existed. How many languages have been lost? How many words? How many concepts? How many ways of seeing the world existed once and are now gone forever? How much of human thought and culture has been erased by the resets, leaving only fragments and shadows behind? Here's something most people don't think about. If humanity has been reset multiple times, if we've been brought to the edge of extinction and forced to rebuild from almost nothing, that experience would leave scars. Not just physical scars, not just genetic scars, but psychological ones. Patterns of behavior, deep-seated fears, instincts that don't make sense in the modern world but would have been essential for survival in the aftermath of a catastrophe. And when you look at human psychology, you find exactly that. Take our fear of the dark. It's nearly universal. Children are afraid of the dark. Adults are uncomfortable in complete darkness. We have an instinctive wariness of spaces where we can't see, where we don't know what might be lurking. From a modern perspective, this doesn't make much sense. We live in cities with streetlights, homes with electricity. Darkness isn't a threat anymore. But imagine surviving a catastrophe. Imagine living in a world where the sky had darkened with ash, where the sun was obscured for months or years, where the normal cycles of day and night were disrupted. Darkness would have been terrifying. It would have been associated with cold, with hunger, with danger. The people who survived would have been the ones who were most cautious, most afraid, most willing to seek shelter and light. And they passed that fear down to us. The same is true of our fear of sudden loud noises, thunder, explosions, crashes. These trigger an immediate startle response, a spike of adrenaline, a fight or flight reaction. Why? Because in the ancestral environment, sudden loud noises meant danger, an animal attacking, a tree falling, a rock slide. Or if you were living through a catastrophe, the sound of the earth splitting open, of impacts, of destruction. Our fear of heights, our discomfort with instability and uncertainty, our tendency to hoard resources when we feel threatened. All of these could be evolutionary adaptations to surviving in a world that had become hostile and unpredictable. But there's something deeper too. Something that shows up in our myths, our dreams, our collective unconscious. Carl Jung, the psychologist, argued that humans share certain archetypal images and stories, patterns that appear in cultures all over the world, independent of contact or influence. The flood, the fire, the end of the world, the hero's journey, the wise old man or woman who teaches the survivors. Where do these archetypes come from? Jung believed they were part of the collective unconscious, a shared psychological substrate that all humans inherit. But what if they're not abstract symbols? What if they're memories? Not individual memories, but cultural memories, passed down through countless generations, of real events that happened in the deep past. What if the reason every culture has a flood myth is because every culture is descended from people who survived the flood? What if the reason we dream about falling, about being chased, about the world ending, is because those experiences are encoded somewhere in our psychological makeup, remnants of traumas that our ancestors endured. There's a concept in psychology called transgenerational trauma, the idea that trauma can be passed down from parents to children, not just through learned behavior, but through epigenetic changes, alterations in gene expression that can persist for multiple generations. Studies of Holocaust survivors and their descendants have found evidence of this. The children and grandchildren of people who experienced extreme trauma show different stress responses, different patterns of gene expression, even though they never experienced the trauma themselves. If that's true for individual families, could it be true for entire species? Could humanity as a whole be carrying the scars of catastrophes that happened thousands of years ago? Could the anxiety, the fear, the sense of impending doom that so many people feel, even in the absence of immediate threats, be an echo of a time when those fears were justified, when the world really was ending? It's a disturbing thought, but it would explain a lot. It would explain why we're so drawn to apocalyptic stories, why we can't stop imagining the end of the world. It would explain why we build bunkers and stockpile supplies, why we have an instinct to prepare for disaster even when everything seems fine. Because deep down, we remember, not consciously, but in our bones, in our blood, in the ancient parts of our brains that evolved to keep us alive. We remember that the world has ended before. We remember that safety is an illusion. We remember that everything can change in an instant, and we're waiting for it to happen again. Let's talk about why so many ancient cultures were obsessed with the heavens. Everywhere you look, ancient civilizations built structures aligned with astronomical phenomena. The pyramids of Egypt are aligned with Orion's belt. Stonehenge marks the solstices. The temples of Angkor Wat mirror the constellation Draco. The Mayan pyramids align with Venus and other celestial bodies. The Nazca lines in Peru are best viewed from above, as if they were meant to be seen from the sky. Ancient observatories appear in cultures that supposedly had no contact with each other. Yet they all show the same preoccupation with tracking the stars, the planets, the movements of the heavens. Why? What was so important about the sky? The conventional answer is that ancient people used the stars for calendars, for agriculture, for navigation. And that's true, as far as it goes. Knowing when to plant crops, when the seasons would change, when to expect floods or droughts. All of that would have been essential for survival. But it doesn't explain the scale of the effort. It doesn't explain why cultures would invest enormous resources, decades or centuries of labour, into building massive stone structures just to track the movements of celestial bodies. A simple wooden post would work as a sundial. A row of stones would be enough to mark the solstice. You don't need a pyramid. You don't need Stonehenge. Unless the sky wasn't just a calendar. Unless it was something more. Something dangerous. What if ancient cultures were so obsessed with tracking the heavens because they knew that's where the danger came from? What if they were watching for asteroids, for comets, for signs that another catastrophe was coming? Think about it. If your civilization had been destroyed by an impact from space, if you had survived and rebuilt, what would you do? You'd watch the sky. Obsessively. You'd track every celestial object, every anomaly, every change in the patterns you knew. You'd build structures to help you observe, to help you remember, to help you predict, and you'd teach your children to do the same, because forgetting, even for a generation, could mean extinction. The ancient astronomers weren't just priests conducting rituals. They were sentries, watchers, early warning systems for a threat that could appear at any time, without warning, and destroy everything. And there's evidence that they knew more than we give them credit for. The Sumerians had detailed astronomical records that go back thousands of years. They tracked the precession of the equinoxes, a cycle that takes 26,000 years to complete. How? Why? What could they possibly use that information for, unless they were thinking in terms of deep time, unless they were trying to preserve